Netflix, one of the world's largest streaming platforms, relies heavily on AWS for its infrastructure. Certainly, the partnership between Netflix and AWS is a notable example of how cloud computing can transform how businesses operate and scale. Many other well-known companies and startups also use AWS for their services. On that note, if you are looking to become an AWS cloud architect to excel your career, then have a look at AWS Cloud Architect Masters program by Simplilearn. With this certification course, you will learn architectural principles, scalability, security, and key components like S3 and CloudFormation. Become expert in the tools like Amazon EC2, AWS Lambda, Amazon DynamoDB, Amazon CloudFormation, and much more. Our AWS Cloud Architect training is great for beginners. However, AWS recommends at least 1 year of relevant experience before pursuing this program. So hurry up and try your hands on this amazing course. Use discount coupon YTBE15 to get handsome discount. Find the course link in the description box. Listen to what our learners say about our courses.
Finishing the course led to personal recognition and opened the door for even more artificial intelligence projects, and it came with a significant pay raise, might I add.
Hi, I'm Philip. I'm 61 years old, and last year I upskilled with Simplilearn's postgraduate program in cybersecurity. I'm happy to tell you that I was able to clear and pass my CISSP and CCSP certification exams on the first.
Before we begin, consider subscribing to Simplilearn never to miss any updates from us. Over to our AWS experts. If you are looking to learn cloud computing, enroll into Professional Cloud Computing program in Cloud Computing and DevOps by Simplilearn and gain hands-on experience with industry projects. 1 year experience is preferred to grab the course. Find the course link in the description box.
When we talk about networking in AWS, essentially we talk about how you can isolate your resources in the cloud. That's something that is a key concern or key requirement for all the organizations that are moving their workload to the cloud. How do I do that? And you can do it using VPC, the Virtual Private Cloud. We'll take a look at Virtual Private Cloud as well. Then you have something called Elastic Load Balancing, where you can say, I have many applications and I want you to do a load balancing for those applications. And AWS gives you out-of-the-box functionality, a managed service called ELB, Elastic Load Balancing, which will do just that. AWS also has something called Route 53. This is a fully managed, highly available cloud DNS service, and what it does is it basically acts like a phone directory. So you put your IP address and put your website address, and it converts that to the IP address and then brings you to your source, which could be the S3 bucket or your load balance or really anything. Let's go to console and then take a look at this thing. Right now, I am in EC2, and then I am at the load balancers. If I click on the load balancer, I can have two types of load balancer where I have an application load balancer. So think about this. If I am a retail website and I have something like apparel, I have sports, outdoors, all of these sections, and I have a social section as well on my website, and I want load for all these sections to be managed separately. And then what I can do, I can come over here and I can set up some target groups, and then I can distribute my load for all these sections of my website. So essentially, I want to change the load of my traffic, and I want to divert that traffic, and I can do that all from here. And this again is available for HTTP and HTTPS. If you want to do a load balancing at a network LAN like a TCP or SSL, then I'm going to choose the classic load balancer. VPC, or Virtual Private Cloud, again is a place where you can isolate your resources in cloud. This is one of the places where you can use a VPN connection to create an encrypted IPsec tunnel to talk between your data center and your resources and clouds. So your VPC can talk to your resources in your data center, and you can do that by using a customer gateway at your end, your data center end. Then use a virtual private gateway at your cloud end. There are firewalls that you can set up, which are called network access control lists. You have subnets, which is a logical grouping of your resources. So you would have resources who would talk to the internet. You would put that in your public subnet by using Internet Gateway attached to that, or you can have subnets that would not be talking to the internet, but would be talking internally instead. Compute is one of the foundation services of AWS. In fact, I was attending one of the trainings at AWS, and they told us that 73% of total revenue of AWS is through EC2. That's a server in the cloud, a compute in the cloud. So let's look at 4 offerings among many that compute gives us. So the first one is Lightsail. And there are people who love to build their servers, have their databases put on the firewall settings, and then install a lot of things. But then, on the other hand, there are people who simply want something out of the box, and they don't want to provision a server to do everything on end. And they want it for a monthly small price. For all those use cases, we have something called Lightsail, which is one of the newest services launched by AWS, and the plan starts at about $5 a month. And it involves the VM, the storage, the data transfer. You can access search it from the console, and you can have a static IP or DNS management right from the console, and you don't need to worry about it. We'll take a look at it in our demo section. Then we have EC2. So this is where you install any application that you would want. This is essentially the compute in the cloud where they have virtualized your services, and then you can access it anywhere from the world using the internet. They have multiple pricing options: on demand, on reserve, on the spot. So if you have your workload, which you know is going to run for a very long time, 1 year, 2 years, 3 years, you can go ahead, pay up front, reserve that thing, and get 75% off. They have something called Spot Option, where all of the unused capacity that AWS has for compute, they put it on auction. And then you can put your price over there, and then you can probably get close to 90% off. And then it is used for large workloads with huge, huge, huge capacity. If you want to run microservices, you know that is a native support for Docker in the cloud, then ECS is the service that does that. You don't have to install it. You can operate and scale your own cluster in the cloud, and it's all a managed service open to you. Now, let's say you are focused only on writing code. You are a developer, or you want your team to focus only on writing code. You do not want to worry about the infrastructure part of your application. Then AWS Lambda is the service that is the function as a service. So you don't have to worry about the infrastructure at all. AWS simply tells you that you give me the code, you tell me how much memory you are going to need, and all I'm going to bill you for is the time your function is going to take to run in the cloud, and I think it's an amazing thing. If you've heard about the term serverless, this is what serverless is. So we are going to take a look at the demo of this service as well. So let's go back to console and see if we can take a look at EC2. So here I am on the EC2 console, and if you see here, this is my region, and I am in US East, not in Virginia region. Now we are at EC2 dashboard, and let's look at how we can launch an instance. Now before we start, let's take a look at the regions. So I am in US East Northern Virginian region, and these are all the regions that you can choose from. And this is where I'm going to launch my EC2 instance. The first thing that I'm going to do when I'm going to launch my instance on the server in cloud is choose an image, which is known as Amazon Machine Image, AMI. And this is nothing but the software package. So I'll go ahead and I'll choose the default option that I get over here. And you can see that it has the command line tools: Python, Ruby, Perl, Java, Docker, PHP, MySQL. So you could have anything that you want. And then I'll go ahead and I'll select this. Once I have selected this, I'm going to choose my instance type on hardware. And you can see that right now I have a T2.micro, which simply is 3-tier eligible. And the network performance is kind of low to moderate. But if I scroll down, you can see the network performance and everything else goes way up. And then I can go and have a different purpose: compute, memory, FPGA, the graphics, anything that I want. And this is the variety of services you get with AWS. Next step is to configure my install details so I could have one or more instances. This is my networking. So essentially, where do I want to put it? Do I want to put it in my network or the VPC that I have created? Or do you want it in another VPC? VPC is nothing but your isolated cloud, your network inside the cloud. Apart from that, I can put something called advanced details, which is nothing but boot up, JavaScript. So if you want something to run when your EC2 instance is provisioned, when it starts, this is where you are going to put that. So for the purpose of the demo, I'll keep it where it is and move on to the next step, which is storage. So essentially, your hard drive. The root volume is nothing. It is the hard drive where your OS is installed, and then I can add any more hard drives that I want, and then I can change the size of it. If I want it to be encrypted, I can do that as well. So let's keep it simple and move to the next step, which is tags. Now, tags are used for identification purposes. Let's say you have many teams. There's a Java team, a darknet team, and you want to keep track of who is using all the resources. So this is where you can add tags that say name equals darknet team, and this is how you are going to identify who has launched this thing. Next up, we have security groups. These are instance-level firewalls, so firewalls for your server. So typically, if you want to allow an SSH, if you want to allow an HTTPS access, this is where you are going to go to add the firewall rules. And you can put the source as anywhere, which means anyone from the internet can access this thing. Now, I do not want SSH access for everybody, so I just keep it HTTP and HTTPS. The SSH access will be essentially for my people that I want, and that's about it. I go and I'll say review and launch, and we can review all of the settings that we have here over here, and we will simply launch. And now it's going to ask for my keypad. This is now something that is required of me to SSH into this particular instance. And I'll simply say that, yes, I have access to this thing, and it will launch the instance. That's about it. It's as simple as that to launch your EC2 instance in cloud. And if I come on the dashboard, I can see that my instance is being provisioned, and I have all the information I need over here. Then, if I want more information, I can click over here, and I can get all of the information that I want over here. Moreover, I have these status checks. So there are two types of status checks that check the health of the instance. So it will make sure that everything, all of the AWS resources that are required to keep this resource up and running, are running fine. And it will also see if I have something that is not required in my instance. It is also there to make it up and running. Now that our instance is up and running, I can click on it and I can connect using the console. So I don't have to use a command prompt. I can click on the console itself and I can do whatever I want. On the other hand, if I take the IP address and if I go here, there it is. Out of the box, I see my WordPress site up and running. I don't have to do anything. It is right there for me to use, and I can just customize it any which way that I want. Let's see if I can have the SSH window open here, and I can just use the login credentials that I have. There it is. I can simply log into this and start playing around with it. I can also see all the metrics. I can see the networking. I can take a snapshot. I can do pretty much whatever I want. This is something that if you have your own virtual private server in the cloud with all the resources that you need, you can run your small applications on it, you can run your WordPress site on it, you can do so many things. There are so many use cases that you can use Lightsail for. It is one of the most popular compute services that was recently launched. Let's look at Lambda. So we come to compute and then we click on Lambda. This essentially functions as a service. You can see that I already have something that is already there, so let's create a Lambda function. We'll take something that is provided out of the box for us. You just click on this, and then we click on an SNS message. So this is like the messaging service of AWS, Simple Notification Services. And we can enable trigger. The SNS topic is incident response, and let's click on it. Now you can see I can type my function name, so I'll simply say my Lambda function, and the language that I'm choosing, Edge Node.js. I can also have C#, Java, Python, etc. And this is my simple code. And then I have environment variables I can use. I will create a new role, and then I will name my new role my Lambda SNS role. I'll keep everything as it is, and that I would simply say go next. Then I'll create a function. Now, this function would be using some memory, and this function will take some amount of time to execute. That amount of time is what AWS is going to charge me for. I do not get charged for anything else. So here, my Lambda function is ready, and if I click on test, then I can simply say there it is, SNS. Say and test. And it should give me something that says hello from SNS. Let's look at this function, at the detail that we got. If you see here, that is the duration. So it ran for 2.84 milliseconds. And then the billing duration, or the build duration, is 100 milliseconds. The resources configure. So I said that I needed 128 MB of RAM to run this thing, and the maximum memory that I actually used, that this function actually used, was 90 megabytes. So that is all I need to do. I need to upload my code, and then I need to say how much memory I'm going to use, and it can be up to 512 MB. There's only one more limitation that says that our function should not run for more than 5 minutes. Essentially, a microservice would not necessarily run for 5 minutes. If it's running for more than 5 minutes, then it's probably the best idea to break it down into several more functions. We get billed by milliseconds, and the best part is in the first year, you get something like 1 billion milliseconds available in the first year. Go and test this thing. This is one of the most interesting things that you will find. As a developer, as an organization, you want your people to focus on the code. You know how easily you can push your code to production to the customers, and you don't want to worry about infrastructure. So this is one service that is really worth exploring. Let's take a closer look at Lightsail, the newest addition to Compute. Now, this is one of those things which will give you a complete package. It starts at less than $5 a month. So let's create an instance. And right now I am in the Mumbai region, and I can change my region. So let's put it into Virginia. We can pick up our instance image. If I want only OS operating system, I can do that. If I want apps and OS, I can do that as well. So I'll keep it to WordPress. I want to make a WordPress website on my server. I can add any script that I want to fire at the bootstrap. I can also have the SSH keypad that I will use to log in from the console for Lightsail. And then, depending on how many resources I need, I can choose my instance plan, and it goes all the way from $5 a month to $80 a month if I'm running some really heavy-duty application on it. But because I'm only running my WordPress website, I simply need the basic one. Then I am very good with 512 MB RAM, 1 CPU, and 1 terabyte of data transfer. Then I want to name my instance, and I'll keep it the way it is. And here I can change the quantity as well. If I click on it, then that's about it. That's about all I need to do to have my instance up and running. Right now, it is in a pending state. Now, this is something that is really good for the virtual private server. I don't have to worry about EC2 instance. I don't have to worry about security patches. I don't have to worry about the firewalls. It's all available to me in one small box. So all I do is come here, I click a few things, and my instance is up and ready. Let's talk about databases in AWS. There are a host of options to store your data by using multiple database services in AWS. So quickly speaking, you have RDS, the relational database service that supports many engines. Then there's an offering from AWS that is known as Aurora. It is a fully managed MySQL compatible relational database service. Then you have a NoSQL service offered from AWS that is a fully managed service as well. It is called DynamoDB. We are going to take a look at that. Then you have Redshift. That is a petabyte level data warehousing service. Again, it is a fully managed service. Then you have Elasticache. That supports in-memory cache. Two very popular engines such as Memcached and Redis. Then you have a very cool service called Database Migration Service that basically allows you to migrate your database from Oracle to Aurora. You can use the service and then there is no downtime at all when you use this service. So let's take a look at RDS, DynamoDB, Elasticache, and Redshift. So once you're in AWS console, you can see that this is the RDS, and it is a management service, which essentially means that batch upgrade, operating systems installation are all taken care of by AWS. Then what we are responsible for is when we store our data, we have to provide permissions to set up the firewall settings and to allow access for everything. Then, of course, we are responsible for setting up the databases, but the engine is provided by AWS. Then if I click on this thing, let's say, for example, I want to fire my SQL instance, and if I click on this thing, I'll just show you how the high availability as well as the backup is taken care of by AWS. So I'll select my server, my hardware that's based on my workload, and then I can do something called multi-AZ deployment. When I do this, it basically asks if you want to have a master save configuration, a high availability configuration, and when I do that, then yes, I do get copies of my database in the multiple availability zones within the region. And these are synchronized, replicated copies. So in the event of failure, I will automatically be switched on to the other availability zone that has the same copy of my database. So let's quickly add the DB identifier and the username and password. So I'll just call it MySQL for the sake of simplicity. Let me just copy and paste all these. Okay, it doesn't like that. Okay, so it doesn't like my SQL database. And let us copy it all over. And then let's go to the next step. Now, when we go to advanced settings, I'll show you that they have something called backup. And then this backup is automatically provisioned by AWS. And you can see here that there is a maintenance window as well. If I want, I can give a window, then this is where you should take my backup, and the same thing for the maintenance. Now, these are all the things that are taken care of by AWS. And in a traditional environment, we have to do all these things ourselves. So this is the beauty of using AWS, that we don't have to worry about the patches. We don't have to worry about the backup. We don't have to worry about the high availability. It's just configured, and all we have to do is set some security rules, some firewall rules, and some accessibility rules for the users. Coming back to the NoSQL offering of AWS. So this is Amazon DynamoDB. Again, it is a very fast and flexible NoSQL database. So for all of your IoT platforms, for your mobile, for your gaming, this is the AWS service that you are going to use because it is a schemaless database, essentially, where you can have a keypad value and you don't have to worry about whether I'm going to store one value or do I have to store values in all columns as well. It deals in something called read capacity unit and write capacity unit for your read requirement and for your write requirement. And that's how it works. You don't have to worry about the provisioning of resources. It scales automatically. Redshift is a petabyte scale data warehousing solution. And again, it is a managed service, so you don't have to worry about, the OS level or the patches. The same thing goes with Elasticache as well. It supports the very popular Memcache and Redis engines. And it is a fully managed service, so you don't have to worry about management or scaling of all of the memory in these engines. Now, let's look at storage services that AWS offers. Now, storage makes up a very big part of the services that AWS offers in the cloud. They are heavily used by multiple organizations, individuals, consumers around the world. So let's go and look at a few things. So EBS is essentially your block storage, your hard drives. They are low latency. And all of your web servers and your database servers, your analytics engines, they all use EBS, Elastic Block Storage. Let's say you have a requirement to have shared file storage. That is where you are going to use Elastic File Storage. And again, it provides high fault tolerance with consistent latencies, and you pay only for what you use, so you do not have to pre-provision it. Just in the case of EBS, you need to pre-provision it. Then you have S3, a simple storage service and one of the most popular services of AWS, launched way back in 2006. It is secure, it has 11.9's durability, and it scales past tens of trillions of objects, and it has many, many use cases. Most importantly, for storage, backup, and recovery. Tiered archiver. We're going to look at a demo of that thing, and it also acts like a data link for big data analytics. Now, if we have something called cold data that we want to keep for our audit records or some archival records, AWS has something called Glacier that is very, very economical archival service. The rates start as low as like 4 cents a gigabyte, which is very, very cheap. You also have something called Storage Gateway, where you apply this virtual device to your data center, and then you can store all data through this storage gateway in the cloud. This is one of the very popular services in the hybrid environment, where you want to keep some data in the cloud and some data in your data center. There are a host of data transfer services which help you move your data to cloud, and it can go from a small amount of data that you can transfer over the internet to exabytes of data that you can transfer through truck to AWS storage services. So you have something called Data Connect, where you connect directly to AWS regional data transfer. You bypass the internet, and then your network is connected. Then you have something called Snowball, which is like a box where you migrate petabytes of data in batches to the cloud. Then you have something called Snowmobile, where you migrate exabytes of data in batches to the cloud. And they will simply send a truck to your data center, you plug it in, the truck will roll into AWS data center, and then they will put data anywhere you want. So let's also take a look at Kinesis Firehose as well. So you have these Kinesis streams and you have ingestion process, streaming data, your IoT data, your mobile data, your Twitter feed, the clickstream data. These are the things you can use Kinesis to store and process all of that data. This is where you would come in AWS services, AWS console to request Snowball. These are all the things that AWS gives you to transfer your data. Again, your data is secure, it's encrypted, it's addressed in transit, and you can access it anywhere using the internet. Let's look at S3 in AWS Management Console. S3 is a place which is used for data leaks, for any sort of data that you would want to upload in cloud. I can very easily go and I can create a bucket, so let's create a bucket. Bucket is where you are going to store your data. All right, so I have created Albert Simplilearn Lab Bucket, and if I click on it, I can do so many things over here. I can upload any data that I want over here. I can send the permissions of who all can access this data by default. In AWS, it's a shared responsibility model. So I can upload the data and I can choose who can access this data in S3. There are so many things that I can do with this bucket. That is my folder in the cloud, S3. That is Simple Storage Service. I can enable versioning, so I can keep all the versions of my objects over here. I can set up logging. I can set up a static website hosting. We will have a demo for this static website hosting as well, but we don't have to worry about this killing the load balancing, etc. It just scales automatically. I did mention that it's a great tool for disaster recovery, and what you can do is you can set up your backups, your snapshots in S3. You can put all your data in S3. You can simply enable the cross-region replication. So what happens is that, let's say you are in US East 1 or Northern Virginia region, and you want to set the cross-region replication to Oregon or maybe somewhere in Europe. You can just come over here and you can enable the cross-region replications. So what happens is AWS will automatically replicate your data from one region to another of your choice. You decide where you want your data to be replicated. AWS will not do so on its own. There are so many types of things that you can do. You can tag everything. You can give permissions to all your people. There are so many types of permissions that you can give. There is an access control list. You can set up a bucket policy. It's also tightly integrated with identity and access management, so you can very easily command who is able to access your bucket. Apart from that, there are some really interesting things. There is something called lifecycle. Now, this is a tiered storage. So normally, whenever you get data, typically that data is going to be very hot. So you would define the data or classify the data as a hot data, warm data, or cold, depending on how frequently it is accessed. Then you would normally have a tiered storage. So S3 has 4 classes. That's standard storage, and infrequent access storage, reduced redundancy storage, where you would put normally reproducible data, and archival storage, that is Glacier. So what you normally do whenever you get some data, you would keep it in a standard, and you would know over a period of time you would want to move that into an infrequent storage, like over here. So I will say that move this data into infrequent storage, which offers the same security, same durability, but it's a lot cheaper. Okay, and then after that, I can also add a data that I want to move into Archive, which is Glacier, after some time. So we can add it to Glacier after 60 days, and if I just click on Next, this is where I will see it. And then I can also delete that object after whatever the amount of time that I would want, and I click on it. You see here that I have set up a transition rule that says that for the current version of the object, anything that I add to this S3 bucket, I want to transition all those objects automatically to standard infrequent access class. And then I will be charged lesser than what I've been charged now. And then I also want to transition to Amazon Glacier. That is my archival service after 60 days. I do not want to delete them ever. So these are the things that you can do with the S3. You also have a lot of analytics tools, which allow you to see who is accessing your data, what data you have, who is adding a lot of data, and these are all available to you at a very economical rate. All these services are tightly integrated with each other, so you can plug them in with an EC2 instance or IM, and you can get all the information at your fingertips. So let's talk about static website hosting on S3. And this is one of the very, very powerful features of S3, where we can actually host a website. And it's static and some part dynamic as well. So you do not need a web server to host your website. I have this bucket over here, AWS Agile.n. I click on it, and you can see that I have a couple of HTML pages, error.html and index.html, and then my code. My HTML, CSS files, my image, my video files are inside the folder. So I come over here, I click on the properties, and you can see that the bucket hosting is enabled. So if I click on it, all I need is 2 documents, then whatever I want inside my website. If I simply click on this thing, this is what I get. Now, these are the things that I have inside my website, my folder, and the beauty of it is that you do not need any web servers. You do not need any load balancer. You don't need any firewalls. You can simply give this URL, and then you can map it to your DNS, the domain name service, and then anybody will type your website name or your blog name, and then they are going to land on this page. And it's scalable. It is load balanced, and you can scale it to any number of people. You can have millions of hits coming in, and this is one of the very, very, very popular services of S3.
Let's look at AWS Marketplace. AWS Marketplace is an online store where you can buy software that runs on Amazon Web Services. We've gone through a lot of services, and you must be wondering, where do I get help? Where do I buy some software that integrates with all these services? AWS Marketplace is the buying and selling platform where you can either buy or sell software that integrate with AWS services. They are open source, commercial, these are for businesses, enterprises, and they're also for developers. And they are available in a range of categories, such as OS, security, networking, storage, business intelligence, DevOps, databases, monitoring, logging, etc. So let's take a look at AWS Marketplace.
So once you come over here, you can see that you will have something called AMI. That is a machine image. And you can also have something for software as a service. Let's look at the DevOps. Most of these are offered as a free trial as well. And if you want to see just the free versions, you can click on the pricing plan, and then you can see that you get these images of software, of Amazon Machine Image, the AMI. And you can just install it on your hardware that you provision from AWS. And that is how you start using these things. And as you can see here, there are a lot of developers tools, infrastructure, business software.
If you want to make some dashboards, if you want to run some analytics, you can do many of those things and more right over here. So come over here, explore the things you want to do, whether it's security, databases, networking, or anything else you might be looking for.
The main purpose of configuration management is to quickly spin up new resources whenever required. You may need to quickly spin up resources to upgrade to new instance types, to replace a failed instance or underperforming instance, for disaster recovery, for auto-scaling. You may also need to deploy configuration changes to a fleet of existing and running instances. Logging into each virtual machine and updating the same configuration files can take a ridiculous amount of time. So the deployment of the instances must be automated and repeatable to make the process easy and convenient. AWS supports a number of technologies for configuring and deploying Amazon EC2 instances and other AWS infrastructure. User data, Amazon Machine Images or AMIs, configuration management tools. User data is basically a command sequence that is executed at the first launch of the instance. When you launch an instance in Amazon EC2, you have the option of passing user data to the instance that can be used to perform common automated configuration tasks and even run scripts after the instance starts. You can pass two types of user data to Amazon EC2, shell scripts and cloud init directives. You can also pass this data into the launch wizard as plain text file for launching instances via the command line tools, or as base64 encoded text for API calls. The AMI provides the information required to launch an instance, which is a virtual server in the cloud. You can specify an AMI when you launch an instance, and you can launch as many instances from the AMI as you need. You can customize the instance that you launch from a public AMI and then save that configuration as a custom AMI for your own use. Instances that you launch from your AMI can use all the customizations that you've made. AWS also offers a variety of its own configuration management tools and services, which allow you to configure new instances using reusable templates and update configuration dynamically in response to change. In this lesson, we'll review some of these tools, such as AWS CloudFormation and AWS OpsWorks, and discuss strategies for combining these technologies into a comprehensive configuration and deployment strategy. AWS CloudFormation enables customers to create and modify collections of AWS resources using predefined reusable infrastructure templates. The CloudFormation templates provide EC2 bootstrapping features to help automate the initial installation and configuration of the OS and application stack. Templates can also be versioned, enabling customers to apply versioning logic to their AWS infrastructure the same way they do with software. AWS OpsWorks is a fully managed application stack management service that includes provisioning and configuration of Amazon EC2 instances, auto-scaling, application deployment, and application health monitoring. It also provides the ability to integrate with additional AWS services, such as Elastic Load Balancing and Amazon RDS instances. Your organization may have decided that it wants a base set of software included on all instances launched within its cloud. This may include homegrown utilities, in-house tools for using AWS services, and advanced software for enterprise-scale activities, such as monitoring and intrusion detection, among other possibilities. In this circumstance, consider using the base AMI approach. With this approach, you can pre-configure all of the software your organization requires on an Amazon EC2 instance, and then create an AMI from that instance. The new AMI would then become the AMI used to create all new instances within the organization. Organizationally, you could enforce use of the base AMI in a couple of ways. Create a custom toolset that becomes the gateway toolset for creating AWS resources, and that forces creation of instances from the pool of custom AMIs. Create processes that scan the running Amazon EC2 instances in your account and terminate any instances that are not using the standard AMIs. Third-party configuration tools, such as Chef and Puppet, are used by many AWS customers to start new Amazon EC2 instances in an automated and repeatable manner. The flexibility of these environments enables the implementation of a complete configuration management system. This screen illustrates one way in which configuration software can be integrated within an AWS architecture. Let's assume that you want to use configuration software to initialize a set of Amazon EC2 instances as web servers. The scenario breaks down as follows. The administrator sets up a configuration server. This usually is a standalone Amazon EC2 instance that will contain a set of templates which describe all of the applications, files, and configuration that a server needs to initialize itself. For example, a web server might instruct an instance to install Apache HTTPD, configure Apache's HTTPD config file, install all necessary programming language environments such as PHP, Ruby, and create a directory and file structure for web server content. A configuration server will likely contain a number of recipes for configuring dozens of different types of machines, including MySQL Server, NAT Server, Windows IIS Server, and so on. The administrator will create configuration templates, publish them to the configuration server, and check them into a source control system for version management and change tracking. The administrator will use custom scripting, CloudFormation, OpsWorks, or similar products to describe and create a full AWS cloud deployment environment. These tools may also specify what custom applications will be hosted in these environments, on which instances they should be hosted, and how they ought to be configured on each instance. For each Amazon EC2 instance that is deployed, the administrator will instruct the instance on how to configure itself as a configuration client of the configuration server. The administrator will also supply the name of the templates to be downloaded and executed on that machine. When an Amazon EC2 instance is deployed using a deployment technology, such as a script or CloudFormation, it will configure itself as a configuration client, download the appropriate template, and execute it. Various customers use different combinations of the technologies discussed in this topic to manage their AMIs. The solution adopted by your organization will depend on several factors, including your production workflow and your organizational standards. None of these techniques are mutually exclusive. They can all be used in tandem to craft a strategy that's right for your company. In general, placing software in AMIs is best reserved for foundational, slow-changing components that are truly required as standards throughout your organization. To create an Amazon EBS-backed Linux AMI, start from an instance you've launched from an existing Amazon EBS-backed Linux AMI. After you've customized the instance to suit your needs, create and register a new AMI, which you can use to launch new instances with these customizations. Ensure data integrity by stopping the instance before you create an AMI, then create the image. When you create an Amazon EBS-backed AMI, it's automatically registered for you. Amazon EC2 powers down the instance before creating the AMI to ensure that everything on the instance is stopped and in a consistent state during the creation process. Some file systems, such as XFS, can freeze and unfreeze activity, making it safe to create the image without rebooting the instance. When you need to automate the creation of an AMI, you can use the AWS EC2 Create Image command as displayed on the screen. During the AMI creation process, Amazon EC2 creates snapshots of your instance's root volume and any other EBS volumes attached to your instance. If any volumes attached to the instance are encrypted, the new AMI will only launch successfully on instances that support Amazon EBS encryption. Depending on the size of the volumes, It can take several minutes for the AMI creation process to complete, sometimes up to 24 hours. You may find it more efficient to create snapshots of your volumes prior to creating your AMI. This way, only small, incremental snapshots need to be created when the AMI is created, and the process completes quickly, though the total time for snapshot creation remains the same. After the process completes, you have a new AMI and snapshot created from the root volume of the instance. When you launch an instance using the new AMI, a new EBS volume for its root volume is created using the snapshot. Both the AMI and the snapshot will accrue charges to your account until you delete them. You can copy an AMI within or across an AWS region using the AWS Management Console, the command line, or the Amazon EC2 API, all of which support the copy image action. Both Amazon EBS-backed AMIs and instance store-backed AMIs can be copied. You can't copy an encrypted AMI between accounts. Instead, if the underlying snapshot and encryption key have been shared with you, you can copy the snapshot to another account while re-encrypting it with a key of your own, and then register this privately owned snapshot as a new AMI. Copying a source AMI results in an identical but distinct target AMI with its own unique identifier. In the case of an Amazon EBS-backed AMI, each of its backing snapshots is, by default, copied to an identical but distinct target snapshot. The exception is when you choose to encrypt the snapshot. The source AMI can be changed or deregistered with no effect on the target AMI. The reverse is also true. AWS does not copy launch permissions, user-defined tags, or Amazon S3 bucket permissions from the source AMI to the new AMI. After the copy operation is complete, you can apply launch permissions, user-defined tags, and Amazon S3 bucket permissions to the new AMI. The AMI creation process is different for instance store-backed AMIs. First, launch an instance from an AMI that's similar to the AMI that you'd like to create. You can connect to your instance and customize it. When the instance is set up the way you want it, you can bundle it. It takes several minutes for the bundling process to complete. After the process completes, you have a bundle, which consists of an image manifest and files that contain a template for the root volume. Next, you upload the bundle to your Amazon S3 bucket and then register your AMI. When you launch an instance using the new AMI, we create the root volume for the instance using the bundle that you uploaded to Amazon S3. The storage space used by the bundle in Amazon S3 incurs charges to your account until you delete it. You can convert an instance store-backed Linux AMI that you own to an Amazon EBS-backed Linux AMI. This involves creating a bundle, but the bundle is then downloaded onto a new Amazon EBS volume. After that, you need to snapshot the volume and create your new AMI from the snapshot. Please note you cannot convert an instance store-backed Windows AMI to an Amazon EBS-backed Windows AMI, and you cannot convert an AMI that you do not own. Using a configuration server can simplify many common administrative tasks. The most common example is provisioning and deprovisioning user access to Amazon EC2 instances. Say that Joe, an engineer, has been given access to multiple Amazon EC2 instances across the fleet, meaning Joe has a private key that enables him to log in with his unique user ID and perform administrative tasks on these instances. But what happens when Joe leaves the company? Without a configuration server, deprovisioning Joe's access to these machines can be a manual nightmare. Using a configuration server, however, a system administrator can easily change Joe's status in the system and roll this change out to all instances in the fleet with a few simple commands. One of the advantages of using a configuration server, such as Chef, Puppet, or Ansible is that configuration is idempotent. Resources that are created or configured by a configuration server are configured or created only once. If manual modifications are made to the configuration of an instance, the configuration server detects them and rolls them back. This ensures that the integrity of the instance isn't compromised by an accidental change. Most configuration software supports a single machine or standalone model, which means that it is typically capable of managing 1 to hundreds of servers from a central controller machine, hence the server orchestration term. In a typical environment, you can have a single administrator machine on which you create and edit the configuration templates, store them in the source control system, for example, Git, and use the configuration management tools to orchestrate your infrastructure. We'll now review some typical failures that might occur during the launch of the instances. Automated scripts or CloudFormation templates fail to create instances in different regions. Here, you need to check the AMI IDs. Keep in mind that in different regions, you always have different AMI IDs, so you need to make sure that you set the correct ones in your configuration. Another issue that you might come across is when the instance is marked ready, but the configuration is not complete. Keep in mind that the configuration readiness is separate from instance readiness. You need to take additional measures to check readiness of your configuration. For example, your configuration scripts can send an alert when the instance is fully configured. Another common issue is when the Windows images take a long time to boot from the AMI. The Microsoft System Preparation, or SysPrep tool, simplifies the process of duplicating a customized installation of Windows, but it can't extend the time it takes for an image to boot. For instance, readiness. Note that if you are using CloudFormation templates to deploy infrastructure, CloudFormation provides an object called waitCondition that can be used by user data scripts to signal to CloudFormation when configuration has completed successfully. The cloud offers you lots of possibilities, but it also brings a lot of questions about how to manage its power and flexibility. How do you update servers that have already been deployed into a production environment? How do you consistently deploy an infrastructure to multiple regions in disparate geographical locations? How do you roll back a deployment that didn't execute according to plan? In other words, how do you reclaim the resources that were already created? How do you test and debug a deployment before rolling it out to production? How do you manage dependencies, not only on systems and technologies, but on entire subsystems? The most commonly used technologies for automated, repeatable deployments include custom scripts and applications in which you can use AWS command line interface commands or AWS API to automate deployments in a variety of languages. AWS CloudFormation is a building block service that enables customers to provision and manage almost any AWS resource via a JSON-based domain-specific language. AWS CloudFormation focuses on providing foundational capabilities for the full breadth of AWS, without prescribing a particular model for development and operations. Customers define templates and use them to provision and manage AWS resources, operating systems, and application code. AWS OpsWorks focuses on providing highly productive and reliable DevOps experiences for IT administrators and ops-minded developers. To achieve this, AWS OpsWorks employs a configuration management model based on concepts such as stacks and layers, and provides integrated experiences for key activities like deployment, monitoring, autoscaling, and automation. Compared to AWS CloudFormation, AWS OpsWorks supports a narrower range of application-oriented AWS resource types, including Amazon EC2 instances, Amazon EBS volumes, Elastic IPs, and Amazon CloudWatch metrics. The cloud simplifies the migration of systems by making it easier to create parallel environments. There is no need to buy additional hardware to stand up a pilot version of your new environment. You can simply create the resources that you need. However, you still need to figure out how to ramp users off the existing system and onto a new one, a task that is much more challenging than a so-called greenfield or initial deployment. Some common patterns used to bring new systems online in a cloud environment include blue or green deployment. A parallel or green system is deployed by auto-scaling alongside an existing or blue system. The traffic is gradually shifted onto the green system. We'll discuss this model in depth a little later. Red or black deployment. This is a variation on the blue or green method used by Netflix. In this model, the existing or the red system exists in parallel to the new system. Once the new system is fully initialized and running, the infrastructure is considered to be in a red state. Next, the traffic is cut off to the existing system, putting it in a black state. The system is now in red-black mode. The old system is no longer receiving requests, and all new traffic is going to the new system. The black system is kept up and running while existing connections are completed to ensure that the red system is operating without incident. Engineers can bring the black system online if required. Dark launch. Used mainly for testing, a dark launch brings new features into a system without enabling the new feature in the user interface. Dark launches are used to ensure that a new feature works correctly in production and can handle the load associated with a company's existing user base. On this screen, an example of a blue or green deployment is displayed. In this model, a parallel environment with its own load balancer and auto-scaling configurations is brought up side by side with the existing environment. A feature of Amazon Route 53 called weighted routing can be used to begin shifting users over from the existing or blue environment to the new or green environment. Technologies such as CloudWatch and CloudWatch logs can be used to monitor the green environment. If problems are found in the new environment, weighted routing can be deployed to shift users back to the running blue servers. Once the new green environment is fully up and running without issues, the blue environment can gradually be shut down. Due to the potential latency of DNS records, a full shutdown of the blue environment can take anywhere between 1 day and 1 week. As discussed earlier, one of the challenges faced while deploying in cloud is implementing version upgrades. You can solve this problem with the help of auto-scaling. There are multiple approaches. Use the oldest launch configuration termination policy to drain old instances. Old instances will be replaced with the newer ones, launched using the latest version of launch configuration. Bring up 2 separate auto-scaling groups and use Amazon Route 53 and weighted routing to drive different percentages of incoming traffic to the 2 groups. You can start creating new instances and use AWS auto-scaling attach instances to bring new instances into group, and use the AWS auto-scaling detach instances policy to remove existing ones. AWS CloudFormation enables you to create and provision AWS infrastructure deployments predictably and repeatedly. It helps you leverage AWS products such as Amazon Elastic Compute Cloud, Amazon Elastic Block Store, Amazon Simple Notification Service, Elastic Load Balancing, and auto-scaling to build highly reliable, highly scalable, cost-effective applications without worrying about creating and configuring the underlying AWS infrastructure. AWS CloudFormation enables you to use a template file to create and delete a collection of resources together as a single unit or a stack. The 2 major concepts in AWS CloudFormation are templates and stacks. A template is a specification of the AWS resources to be provisioned. A stack is a collection of AWS resources that has been created from a template. You may provision or create a stack numerous times. When a stack is provisioned, the AWS resources specified by its template are created, Any charges incurred from using these services will start accruing as they are created as part of the AWS CloudFormation stack. When a stack is deleted, the resources associated with that stack are also deleted. The order of deletion is determined by AWS CloudFormation. You do not have to direct control over what gets deleted when. First, we'll be creating an Amazon S3 bucket for using the CloudFormation template. You need to decide in which region you want to create the template. For this demonstration, we'll create the template in the Mumbai region. Go to the CloudFormation service under the Management Tools section. Click Create New Stack. On this page, you get various options for designing or selecting a template. We already have a JSON code ready for this template. So let's select the Upload a Template to Amazon S3 option. Click Choose File to upload the file from your system. Select the file from your system to upload it. It's a simple JSON file that creates an Amazon S3 bucket. Click Next. Provide a stack name. Click Next. We'll keep all the values as default and click Next. On this page, you can review the template URL and the stack name. Click Create. Under the Events tab, you can observe the progression of the events related to stack creation. As you can see, the status is being shown as in progress. Click the refresh icon to view the progression of the steps in the stack creation process. Click the refresh icon again to refresh the view. As you can see, now stack has been created. Refresh the page again. Now you can see the status also displays that the stack has been created, which means that the stack is ready to use the resources. Click the Resources tab to view the bucket that has been created. As you can see, Amazon has provided a physical ID for the bucket. Let's now check out the bucket and see it has been created correctly. Let's go back to the console. Click S3 under the Storage and Content Delivery section. As you can see, our bucket is available. Click the bucket name. As you can see, the bucket is empty. Click the Properties button to view the properties of the bucket. As you can see, it has been created in the Mumbai region. Let's now go back to the Management Console and click CloudFormation under the Management Tools section. We'll now go and delete the stack. Once the stack is deleted, this bucket will be automatically deleted. Select the stack, click Actions, and select the Delete Stack option. Click the Yes Delete button to confirm your action. Under the Events tab, you can view all the events related to the deletion process. Click the refresh icon to get the updated view every time. As you can see, the stack and the bucket have been deleted. You have learned how to create an AWS CloudFormation template.
If you are looking to become an AWS Cloud Architect to excel your career, then have a look at AWS Cloud Architect Masters program by Simplilearn. With this certification course, you will learn architectural principles, scalability, security, and key components like S3 and CloudFormation. Become expert in the tools like Amazon EC2, AWS Lambda, Amazon DynamoDB, Amazon CloudFormation, and much more. Our AWS Cloud Architect training is great for beginners. However, AWS recommends at least 1 year of relevant experience before pursuing this program. So hurry up and try your hands on this amazing course. Use discount coupon YTBE15 to get handsome discount. Find the course link in the description box. If you are looking to learn cloud computing Enroll into professional cloud computing program in Cloud Computing and DevOps by Simplilearn and gain hands-on experience with industry projects. 1 year experience is preferred to grab the course. Find the course link in the description box.
Security is one of the key concerns for all those who would want to come onto the cloud. It could be an enterprise, it could be a startup, it could be a small business, and they all worry about that data. How secure is the data? So let's spend some time talking about security on AWS. Security at AWS is job zero. That is what AWS talks about. That is everybody's responsibility, and it starts right from the infrastructure. We spoke about regions. We spoke about availability zones. So availability zones are the physical data centers, and they are designed to be fault tolerant. They are designed to be highly available. So they are always in a group of 2 or more. So that way, if one goes down for any reason, we will still have the services running from the second data center. AWS has something called a shared security responsibility model, where they say that whatever happens to the underlying infrastructure, they are responsible for securing that infrastructure, such as the regions, the availability zones, the edge location. They are responsible for that underlying infrastructure. The customers are responsible for everything that they put on top of that infrastructure. So the data, the application, the access, the firewall rules. The customer is responsible for configuring access to anybody on that infrastructure. By default, AWS provides all the tools, and they do not provide any access to firewalls that we create, any user that we create, or any object that we upload to the cloud. By default, it will be private, so we have to explicitly make it public for any user. We have to give them permission to do something. Otherwise, they will not be able to do anything. Whenever we add any data, then it is addressed. We have to tell them who can access it. AWS gives you a whole set of services to secure your data, to secure your applications, to secure your resources, such as servers in the cloud. We will also talk a little bit about the compliance that you need for your application to be PCI DSS compliant, or if your application deals with the healthcare industry and must be HIPAA compliant, and you need all those documents that say that your infrastructure is HIPAA compliant. There's a place to go, and it's a shared service. So you go, and you request something, and you get it.
Take a look at all that AWS has to offer when it comes to security. It all starts from the identity and access management. At the heart of it, you would have who is accessing your system, and then what they are allowed to do in that system. So we are talking about authentication, and we are talking about authorization. So AWS gives you so many options to create users. You can create rules. You can manage the credentials on your own. Or you can have something called identity federation. So you don't have to create a login for everybody if you already have their credentials in your Active Directory. Or if you want to have them connect with Facebook ID, or Gmail ID, or LinkedIn ID, or Twitter ID, they should be able to do that. This is known as identity federation, and it allows you to do just that. They also have something called roles, where the credentials are managed by AWS and they are rotated internally, so you don't have to worry about managing credentials or storing them in the servers or passing them to the API request. They also have something called security tokens, which are nothing but temporary credentials, and you can allow somebody to access your application or system for a few minutes, maybe 60 minutes, maybe up to a few hours, and then these tokens would automatically expire. They also have something called multi-factor authentication. You can have all your users use this hardware or software device to authenticate themselves. You can have the MFA set up on their phones, and you'll be sure that anybody who is logging in should be in possession of that phone in order to log in. Similarly, for your application, they have something called AWS WAF,
That is a web application firewall, and it's simply to protect your application. You can configure it to the best of your choices, and it will simply protect you from any unwanted traffic that you don't want to hit your application. In similar fashion, they have something called AWS Shield. That is the service to mitigate all DDoS attacks. It comes in two versions, a standard version and an advanced version, and the standard version is free of cost. So, it will block most known DDoS and other attacks, and you can configure it to protect your hardware or your resources from any known attacks. Let's say you know you have a lot of resources in the cloud, and you want to monitor them continuously against any security threat. There's a service called Amazon Inspector, where you simply install an agent, and this agent will keep running, will keep producing reports for you on a monthly basis. So the bill is per agent per month, and it is really very economical when you compare it with other services, which are either paid or open source and not managed. And there's something called AWS Certificate Manager. That is a service that simply manages your SSL and TLS certificate. So you can bring your own certificate and upload it, or you can buy that certificate from AWS. And in both ways, you can simply manage those certificates in one location. AWS gives you that capacity, so you don't have this hassle of managing those services. Now this is a very interesting AWS artifact that we spoke about. So, let's say you need a compliance certificate that says that the infrastructure that you're running on is PCI certified because you are running an application that takes credit card information or does some credit card transactions. You could simply come here, and then you can request the artifact that you want. So you have something like FedRAMP Partner Package, you have ISO certification, and you can simply request that certification, and you are going to get that certification over here. So these are the suite of services that AWS has to offer for security. Apart from that, there are firewalls at your instance level, at your server level, firewalls at your subnet level. There are encryption services. You can ask AWS to do their own encryption, or you can run your own encryption algorithms. There are several kinds of credentials for accessing different services. And I like to think about it like this. There was once a time when people would not go on the cloud because of security. And now, people, organizations, banks, government agencies, they're moving towards cloud because their data, their network, is much more secure than what they could have on their own data center.
Let's see the steps to create an AWS account. The first step is to open the AWS web page. Then, click Create a Free Account to display the sign-in or Create an AWS Account page. In this page, click I am a new user. Enter your email ID or mobile number in the email or mobile number box, and then click Sign in using Secure Server. The AWS servers verify if an account already exists with the entered email ID. If yes, it displays an error message, else displays the login credentials page. In the Login Credentials page, enter the name. Re-enter the previously entered email ID and the password for your account. Then, click Create Account to display the contact information page. This page gives you the option to create a company account or a personal AWS account. For this demonstration, we will create personal AWS account. Then enter your full name and address in the displayed fields. Next, enter the CAPTCHA characters from the displayed security image. An important step is to open the AWS agreement and read it thoroughly. Then select the AWS Customer Agreement checkbox. Selecting the checkbox indicates that you have read the AWS agreement and you agree to it. Then, click Create Account and continue to display Payment Information page. In this page, enter the credit card details, and then click Verify Card and continue to display the Identity Verification page. Before displaying the Identity Verification page, the AWS servers verify the entered credit or debit card details by performing a reversible transaction of a small amount. This page displays your entered mobile number and is used to verify and confirm your identity. As you click Call Me Now, the AWS system calls you on the displayed number and your computer screen displays a 4-digit verification PIN. Enter the displayed 4-digit PIN in your phone using the keypad. Once the verification is successful, the page displays a message, Identity Verification Complete. Simply click Continue to select your support plan to display the support plan page. This page displays and explains about the 3 support plans: Basic, Developer, and Business. For this demonstration, we will select the free or basic plan, and then click Continue to display the welcome page of the AWS services. Congratulations! You have successfully created an AWS account.
Somewhere far in the country, a scientist has a lab far in the woods, and at one day he stumbled on a calculation that he had trouble solving. And he was very certain that his computer can handle it. And he asked his computer to do the math or the calculation for him. And the computer thought about it for a while, then took a couple of hours in trying to process the data. And eventually, at one point, it gave up and died due to low memory. And this old scientist is now clueless about how he was going to finish the task and complete his invention and let the whole world know about it. And that's when he was introduced to this new friend AWS, as you see on the screen. AWS was very handy in replacing his old machines, and it was able to give him the service that he wanted at that moment. AWS has been around for a while helping people with their computer needs, and now this new scientist friend in need is welcomed by the new and trendy IT technology AWS, and sure enough, his new AWS friend welcomed and walked him through the new way of computing. And this new happy-faced AWS friend talked to this scientist about AWS EC2 in specific, and walked him through about all the new innovations in IT and in cloud that he had been missing all these days. So his new friend AWS started the conversation about explaining how there is no need for any hardware units, no managing hardware or provisioning in AWS. And secondly, it explained increasing and decreasing the capacity as per the demand is just a click away. And the best part here is that there is no upfront commitment, and we only pay for what we have used, just like we pay electricity and water bills. And all this comes with complete control from our side. In other words, the whole key for this infrastructure is with us. And as if this was not enough, all this comes with enterprise-grade security that's beyond imagination in on-premises. And if this still does not excite you, then this definitely would. You can work from anywhere in the world. Now this really made the scientist to get excited, especially when he thought about working from home. Working from home, there is nothing like it, isn't it? Now this person, this scientist, is not tied up to a particular environment. He can work from home, work on the fly, work from anywhere. Still, the data and everything else in his IT environment is secure and safe. Now let's move to the next level of discussion. Let's talk about what is EC2 and some of the use cases of EC2. And this use case we're going to talk about, or this architecture we're going to talk about, it notifies a group of users about a new letter. And the components or resources this architecture would need be first EC2 instance, then SNS, a simple notification service, and coupling EC2 and S3 service together. That's all it would require to get an architecture that notifies a group of users about a new newsletter. And now I think it would be a good time to talk about what EC2 is. AWS offers plenty of services offered under different domains like compute, storage, database, migration, network, management tools, media services, security, business productivity, application integration, machine learning, game development, and a lot more coming up, out of which EC2 falls under the compute capacity. So what is EC2? EC2 is a web service which aims to make life easier for developers for providing secure and resizable compute capacity in the cloud. With EC2, it is very easy to scale up or scale down our infrastructure based on the demand. And not only that, this EC2 service can be integrated well with almost all the services in Amazon. And out of all this, the best part could be we only pay for what we use. Alright, let's talk about this use case. A use case here is that a successful business owner has a bunch of users and a successful product that's running, and now he has developed few more products that he thinks will be very successful, that he thinks his customers are going to like. Now, how can he advertise his product to his new and prospective customers? Or the solution for this question can be addressed by AWS. In AWS, we can use services like Simple Notification Service, SNS, and EC2 for compute and S3 for storage. We can, in a way, integrate them all and achieve this business use case. And that sort of got this business owner very cheered up, and now he wants to use the service and he wants to get benefited from the service. He wants to advertise or he wants to notify his users every time the company creates a newsletter. Alright, so let's talk about what it would take to get this environment up and running, or what it would take to connect the environment and put the applications on top of it. Firstly, we would require an AWS account, and then for compute capacity, we would require an EC2 instance. And here's how we go about doing it. The first thing is to create an AMI, which is Amazon Mission Image. That's really the softwares and the application packages we would need to run our application. And the second is to choose the hardware. In here it's the instance type. Depending on the workload, we would be choosing the hardware, and depending on the intents of the workload, we will be choosing the size of the hardware. And finally, we would configure the instances. How many instances do I want? Which subnet do I want them in? And what's going to be the stop or terminate behavior of the instance, and do I want to update any patches when the instance starts running? All those pieces of information go in here when we configure the instance. And then the first three steps is really about the OS volume and the basic hardware. Now it's time to add additional storage to the EC2 instance. That would be step 4. Here we add additional storage to the EC2 instance. And then tags, we use tags, or we would configure tags to easily identify an EC2 instance at a later point. We give it some meaningful names so we can identify, like which team it belongs to, which billing department it belongs to, what's the purpose behind launching this instance, stuff like that. In an environment where we run 700 to 800 or even more instances, identifying an instance and trying to understand who owns the resource, for what purpose we created, it could be an full-time work. So tagging comes to our rescue at that time. After tagging, as step 6, we would configure the firewall, which is also called security group, for the EC2 instance. And this is where we would allow or deny connection from external world to this particular EC2 instance. Well, it works both ways, from outside and from inside out. This firewall blocks the connection based on port number and IP address. And finally, as step 7, we review all the configurations that you have done and we make sure that the configurations is what we wanted, and finally click on submit. That's going to launch an EC2 instance. Alright, this was just an overview of how to create an EC2 instance. Now let's talk about each and every step in detail. So to begin with, let's talk about how to create an AMI. Well, the AMI is just a template that's used to create a new instance or a new computer or a new VM or a new machine based on the user requirement. The things that go into an AMI are the software, the operating system, the additional applications that get installed in it, stuff like that. The AMI will also contain software information, information about operating system, information about access permission, information about volumes. They all compact in the AMI. Again, the AMI is of two types. One is predefined AMIs, or called Amazon provided AMIs. The other one would be custom AMIs, the AMIs that we create. And if you're looking at a particular AMI that you don't want to create but still want to get it from Amazon, there is a place or a portal called AMI Marketplace. There we get like thousands of AMIs in there available for us to shop and use them on a pay-as-you-go business model, and use them as pay-as-you-go billing. So there you can search AMI that you're looking for. Most probably you'll be able to get it there. Now let's talk about choosing the instance type. The instance type is basically the hardware specification that's required for a machine that we're trying to build. And the instance types is categorized into 5 main families. They are, to begin with, it's compute optimized. Now compute optimized gives us lots of compute power or lots of processing power. So if my application is going to require a lot of processing power, I should be picking compute optimized instance. And the second one is memory optimized. Now this is very good for applications that require in-memory caching. There are some applications that performs well with cache or through cache, or the application would create a lot of data that it wants to keep in cache for rereading or for processing, for lengthy processing, stuff like that. For those type of application, this memory optimized instance that comes with in-memory cache is a very good use case. And the third one is the instance that comes with the GPU, otherwise called GPU optimized. GPU stands for graphical process unit, and this is very good for application that deals with gaming. This is very good for application that's going to require large graphical requirements. And storage optimized is the fourth option. Just like the name says, this is a very good use case for storage servers. And the fifth family type is general purpose. Just like the name says, it's for general purpose. If you're not particular about the family, then you generally would end up picking the general purpose, because here the services are sort of equally balanced. You'll find a balance between the virtual CPU and the memory and the storage and the network performance. It's sort of balanced. All the components, all the features that needs to go in a computer are sort of balanced in general purpose. Now these instance types are fixed and they cannot be altered because it's hardware based. We buy hardware. We do not have much control on the hardware that's being used. Well, we have options, but we do not have control on the hardware. And these instance types are divided into 5 main families. They are compute optimized, memory optimized, GPU enabled, storage optimized, and general purpose. Then as third thing, we have to configure the instance. Now here is where I have a lot of options about purchasing. What type of purchasing do I want to do? Do I want to go for a spot instance? Do I want to go for a reserved instance? Do I want to go for an on-demand instance? These are different billing options available, and that's available under configure instance. Not only that, here's where I'm going to put the EC2 instance. Do I want an public IP address assigned to it? Do I want an IAM role attached to it? IAM role is authentication. Or what kind of authentication am I going to provide? And the shutdown behavior. The shutdown behaviors include, do I want to stop the instance when the user shuts down the machine from the desktop, or do I want to simply terminate the instance when the user shuts down the instance from the desktop? So those things go in here, just like the name says, configure instance. A lot of instance configuration options comes in here. That's the third step. And not only that, under the advanced details or advanced tab under configure instance, I can bootstrap the instance with some scripts. Now bootstrap is nothing but the scripts that you want to be run in the instance before it actually comes online. Let's say you're provisioning the instance for somebody else. Instead of you launching the instance and then logging in and running some commands and then handing it over to the other person, you can create bootstrap shell scripts and paste it in a console option available under configure instance, and Amazon is going to take those commands, run it on the instance before it hands over to the user that initially requested for that instance. Now it could be a different user or just you. It sort of automates software installation procedures in the instance that we will be launching. And not only that, there are multiple payment options available under configure instance. The user can pick an instance under normal price, and that instance would apply normal rates applied to it. And there are also options like reserved instance, where the user can pay for an instance upfront before a year or before months, for a span of year or a span of months, and that way they can pay less per hour for using that instance. Not only that, you can also go for spot instance, like bidding for those instances. Whoever bids more, they get the instance for that particular time. Well, these instances are a lot cheaper than on-demand instances. And through bidding and buying, you can keep the instance as long as your bid price doesn't exceed the price that Amazon is proposing. And as the fourth step, we will have to add storage to the instance that we are about to launch. And here we have a bunch of storage options. I can go for ephemeral storage, which is free, or I can go for an external elastic block storage, also called EBS, which is paid and it's a permanent storage, or else I can integrate my EC2 instance with S3 for its storage needs. And the best part about storage is free subscription users, they get to use 30 gigabit of SSD storage or magnetic storage for the whole year. In this page where we are ready to add storage, we will have to mention or provide the size in gigabit and the volume type. Is it going to be an provisioned volume? Is it going to be an general purpose volume? Is it going to be a magnetic volume? Stuff like that. They are volume types. And we also need to give inputs about where the disk will be mounted and whether this volume needs to be encrypted or not. So all these options or all these inputs are received from us under the adding storage section. And then the fifth option would be adding tags. Like we discussed some time back, tags are very helpful to identify a machine in an environment where we have 700 or 1000 VMs running. And security groups are the actual firewall that sits in front of EC2 instance, and it protects that EC2 instance from unintended inbound and outbound traffic. Now here is where I can fine tune the access to my EC2 instance based on port numbers and based on IP address from which it can be accessed. And finally, we get to review the whole changes or the whole configurations that we have made to find out whether they are intact with the requirement, and then click on submit. That's going to launch an EC2 instance. But hold on, we're not done yet. When we're about to launch, or before the Amazon console actually launches the EC2 instance, it's going to give us an option to create a key pair. Remember, I said it's key pair. Key pair is two things. One is public and private. The private key is downloaded by the user and is kept with the user, and the public key is used by Amazon to confirm the identity of the user. So just go ahead and download the private key and keep it for yourself. And this private key gets downloaded as a .pem file. It's a format of the file and it gets downloaded as .pem file. And our next step is to access the EC2 instance. And because the instance that we have launched in this example, let's assume it's a Linux instance, and that's going to require a tool called PuTTY to be able to access it. And this PuTTY tool is really needed when we are trying to access an Linux instance from Windows instance. Most of the time, Windows instance will have PuTTY installed in them, but in some rare cases, they do not come with PuTTY. In those cases, we can go ahead and download PuTTY and PuTTY generator, and we can start using it to access the Linux instance. Now you might ask, well, I understand PuTTY, what's PuTTY generator? Now the file that we have downloaded is in .pem format, but unfortunately PuTTY does not accept .pem format as input. It has to be converted into a different format called ppk, and PuTTYgen is a tool that helps us to convert the .pem file into ppk file. So the quick way to do it is download generator, open it up, click on conversion and insert the .pem key that we have downloaded and save the private key. And this, when we save the private key, it gets saved as a .ppk type private key. And when that's done, the next very step is to open PuTTY and try to log in. And the way to log in is to open PuTTY, put that IP address here, and then click on auth. This is where we would input the file that we have created. So click on auth and then click on browse and find the .ppk file that we have converted and stored, browse it and upload it, and then click on open. Now that's going to open up a login screen for us. And the AMIs comes with a default username. Depending on the AMI that we have picked, the username might differ. In our case, we have picked an AMI for which the username is EC2-user, and this is the default, by the way. Let's put the username EC2-user and hit enter, and that's going to open up the Linux instance using CLI. There are a few other things that we can do with the terminal that we'll explain it a little later. Alright, so we have successfully launched an EC2 instance, and give yourself a pat on your back. Launching an instance was just one part of the solution. So let's actually talk about how we can notify our customers. SNS, or Simple Notification Service, is a service or a product in Amazon that helps us to notify customers through email. So navigate to SNS in your account and create a topic. And we're going to use this topic for public notification. So let's make it public and then add subscribers to it. Now these subscribers are the people who you want to be notified about the newsletter. So we already have the email database in there. Add them to the subscribers list and then they will start getting new newsletters as and when we post them to the topic. And as next step, create a bucket in S3 where you can store content, and in that bucket create an event that triggers a notification to Simple Notification Service. So this is how it will be set up. A notification will be sent to our subscribers anytime we put something in our S3 bucket. So S3 bucket is going to create an event for the notification, and the notification is going to make sure that it's delivered to your end customer because they're already subscribed to the topic as subscribers. And finally, let's connect the S3 with EC2 so the bucket and the AWS instance are in sync. So we put some content in the S3 bucket, our email system notifies our customers, and the customers can go online to a website that's hosted in EC2, and because S3 and EC2 are in sync, the items that we put in S3 will also show up in EC2. See how this is all connected and it's working together. And once this is all connected, our subscribers will regularly be informed anytime we put new content in the S3 bucket, and the same content will be made available in EC2 instance through the website. So what are we going to learn? We're going to learn about what is cloud storage in general, and then the types of storage available in general in the cloud, and how things were before anybody adopted using S3. That's something we're going to learn. And then we're going to immediately dive into what is S3 and then the benefits of using S3 over other storage. And then we're going to do a couple of labs or console walkthroughs about what is object and how to add an object, what is bucket, how to create a bucket, stuff like that. And then we're going to talk about how Amazon S3 generally works. Now, it comes with a lot of features, it comes with a lot of promise. How does this all work? How does Amazon able to keep up with the promise? We're going to talk about that. And then we will talk about some features, add-on features that comes along with Amazon S3. So what is cloud storage in general? Cloud storage is a service that provides web services where we can store our data. And not only that, the data can be easily accessed and the data can be easily backed up, everything over the internet. In short, if you could store your data, if you could access the data, if you could back up your data, everything you do through the internet, then that's a good definition for cloud storage. And additional definitions are, in cloud storage, we only pay for what we use. No commitment, no pre-provisioning. Is pay as you go type subscription. And the best part is we pay on a monthly basis. We don't rent a hardware for the year, or we don't give commitment for the whole year. It's pay as you go and pay on a monthly basis. And these cloud storages are very reliable, meaning once you put the data in it, it's never going to get lost. And these cloud storages are scalable. Assuming I have a requirement to store 100 times of what my actual data size is, and I want it now, it's available in the cloud. And these storages are secure as well, because we're talking about data virginity. They need to be secure, and Amazon provides tools and technologies through which we can secure our data, and these are generally not found in the on-premises storage system. So let's talk about the different types of storage in general. So S3 is cloud storage in AWS, and then we have Elastic Block Store. Now, Elastic Block Store is actually the SSD hard drives that gets attached to our EC2 instance. It's like the C drive, it's like the D drive, it's like the E drive that gets attached to our instances. Now, EFS is Elastic File System. The underlying technology is kind of the same, but it differs from EBS in a way that EBS can be accessed only by the system that's attached to it, meaning the E volumes and the D volumes we spoke about. They can be accessed only if there is an instance connected to it. But these EFS are actually shared file systems, Elastic File System. Alright, they are shared systems. They can be accessed by multiple systems. They can be accessed from inside the Amazon environment. It can be accessed from on-premises equipment as well. Glacier is actually the archiving solution in the cloud. If you want to dump a data and try to keep them in the low cost as possible, then Glacier is the product we should be using. And then we have Storage Gateway. If I want to safely move my data from my local environment to the cloud environment, and also want to keep a copy of the data locally, so users locally can access them, and cloud users or internet users can access the data from the cloud. If that's your requirement, then Storage Gateway is the one we would be choosing. And then we have Snowball. Snowball is really an data import and export system, but it is actually an hardware that gets shipped to our premises, where we can copy a data into it and then ship it back to Amazon, and Amazon would copy the data into whatever destination we give them in our account. And if the data is really huge, then I can call for a snowmobile, which is actually a data center on a truck, where Amazon would send me a truck loaded with a data center, as you see, that has compute capacity, lots and lots of storage capacity, and electricity, AC, and a lot more. So they get come parked near our data center, and cables run into our data center. We can copy data into it, send it back to Amazon, and they would copy it to our account in whatever storage that we advise them. So if the data is really huge, then I would be calling Snowmobile. Snowmobile is not available in all the regions. Alright, let's take this example, how things were before S3 was introduced. Two professionals are having a conversation, and one of them is finding it very difficult to sort of manage all the data in the organization. Well, if the data is small, it can be easily managed, but as company grow, and we are living in an era where data is everything. We want data to back up every idea. We want data to back up every proof of concept that we provide. So data is everything. So this era, it's all about collecting data, analyzing them, and saving, not losing logs, saving them, analyzing, stuff like that. So coming back to our discussion, here one person finds it very difficult to store and manage all the data that they have. So some of the data that this person is having problem storing is data that application use to running, and then data that get sent to the customers, and data that the websites require, the data that are because of the email backups, and a lot more other storages that an enterprise can have. And this person is having problem backing up all those data. And even if we think of increasing the local storage capacity, that's going to cost a fortune. And few things that make it sometimes impossible to increase the storage capacity in-house is we will have to go and pay heavy to buy hardware and software to run these storages, and we need to hire a team of experts for maintaining them, the hardware and the software. And anytime if there is a dynamic increase in the storage capacity, the on-premises or in-house hardwares won't be able to scale. And data security is very costly when it comes to building our own storage environment in-house and adding data security on top of it. So the other guy in the conversation was sort of quietly listening everything the manager was saying, and then he slowly introduced him to S3 because he knew that all the problem that this manager was worried about can be solved to S3. In other words, all the scalability, all the data security, all the not being able to provision hardware and software components are all available with S3. So that actually brings us to the discussion about what S3 is. S3 is simple storage service. It actually provides an object storage service. Let me talk to you about object and block storage. Object storage is where you can store things and retrieve. All right, you can't install anything in it, and this object storage can be accessed directly from the internet, whereas block storage is something that needs to be attached to an instance, and we can't directly access it, but we can install software in it. So that's a high level difference between object storage and block storage. And S3 is an object storage. What does that mean? We can store data from the internet, we can retrieve from the internet, but we can't install anything in S3. All right, so S3 is an object-based storage, and it's really built for storing and recovering or retrieving any amount of data or information from anywhere in the internet. Few other things you need to know about S3 is that this S3 is accessible through the web interface. The storage, one type of accessing or one way of accessing S3 is by dragging, dropping content into it, and another way of retrieving data from S3 is go to a browser, click on download. That's going to let you download any content, and the data can be 5 terabytes in size. Now we're talking about one file. You can have hundreds or thousands of files like that. One file can be as big as 5 terabytes in size. And S3 is basically designed for developers where they can push logs into S3 or retrieve logs anytime they want instead of storing locally in the server. They can use S3 as code repositories, where they can save the code and have the applications read the code from there, and a lot more. If they want to safely share the code with another person with a lot of encryption and security added on top of it, that's possible as well. So there are a few things about S3, and on top of all this, S3 provides 11.9 durability and 4.9 availability. Meaning durability is, if I store the data, will it get lost? Amazon is like, no, it's not going to get lost. You're going to have the data because we provide 11.9 durability for the data. And availability is, if you want the data now, will you be able to show it? Amazon is like, yes, we will be able to show it. We have 99.99% availability, and when you request the data, we will be able to show the data to you. All right, so let's talk about the benefits of S3. S3 is durable. As we saw, it provides 11.9 durability. S3 is low cost. Out of all the storage options in Amazon, S3 is the cheapest, and S3 is very scalable. Like we were saying, there's no required to pre-provision a storage capacity. If you need more, go ahead and use more. If you need even more, go ahead and use even more. And once you're done, some data needs to be removed, just remove the data. So that particular month you will be paying less. So it's very scalable in nature, and it's very available as well. S3 isn't regional service. It's not based on one availability zone. So one availability zone going down within Amazon, the whole availability going down, it's not going to affect your ability to access S3 storage. And S3 is secure. A lot of security features like bucket policy, a lot of security features like encryption, and then MFA authentication are possible with S3 that actually adds a very good security layer on top of the data that we have stored in S3. And not only that, this S3 is very flexible in terms of cost, flexible in terms of where I want to store the data. In terms of cost, there are a lot of pricing tiers within S3. S3 itself is a cheap service. Now within that, we have a lot of pricing tiers depending on the durability. So I can always choose to put data on a different storage tier or storage option in S3. We're going to talk about it as you stick along. And in terms of flexibility in region, I can always choose any of the region available in the console or in the S3 console to put my data to. There is no restrictions on where I can or cannot put the data in the cloud, as long as there are regions available for me to move the data to. And data transferring with S3 is very simple. All I have to do is browse to the bucket, upload the data, and the data gets uploaded. And we can also upload data using CLI. Commands are very similar to Linux. Commands are very similar to what we would use in the run command prompt in Windows and what we would use in the run command prompt in the PowerShell. All right, let's talk about a basic building block of S3, which is bucket and objects. Now, what's a bucket? What's an object? Object is the actual data, and bucket is the folder where the objects get stored. Let me give you a new definition for object. So object is the actual data plus some information that reference the data, like is it a JPEG file, the name of the file, and at what time it was added to. So they're called metadata. All right, so object is actually data plus metadata, and bucket is actually a container that receives the data and safely stores in it. And when we add a data in a bucket, Amazon S3 creates an unique version ID and allocates it to the object so we can easily identify it at a later point. Let me show you a quick lab on S3. Alright, I'm in the S3 console. If you're wondering how I reached here, go to services under storage and S3 is right here. And let's create a bucket called Simplilearn. Now the bucket names will have to be unique. So I really doubt if Simplilearn will be available. Let's check it anyway. All right, it doesn't seem to be available. So let me pick another name, or let's call it simplylearn.samuel.com. And I'm going to put this in Mumbai, or I can choose Oregon. Let me choose Oregon. Yes, let me choose Oregon. And let me create a bucket. Sure enough, a bucket got created. Let me upload an object into the bucket. And you know, these objects can be as big as 5 terabytes. We talked about it, right? All right, let me upload an object. All right, so that's my object. So you get the relation, right? Here's my bucket. All right, here's my bucket, and within that is my object. Now, object is the actual file plus what type of file it is, and then the size of the file, the date in which it got added, and the storage class it is in at the moment. So if I have to access it, I can simply access it through the internet. So let's talk about how does this S3 bucket work anyway. Alright, so how does it work? A user creates a bucket. They will specify the region in which the bucket should be deployed. We had an option. We could have chosen to deploy in all the regions. Amazon provides S3 service, be it North Virginia, be it Mumbai, be it Tokyo, be it Sydney, be it Oregon. And we chose Oregon to be the destination region where we want to create a bucket and save our data there. And when we upload data into the bucket, we can specify 3 types of storage classes. In our case, we picked the default, which was S3 standard. As we saw on the object data, it was on S3 standard. So that's the basic thing. Later, once the object gets added, we can always add bucket policies. Policies define who access it and who should not access it. What can they access? Are we going to allow users only to read or to read-write as well? Stuff like that. So that's bucket policy. We're defining the life cycle or the lifespan of the data in the S3 bucket. Now, over the time, do you want the data to automatically move to a different storage tier? And at any point, do you want to sort of expire the data, get the data flushed out of your account automatically? Those things can be configured in lifecycle policies. And version control is creating multiple versions. If you're going to use S3 for a code repository, creating multiple versions. Let's say if you want to roll back to whatever you had before a month, how are we going to do it if you kept updating the file and never took a version of it? So version control helps us to keep different versions, and it helps us to roll back to the older version anytime there is a need. So let's talk about the different storage classes in S3. The different storage classes in S3 begins with S3 standard. Now this is the default, and it's very suitable for use cases where you need less or low latency. For example, if you want to access the data of a student's attendance, you would retrieve them very quickly as much as possible. So that's a good use case to store data in S3. Let's understand the different storage classes in Amazon S3. Now let's take a school, for example, and the different data present in a school, and the features of those data, the validity of the data. Alright, so let's take this example, and there are different storage options in S3. Let's take S3 standard, for example, and what would be the actual candidate data that can be stored in S3 standard. Let's talk about that. So S3 standard in general is suitable for use cases where the latency should be very low, and in here the good example or the good candidate file that can be stored in S3 is data that needs to be frequently accessed and that needs to be retrieved quickly. Something like students' attendance report or students' attendance sheet, which we access daily, and then it needs to be retrieved immediately as and when we need it. The other type of storage tier in S3 is infrequent access or infrequent data access. Just like the name says, the use case for that is less frequently accessed data. I mean, the candidate data that should go in infrequent access data is a student's academic record, which we don't need to access on a daily basis. But if there is a requirement, we might want to go and look at it, and that's going to be quick. So it's not a data that we would access on a daily basis, but it's a data that needs to show up on your screen real quick. And the third option is Amazon Glacier. Now, Glacier is really an archival solution in the cloud. So for archives, high performance is not a requirement. So let's talk about some candidate data that can go into archives. Something like students' admission fee, and it's not critical also. Now, anytime if you want to look at the data, you can always wait to retrieve the data. So in other words, put it in the archive, and retrieving from the archival takes time. So a student's old record are a good candidate to be put in the archives. The other options are one zone IA storage class, where the data is infrequently accessed and the data is stored in a single availability zone. For example, by default, Amazon stores data in multiple availability zones, and there is a charge for that. Now, it's not an option, but the charge includes storing data in multiple availability zones. But if your data requirement is you want to keep the charges low even further, you can choose a one zone IA storage class where it stores data in one availability zone. And the candidate data that can go in one zone infrequent access is student's report card. And the other option with Amazon S3 is standard reduced redundancy storage. It is suitable for cases where the data is not critical and the data can be reproduced quickly. For example, take a copy of the library book, take a copy of the PDF library book, for example. Now, we would have a source PDF and we would make copies of it, and then we make it available for the readers to read. The other option in S3 is reduced redundancy storage. Here the use case is data that's not critical and data can be reproduced quickly. For example, books in the library are not that critical and we always have a copy of the book. We're talking about PDF. So if the customer facing or the student facing book gets deleted, I can always copy the same PDF, put it in the destination folder and make it available for the users to read. That would be a very good use case for reduced redundancy storage. Alright, let's summarize everything that we learned about different storage options in S3. So S3 standard, it's for frequently accessed data. It's the default storage. If you don't mention anything, the data gets stored in S3 standard. It can be used for cloud applications, content distribution, gaming applications, big data analytic, dynamic websites. They are a very good use case for S3 standard frequently accessed data. The other one, on the contrary, is S3 standard infrequently accessed data. Just like the name says, the use case is this is good for data that will be less frequently accessed, and then the use case are it's good for backups, it's good for disaster recovery, and it's good for lifelong storage of data. Glacier, on the other hand, is very suitable for archiving data which is infrequently accessed, and the vault lock feature is the security feature of the Glacier that also provides a long-term data storage in the cloud. This is the lowest storage tier within S3. The other options are one zone infrequent access storage class. Just like the name says, it's infrequently accessed and it is stored in just one availability zone. And use cases are any data that doesn't require any high level of security can be stored here in one zone. The fifth storage tier is reduced redundancy storage. This is good for data that's frequently accessed. It's good for data that is non-critical and that can be reproduced if it gets lost. And reduced redundancy storage, or RRS, is an highly available solution designed for sharing or storing data that can be reproduced quickly. Alright, let's compare and contrast a couple of other features that are available in S3. For example, durability, availability, SSL support, first byte latency, and lifecycle management. So in standard, the durability is 11.9 durability. It's the same for standard IA, one zone IA, Glacier, except for reduced redundancy, the durability is 11.9. And availability of all the storage classes is all the same, except for one zone IA, where the availability zone is 99.5%. All of these products support SSL connection, and the first byte latency of these products are most of them provide access with millisecond latency, except for Glacier. It provides a retrieval time of couple of minutes to a maximum of hours, and all of them can be used for a lifecycle management, moving data from one storage tier to another storage tier. That's possible with all of these storage options. Alright, now that we've understood the different types of storage options available in S3, let's talk about some of the features that are available in S3. Lifecycle management. Now, lifecycle management is a service that helps us to define a set of rules that can be applied to an object or to the bucket itself. Lifecycle is actually moving the data from one storage tier to another storage tier and finally expiring it and completing the life cycle of the object. With lifecycle management, we can manage and store our objects in a very cost-effective way. It has two features basically: transition actions and expiration actions. Let's talk about transition actions. With transition action, we can choose to move the objects or move the data from one storage class to another storage class. with lifecycle management, we can configure S3 to move our data from one storage class to another storage class at a defined time interval or at a defined schedule. Let's talk about transition actions in more detail. Let's say we have our data in S3 at the moment and we haven't used the data for quite some time, and that's how it's going to be for the rest of the time. So that data is a very good candidate to move to the infrequent access, because S3 standard is a bit costlier and S3 infrequent access is a bit cheaper than S3 standard. So the kind of usage sort of fits very well for moving that data into infrequent access. So using lifecycle transition or lifecycle management, I can move the data to S3 infrequent access after 30 days. And let's say that the data stayed in infrequent access for 30 more days, and then now I realize that nobody is looking into the data. So I can find an appropriate storage tier for that particular data again, and I can move it to that particular storage tier, which is Glacier. So in this case, after 30 days or in a total of 60 days from the time the data got created, the data can be moved to Glacier. And what does this really help us with? The lifecycle management helps us to automatically migrate our data from one storage cost to another storage cost, and by that it really helps us to save the storage cost. Lifecycle management can also help us with object expiration, meaning deleting the object or flushing it out after a certain amount of time. Let's say that our compliance requirement requires that we keep the data for 7 years, and we have like thousands and thousands of data like that. It would be humanly impossible to check all those or keep track of all the dates and when they need to be deleted, stuff like that. But with lifecycle management, it is very much possible. I can simply create a data and set up lifecycle management for the data to expire after 7 years, and exactly after 7 years the data is going to expire, meaning it's going to be deleted automatically from the account. Alright, let me show you a lab on lifecycle management and let me explain to you how it's actually done. So I'm into the bucket that we have created, and here's our data into the bucket. Assume we have thousands and thousands of data in the bucket, and that requires to be put in a different storage tier over time, and that requires to be expired after 7 years, let's say. So the way I would create a lifecycle management is go to management from inside the bucket and click on lifecycle, and then add a lifecycle rule. Just give it a name like expire. So all the objects that's present in this bucket, meaning the current version of it, set a transition for it. So the transition is, at the moment they are in S3. So here I would like to put them in infrequent access after 30 days. And then after it's been in infrequent access for 30 days, I would like to move it to Glacier. Alright, plus 30 days. So how do you read it? So for the first 30 days, it's going to be in Glacier. So how do we actually read it? So after I put the data in S3, the data is going to get moved to standard IA, and then it's going to stay in standard IA, and after 60 days from the data creation, it's going to get moved to Glacier. So on the 31st day, it's going to move to standard IA. On the 61st day, it's going to move to Glacier. Let's say if I want to sort of delete the data, if I want the data to get deleted automatically after 7 years being in a Glacier, how do I go about doing it? Let me open up a quick calculator. 365 into 7, that's 2555 days. Right after that, the data is gonna get deleted. Pretty much I have created a life cycle. So on the 31st day, it's going to get moved to infrequent access, and on the 61st day, Glacier, and after 7 years is over, any data that I put in the bucket, it's going to get deleted. Alright, let's talk about bucket policies. Bucket policies are some permission files that we can attach to a bucket that allows or denies access to the bucket based on what's mentioned in the policy. So bucket policy is really an IAM policy where you can allow and deny permission to an S3 resource. With bucket policy, we can also define security rules that apply to more than one file in a bucket. Now in this case, we can create an user, or let's say there's already a user called Simplilearn. We can allow or deny that user connection to the S3 bucket or connecting to the S3 bucket using bucket policy. And bucket policies are written in JSON script. And let's see how that's done. Alright, there are tools available for us to help us create bucket policies. What you're looking at is a tool available online that helps us to create a bucket policy. So let's use this tool to create a bucket policy. I'm going to create a deny statement. I'm going to deny all actions to the S3 bucket. And what is the ARN to which we want to attach? The ARN of the resource is actually the name of the bucket, but it really expects us to give that key in a different format. So the ARN is available right here, copy bucket ARN. So this is actually going to deny everybody. Now we wanted to deny a user, just one user. Now look at that. Now we have a policy that has been created that's denying access to the bucket, and it's denying a user called Simplilearn. Pretty much done. So I can use the policy and go over to bucket policies. So once I save it, only the user called Simplilearn won't have access to the bucket, and the rest of them will have access to it. So once I save it, it gets added, and only the user Simplilearn will not have access to the bucket because we're denying them purposefully. The other features of S3 include data protection. We can protect our data in S3 with now one of which is bucket policy. I can also use encryptions to protect my data. I can also use IAM policy to protect my data. So Amazon S3 provides a durable storage. Not only that, it also gives us a protected and scalable infrastructure needed for any of our object storage requirements. So here the data is protected by two means. One is data encryption and the other one is data versioning. Data encryption is encrypting the data so others won't get access, or even if they get access to the file, they won't be able to access the data without the encryption key. And versioning is making multiple copies of the data. So let's talk about them in detail. What's data encryption? Now, data encryption refers to protecting the data while it is being transmitted and protecting the data while it is at rest. Now, data encryption can happen in two ways. One is client encryption, encryption at rest, and server-side encryption, encryption that's in motion. Client-side encryption refers to when client sends the data, they encrypt the data and send it across to Amazon. And server-side encryption is when the data is being transferred, they get encrypted and stay encrypted throughout the transfer. Versioning is another security feature. It helps us so our unintentional edits are not actually corrupting the data. For example, let's say you edited the data and now you realize that the data is incorrect and you want to roll back. Now, how do you roll back? Without versioning, it's not possible. In other words, only with versioning, it's possible. So versioning, it can be utilized to preserve, recovery, and restore any early versions of every object that we stored in our Amazon S3 bucket. Unintentional erases or overwrites of the object can be easily regained if we have versioning enabled. And it's possible only if we have one file with the same key name, and anytime we update the file, it keeps the file name but creates a different version ID. Take this bucket and data for example. Photo.pmg is a file that was initially stored. It attached a version ID to it, and then we edited it. Let's say we added some watermark, we added some graphic to it, and that's now the new version of it. When we store it with the same file name. It accepts the same file name but creates a new version ID and attaches it. Anytime we want rollback, we can always go to the console, look at the old versions, pick the version ID, and roll back to the old version ID. Alright, let's take this example. Now, I'm in a bucket that we've been using for a while, and let me upload an object. Now, before we actually upload an object, this bucket needs to be versioning enabled. So let me version enable this bucket. From this point onwards, this bucket is going to accept versioning. So let me upload an object, photo.jpg. Let me upload it. All right, it successfully got uploaded. Good enough. It's uploaded. Now, let me upload another object with the same file name. Now look at that. It was uploaded at 7:40:35 a.m. Let me upload another object with the same file name that I have it stored right here. That got uploaded but with the same name Alright, so that's the other photo. Now what if I want to switch back? The way I would switch back is simply switch back to the older version. Look at that. This is the latest version and this is the old version that I have. I can simply switch back to the old version that was created at such and such time, and I can open it. That's going to open the old file. So in short, it creates different version of the data that I create as long as it's with the same name, and at any point I can go and roll back to the original data. This is a very good use case if you want to use S3 for storing our codes. Let's talk about other feature like cross-region replication. Now cross-region replication is a very cool feature if you want to automatically keep a copy of the data in a totally different region for data durability, for any additional data durability, or if you want to serve data to your customers who live in another country or who are accessing your data from another country. If you want to serve the data with low latency, cross-region replication is a very cool feature that you can use and get benefited from. And let's see how that's done. So before we actually do a lab on cross-region replication, let's put together a proper definition for it. Cross-region replication is a feature that provides automatic copying of every object uploaded to our bucket or your bucket, source bucket, and it automatically copies the data to the destination bucket, which is in a different AWS region. As you see here in the picture, I put data only in region 1. It's going to copy the data to region 2. And for us to use cross-region replication, versioning must be turned on. So it creates versions and copies the versions as well. If tomorrow the original region goes down, let's say, the other region will be active and it has the complete data that was present in the original region. Or at any point, if we want to simply cut the region replication and use the other bucket as a standalone bucket, it can be used as well, because it already has all the data that was present in the master or all the data that was present in the original replication bucket. Let's see how that's done. So there are two things needed. One is versioning and another one is role. When we transfer data from one bucket to another bucket, we need proper permissions to do so, and these roles, they give us proper permissions to transfer data from one bucket to another bucket. Let's see how that's done. Right, so here's my bucket, a bucket in US Oregon. Let's create another bucket in Mumbai. Call it .mumbai.com and put it in Mumbai, or create that bucket in Mumbai. There you go. We have one in Oregon, we have one in Mumbai. We're planning to replicate or create replication between these two, right? Create replication between these two buckets. So go to the first bucket, go to management and start a replication. Add a rule. So all content in this bucket is going to get replicated. This is my source bucket. It's quite simple. Select the destination bucket. Now my destination bucket is going to be simplilearn.samuel.mumbai.com. Alright, it says, well, you have versioning enabled in your source bucket, but not on your destination bucket. Do you want to enable it now? Without which we won't be able to proceed further. So let's go ahead and enable versioning through the console that shows up. And then like I said, it's going to require permission to put data onto the other bucket. Now I can create different roles. These are different roles that are used for different other services. I can also choose to create a role that specifically gives permission only to move the data from one bucket to another bucket. Pretty much it's done. So if I go over to my source bucket and if I add some data to it, let's say index.html, assuming I'm adding some files to it, in theory they should move to the other region automatically. There you go. I'm in the Mumbai region and the they got moved to the other region automatically. Let's talk about the other feature called transfer acceleration. Now it's a very handy and a helpful tool or a service to use if we are transferring data which is very long distance from us, meaning from the client to the S3 bucket. Let's say from my local machine, which is in India, if I transfer the data over to Oregon, let's say, it's a long distance. If it is going to go through the internet, it's going to go through high latency connections, and my transfer might get delayed. If it is an 1 gigabit file, it's okay. But if we're talking about anything that's 5 terabyte size, if you're talking about anything that's a 5 terabyte in size, then it's not going to be a pleasant experience. So in those cases, I can use transfer accelerator, which in a secure way, but in a fast way, or a fastest way, transfers my data from the laptop or from client to the S3 bucket. And it makes use of a service called CloudFront to transfer or to enable the data acceleration. So the way it would do it is, instead of copying the data directly to the location, instead of copying the data directly to the destination bucket, it copies the data locally into a CloudFront location, which is available very local to whatever place we are in. And from there, it copies the data directly to an S3 bucket, not going through the internet. It helps eliminate a lot of latency that could get added when transferring the data. So let's see how that's done. Right here, I'm in the S3 bucket, and under properties, I can find transfer accelerator. And if I enable transfer accelerator, so I'm in another bucket. Let me go to properties, and let me go to transfer accelerator and enable transfer accelerator. So now if I put data into this bucket, they're going to get copied to the local CloudFront location, and from there they're going to get copied to the S3 bucket from the CloudFront. Now if I need to compare how the speed is going to be compared to directly putting the data through the internet and using CloudFront, there is a tool available that actually runs for a while and then comes with a report that tells me how much will be the improved speed if I use transfer accelerator, and it shows for all the regions available in Amazon. So from the source to the destination, if you want to put what's the normal and what's the accelerated speed when you transfer the data, those results we will get in the screen. So at the moment, this tool is going through its testing, like uploading some file through the internet and uploading some file using CloudFront, and it has come up with the calculation that if I'm uploading file to San Francisco compared to uploading through the internet and through CloudFront, it's 13 times faster. So similar way, it's going to calculate for all the regions available, and it's going to give me a result.
If you are looking to become an AWS Cloud Architect to excel your career, then have a look at AWS Cloud Architect Masters program by Simplilearn. With this certification course, you will learn architectural principles, scalability, security, and key components like S3 and CloudFormation. Become expert in the tools like Amazon EC2, AWS Lambda, Amazon DynamoDB, Amazon CloudFormation, and much more. Our AWS Cloud Architect training is great for beginners. However, AWS recommends at least 1 year of relevant experience before pursuing this program. So hurry up and try your hands on this amazing course. Use discount coupon YTBE15 to get handsome discount. Find the course link in the description box. If you are looking to learn cloud computing, enroll into professional cloud computing program in Cloud Computing and DevOps by Simplilearn and gain hands-on experience with industry projects. 1 year experience is preferred to grab the course. Find the course link in the description box.
One day at office in a growing company, there was discussion going on between two IT personnel. It was about the new role that his colleague Jessica has taken. Benjamin, the guy standing here, wants to know about it. And Jessica's job is new, different, and dynamic and interesting too. She scale and manage servers and operating systems and apply security patches onto them and monitor all of these at the same time to ensure the best quality for application is given to the users. And Benjamin was awestruck with the amount of work Jessica is doing and with the time it would take to complete all of them. But Jessica, being a very dynamic person, very suitable for the job, said it was easy for her to handle all of it and even more. But that easiness on the job did not last longer. As the environment grew more and more, it being a startup company, Jessica was getting drained and was not really happy about all her job as she used to be. Jessica's manual way of scaling an environment did not last long, and she was also finding out that she missed to scale down some of the resources and it's costing her a lot. She needs to pay for the service that she was not at all using. She sort of felt that she was at the end of the road and there was no way out from this manual task. She was very desperate. And that's when Benjamin suggested something. And that brought back the peace and joy Jessica initially had. Benjamin suggested about a service called Lambda that can ease the work that Jessica is doing at the moment. And Lambda, as happy as it looks like, it's a solution that solves the manual, repetitive work and lot more. And Lambda introduced itself as the problem solver and started to explain the following things, the very same thing that we're going to learn about in this series. So in this section, we're going to learn about the features of AWS Lambda, and we're going to talk about what Lambda is, and then we're going to talk about where Lambda is being used in the IT or in the cloud environment as we speak, and then we're going to talk about how Lambda works and some use cases of Lambda, and we're going to be particularly discussing about the use case about automatically backing up the data that's put in the cloud storage. Let's talk about Lambda in detail. Lambda automatically runs our code without requiring us to provision or manage servers. Just write the code and upload it to Lambda and Lambda will take care of it. That means that we don't require any server to run or to manage, and all you need to do is write the code and upload it to Lambda and Lambda will take care of it. Which also means that we can stop worrying about provisioning and managing servers. The only thing Lambda expects from you is a code that's working. AWS Lambda also automatically scales our application by running code in response to each trigger. Our code runs in parallel and processes each triggers individually, scaling precisely with the size of the workload. Scaling here is done automatically based on the size of the workload. Lambda can scale the application running the code in response to each and every trigger that it receives. Billing in Lambda is metered on the seconds. We only pay for the amount of time that our code is running, which means that we're not charged for any of the servers. The only payment required is for the amount of time the code is computed. With AWS Lambda, we are charged for every 100 milliseconds. We are actually charged for 100 milliseconds our code executes and the number of times our code is triggered, and we don't pay anything when the code is not running. Let's talk about what is AWS Lambda. Now, Lambda is one of the services that falls under the compute section or the compute domain of services that AWS provides, along with EC2, EBS, Elastic Load Balancer. Lambda is also a service that comes under the bigger umbrella of compute services in AWS. And Lambda allows us to execute code for any type of application. With AWS Lambda, we can run code for virtually any type of application or backend services. All we need to do is supply our code in one of the languages that AWS Lambda supports. As we speak, the languages that are supported by AWS Lambda are Node.js, Java, C#, Go, and Python. And Lambda can be used to run code in response to certain events from other services. And based on the event, it can run functions, and those functions can be of Node.js, Java, C#, etc. Now let's talk about where is Lambda used. There are a huge number of use cases for Lambda, and there are many ways AWS Lambda is used specifically in the business world. Let's talk about some of them. One use case is AWS Lambda is used to process images when it is uploaded in an S3 bucket. Let's say the object gets uploaded in an S3 bucket in a format that we don't expect it to be, which means the file needs to be formatted. So it gets uploaded in a raw format, and AWS Lambda is triggered anytime a new object is added to the bucket, and the images are processed and converted into thumbnails based on the devices. The other end device that would be reading the data, it could be an PC, it could be an Apple machine, it could be an Android phone, it could be an Apple phone, it could be a tablet, whatnot. So based on the devices, different formats, Lambda can get triggered and convert the video or convert the picture into the different format that it requires. Another use case for Lambda is to analyze the social media data. Let's say we're collecting the hashtag trending data, and the data is received and it's added into the Kinesis stream to feed into the Amazon environment, and Lambda action get triggered, and it receives the data, and then the data is stored into the database, which can be used by businesses for later analysis. And some of the companies that have gotten tremendous benefit using Lambda are Thomson Reuters, Benchlinks, Nordstorm, Coca-Cola, Robot are some of the companies to name at the moment that have received tremendous amount of benefit by using Lambda. Let's look at how Lambda works. In other words, let's look at how the complicated function behind the scenes work in a simple and in a seamless way. So here clients send data. Now clients send data to Lambda, and clients could be anyone who's sending request to AWS Lambda. It could be an application or other Amazon Web Services that's sending data to the Lambda. And Lambda receives the request, and depending on the size of the data or depending on the amount or volume of the data, it runs on the defined number of containers. If it is a single request or if it is less request, it runs on a single container. So the requests are given to the container to handle, and the container which contains the code the user has provided to satisfy the query would run. And if you're sort of new to containers, then let me pause here for a while and explain to you what container is. Now, container image is a lightweight, standalone, executable package of a piece of software that includes everything needs to run it, like the codes, the runtimes, the system tools, the system libraries, and any other settings needed. And it is at the moment available both on Linux and Windows based application, and containerized software will always run the same regardless of the environment it's running on. And containers isolate software from its surrounding. For example, there could be difference between a development and staging environment, so that's sort of isolated, and this helps in reducing the conflict between the teams running different software on the same infrastructure. Alright, now that we know containers needed to understand Lambda, so if there are few requests, it sends to a single container, but as and when the request grows, it actually creates multiple containers, shares the multiple requests to the different containers there. And depending on the volume, depending on the size, depending on the number of sessions, the more number of containers are provisioned so to handle those requests. And when the requests reduce, the number of containers reduce as well, and that helps in saving costs. We're not running any resources and paying for it when we're not using them. And in fact, we're not at all paying for the resources. We're only charged for the amount of time a function is running inside these containers. Now consider a situation where you have to set up a temporary storage and as a system to back up the data as soon as the data is uploaded, which is a near real-time backup. Now, a near real-time manual backups are nearly impossible, and they're not that efficient too. A near real-time manual backups, that's what the business demands, but that's not near real-time backup, that too a manual one, that's not at all efficient. Even if we come up with a solution of manually backing up close to near real time, that's not going to be efficient looking at the amount of data that will be put in and looking at the random times the data will be put into the source bucket. And there is no way we can do a manual backup and keep it as real as possible. But if that's still your requirement, we can use AWS Lambda and set things up so AWS Lambda manually handles the backup. In other words, for an impossible or a difficult situation like that, AWS Lambda comes for the rescue. And this is what we do. Create a two S3 bucket. One would be the source bucket where the data will be uploaded, and the other one is a destination bucket where the data will be backed up from the source bucket. And for these buckets to talk to themselves, it's going to require an IAM role. And then for the automatic copy, it's going to require an Lambda function to copy the files from the source bucket to the destination bucket. And what triggers the Lambda function? The Lambda function is triggered every time there's a change in the metadata for the bucket, and this data is then uploaded into the destination bucket. And after setting all this up, we can literally test it by putting a data in the source bucket that's going to automatically replicate, or that's going to automatically copy the data from the source bucket to the destination bucket. Alright, let's see how we can replicate data between two buckets. Well, we have a feature to cross-region replicate in S3. That's a feature that comes along with S3. What if you want to replicate between two different buckets in two different accounts? In those cases, we can use Lambda to replicate the data between the buckets. So you put one data, or you put data in the source bucket, and that data gets replicated to the destination bucket. And let's see how that's done. The procedure here would be to have two buckets to begin with, and then create an IAM role that lets you access to pull data from the source bucket and put data on the destination bucket, and then create Lambda files or Lambda event or triggers to actually look for event in the source bucket, and anytime a new data gets added, Lambda gets triggered, copies the data from the source bucket and moves the data to the destination bucket, and it uses the IAM role and policy for the needed permissions. And in just a couple of clicks, we have set up a temporary backup system that can run seamlessly without any manual intervention, and that can be as near real time as possible. Alright, that's the concept, and let's see how it is done real time through this lab. So to begin with, we need two buckets. So I have here a source bucket and a destination bucket, and the source bucket as of now do not have any data in it, so as the destination bucket. Alright, so that's one down. The second would be to create an IAM role. Alright, so let me create an IAM role, and the role is going to have this policy in it. A policy that's allowing get object on the source bucket, and a policy that's allowing put object on the destination bucket. And here I'm going to use, or I'm going to paste my source and destination buckets ARN. Alright, go to services, go to S3, source bucket. Alright, click on the source bucket and copy the bucket ARN. So that would be the source bucket ARN. Right, on the destination bucket, copy the destination bucket ARN, and this is going to be my destination bucket ARN. So with this, I'm going to create a policy. All right, go to IAM and create a policy. Now I have already created a policy with the same information. All right, destination bucket ARN, and a policy is available with the name S3 bucket copy Lambda. Attach the policy to the role. Right, go to roles, create a role. Lambda is the service that's going to use it. In here, attach the policy that we have created. Right, give it a name, and then create a role. Now I have a role created as well. Right, copy Lambda, and that's having the policy that we have created sometime back. Now create a Lambda function. Right, so go to Lambda, create a function, give it a name like S3 bucket copy. Right, choose the role that we want to use. Right, that's the role that we want to use. Copy 1, 2, create a function. All right, and in here we're going to use Node.js code. Right, I have a sample code. This can be used as template. In here, replace the source bucket with the name of the source bucket, and the destination bucket with the name of the destination bucket. This is a Node.js code that gets run when an event gets triggered. Now what's an event? Anytime there is a new object placed in the S3 bucket, it creates an event, and the event triggers Lambda, and Lambda checks the source S3 bucket, picks the data, puts it in the destination bucket. All right, paste it here. Paste it here and click on save. All right, now before you click on save, just ensure that you have the appropriate roles defined. That's all you got to do. Click on save. All right, now I already have created a Lambda function, all right, which is the same thing, same code, and the role is attached to it. Now it's running, it's active. Now let's put this to test. Go to S3, pick the source bucket, put some data in it, right? And in theory, those data should be present in the destination bucket as well. There you go. It's all done by Lambda.
So today's session is on AWS Elastic Beanstalk. So what's in it for you today? We'll be discussing about what is AWS, why we require AWS Elastic Beanstalk, what is AWS Elastic Beanstalk, the advantages, disadvantages, the components of Beanstalk, along with that, the architecture and the companies that are primarily using the AWS Beanstalk. So let's get started and first understand what is AWS. AWS stands for Amazon Web Services. It's a cloud provider and that offers a variety of services such as compute power, database storage, content delivery, and many other resources. So we know that AWS is the largest cloud provider in the market, and so many services are available in the AWS where you can apply the business logics and create the solutions using the cloud platforms. Now, why AWS Elastic Beanstalk? Now, what happened earlier and that whenever the developer used to create the software or the modules related to the softwares, it has to be joined together to create a big application. Now, one developer creates a module that has to be shared with another developer. And if the developers are geographically separated, then it has to be shared over a medium, probably an internet. So that is going to take some time. It would be a difficult process, and in return it makes the application or a software development a lengthier process, the building of the software development a lengthier process. So there were challenges which the developers were facing earlier, and to overcome that we have the Beanstalk as a service available in the AWS. So why AWS Elastic Beanstalk is required? AWS Elastic Beanstalk has made the life of the developers quite easy in terms of that they can share the applications across different devices at a shorter time duration. Now let's understand what is AWS Elastic Beanstalk. AWS Elastic Beanstalk is a service which is used to deploy and scale web applications by developers. Not only web application, any application that is being developed by the developers. This is a symbol representation of the AWS Elastic Beanstalk. Now, along with that, the AWS Elastic Beanstalk supports the programming language, the runtime environments that are Java, .NET, PHP, Node.js, Python, RubyGo, and Docker. And in case if you're looking for any other programming language or a runtime environment, then you can make a request with AWS to arrange that for you. Now, what are the advantages associated with the Elastic Beanstalk? First advantage is that it's a highly scalable service. Now, when we talk about the scalability, it means that whenever we require the resources in demand, we can scale up the resources or we can scale down the resources. So that is kind of a flexibility we get in terms of changing the type of resources whenever we need it. And in that case, the Elastic Beanstalk is a highly scalable service. Now that is something which is very difficult to achieve in case of an on-prem environments, because you have to plan for the infrastructure, and in case if you're short of the resources within that infrastructure, then you have to procure it again. The second advantage associated with the Beanstalk is that it's a fast and simple to begin. Now when we say it's fast and simple, that means that you just have to focus on the development of an application, building an application, and then you can just deploy the application directly using the Beanstalk. What the Beanstalk is going to do, that every networking aspect is being taken care by the Beanstalk. It deploys your application in the backend on the servers, and then you can directly access your application using the URL or through the IP address. The third advantage is that it offers the quick deployment. That is what we discussed in the fast and simple to begin as well. So why it offers a quick deployment? You don't have to bother about the networking concepts. You just have to focus on the application development, and then you can just upload your application, deploy that, and then you are good to go. The other advantage is that it supports multi-tenant architecture. When we talk about tenants or multi-tenants, that means we can have a virtual environments for separate organizations or the divisions within the organizations that will be virtually isolated. So likewise, you can have virtually isolated environments created on the Beanstalk, and they can be separated, used as a separate entities or a separate divisions within the organization. And we know that it's a flexible service. Since it's a scalable, then it is a flexible also. Now coming to the simplifies operations as an advantage. Now once the application is deployed using the Beanstalk, then it becomes very easy to maintain and support that application using the Beanstalk services itself. And the last advantage that we can have from the Beanstalk is that it's a cost efficient service. The cost efficient, as we know that many of the AWS services are cost effective. The cost optimization can be better managed using the AWS Beanstalk as compared to if you are developing or if you are deploying any kind of an application or a solution on the on-prem servers. Now, there are some components that are associated with the AWS Beanstalk, and it has to be created in the form of a sequence manner. So AWS Elastic Beanstalk consists of few important components which are required while developing an application. Now, what are these components? These are 4 components. One is application, the second is application version, the third is environment, and the fourth one is the environment tier. And we have to progress while deploying our applications or the softwares using the same sequence. Now let's understand what are the different components of the Beanstalk are. The application. It refers to a unique label which is used as a deployable code for a web application. So generally you deploy your web application or you create your application, and that is something which is basically used as a unique label. Then the second component is application versions. So it resembles a folder which stores a collection of components such as environments, versions, and environment configurations. So all these components are being stored using the application version. The third most important component is the environment. In the environment, only the current versions of the applications runs. Now remember that Elastic Beanstalk supports multiple versions as well. And using the environment, you can only run the current version of the application. If you wanted to have another version of an application to be running, then you have to create another environment for that. Then comes the environment tier. And in the environment tier, it designates the type of application that the environment runs on. Now generally there are 2 types of environment tier. One is the web and the other one is the worker node, and that's something which we'll be discussing later as well. Now let's understand how does Elastic Beanstalk in AWS works. So first we have to create an application, and this is a task that would be done by the developers. And for that you can actually select any runtime environment or a programming language like Java, Docker, Ruby, Go, Perl, or Python as well. And once you select that environment, you can develop your application using that runtime environments. Now after that, once the application is created, then you have to upload the version of an application on the AWS. And after that, once the version is uploaded, and then you have to launch your environment. So just have to click on the buttons, that's it. Nothing more you have to do. Once the environment is launched, then you can actually view that environment using a web URL or using the IP address. Now what happens in that case is when you launch an environment, in the backend, the Elastic Beanstalk automatically runs an EC2 instance. And using a metadata, the Beanstalk deploys your application within that EC2 instance. That is something which you can look into the EC2 dashboard as well. So you don't have to take care of the security groups, you don't have to take care of the IP addressing, and even you don't have to log in into the instance and deploy your application. It would be done automatically by the Beanstalk. It's just that you just have to monitor the environment, and the statistics will be available there itself in the Beanstalk dashboard. Otherwise, you can view those statistics in the CloudWatch logs as well. Now in case if you wanted to update any kind of a version, then you just upload a new version and then just deploy that and then monitor your environment. So these are the essentials to create a local applications for any platform, whether it's a Node.js, Python, etc. These are the things that you have to actually take care, and this is the sequence you have to follow while creating an environment. So you can say that it's a 4 steps creation of or deployment of your application. That's it. Now after users upload their versions, the configuration is automatically deployed with a load balancer. Yes, and with a load balancer, that means you can access the applications using the load balancer DNS also. And apart from load balancer, if you wanted to put any other feature that includes the auto scaling, for example, if you wanted to create your EC2 instances where the application will be deployed within the virtual private cloud or in a particular subnet within the VPC, all those features that are available, and you can select them using the Beanstalk itself. You don't have to move out to the VPC. You don't have to actually go to the EC2 dashboard and select all those separately. Everything would be available within the Beanstalk dashboard. So that's what it says in the presentation, that after creating an application, the deploy service can be specifically accessed using the URL. So once the environment is created, there will be a URL defined. Now you can put a URL name also. That is something which you wanted to put for your application. You can define that. You can check for the availability of that URL, and then you have to use that URL to access your application over the browser. Now, once it is done, then in the monitor environment, it says the environment is monitor, provided capacity provisioning, load balancing, auto scaling, and monitor features. All those features are available there itself in the Beanstalk. Now let's understand the architecture of AWS Elastic Beanstalk. Now there are two types of environments that you have to select. You can select. One is the web server environment and the other one is the worker environment. So based on the client requirement, Beanstalk gives you two different types of environment that you have to select. Generally, the web server environment is the front end facing. That means the client should be accessing this environment directly using a URL. So mostly web applications are deployed using that environment. The worker environment is the backend applications or the micro apps, which are basically required to support the running of the web applications. Now it depends on the client requirement what kind of an environment you wanted to select. Now in the web server environment, it only handles the HTTP request from the clients. So that's why we use the web server environment mostly for the web applications or any application which works on the HTTPS requests. So it's not only the HTTP, you can use the HTTPS as well. The worker environment, it processes background tasks and minimizes the consumption of resources. So again, it is just like a kind of a microservice or an application services that are running in the backend to support the web server environment. Now coming to the understanding of the AWS Beanstalk. So this is how the architecture of the AWS Beanstalk is designed, and you can refer to that image also. Now in the web server environment, let's say if we select a web server environment, and it says that if the application receives client request, the Amazon Route 53 sends these requests to the Elastic Load Balancer. Now obviously we discussed here that the web server environment is primarily an environment which receives the HTTP requests. It's a kind of a client facing environment. Now if the application receives a client request from the Amazon Route 53, this Route 53 is a service which is primarily used for DNS mapping. It's a global service and you can route the traffic from the Route 53, matching your domains towards the load balancer. And from the load balancer, you can point that traffic to the web server environment. Obviously, the web server environment is nothing. It's just the EC2 instances that would be running in the backend. Now, here in the diagram, you can see that there are two web server environments and they are created in the auto scaling group. That means there is some kind of scaling options that are defined as well. And these instances are created in an availability zone, or they can be created in a different availability zone also for the redundancy as well. And these web application servers are further connected to your databases, which primarily will be in a different security groups. Probably it can be an RDS database also. So all these functionalities, all these features are basically available on the Elastic Beanstalk dashboard itself. Now what happens in that case is if the application receives client requests, Amazon Route 53 send these requests to the load balancer. Later, the load balancer shares those requests among the EC2 instances. How does that happen? It happens using a predefined algorithm. The equal distribution of a load is distributed to both the EC2 instances or n number of EC2 instances running in the availability zone. Now in the availability zones, every EC2 instance would have its own security group. They can have a common security group also. They can have their own security group as well. Now, after the security group, the load balancer is then connected to the Amazon EC2 instance, which are part of the auto scaling group. So that's something which we have discussed already. Now, this auto scaling group would be defined from the Beanstalk itself, and there will be some scaling options that will be created. It could be a possibility that it might be the minimum number of instances that would be running as of now, and based on the threshold defined, it may increase the number of EC2 instances, and the load balancer will keep on distributing the load to as many instances that will be created inside the availability zones. Obviously, there will be an internal health check that the load balancer will be first doing before distributing the real-time traffic to these instances created by the Beanstalk. Now what does auto scaling group does? It automatically starts the additional EC2 instance to accommodate increasing load on your application. That's something which we know that. And also it monitors and scales instances based on the workload as well. So depends on what kind of a scaling threshold you have defined in the auto scaling groups. And when the load of an application decreases, the EC2 instance will also be decreased. So whenever we talk about the auto scaling, generally it comes in our mind is that we scale up the resources. That means it increases the EC2 instances. In the auto scaling, you might have the scale down option also, scale down policy also created, in which if the load minimizes, it can terminate the additional EC2 instances as well. So that is something which will be automatically managed. All these features can be achievable using the Elastic Beanstalk, and with this feature accommodated, it gives you the better cost optimization in terms of managing your resources. Now it says that Elastic Beanstalk has a default security group, and the security group acts as a firewall for the instances. Now here in this diagram, it says about the security group, auto scaling also. You might create it in a default VPC also. You might create it in your custom VPC also, where you can have the additional level of security is also created. You can have the NACLs, NACLs also defined here before the security groups. So that would give you the additional filtering option or the firewall option. Now it says that with these groups, with these security groups, it allows establishing security groups to the database server as well. So every database would also have its own security group, and the connection can be created between the web servers environment that is created by the Beanstalk to the database security groups as well. Now let's discuss about the worker environment. Now, understanding the worker environment, what happens is that the client, the web server environment is the client facing. The client sends a request for an access to the web server. And in this diagram, the web server further sends it to the SQS, which is a simple queue service. And the queue service sends it to the worker environment. And then whatever the worker environment is created for doing some kind of a processing or some kind of an application that is running in the backend, that environment initiates and then send back the results to this SQS and vice versa. So let's understand the architecture of a AWS Elastic Beanstalk with the worker environment. So when a worker environment here is launched, AWS Elastic Beanstalk installs a server on every EC2 instance. So that is in the case of a web server environment also. And later the server passes the request to the simple queue service. Now this service is an asynchronous service. Instead of a simple queue service, you can have other services also. It is not necessary that you need to have the SQS also. This is an example that we are discussing about. And the SQS shares those messages via a post request to the HTTP path over the worker environment. And there are many case studies also with respect to this kind of an environment that is being created, that is being done on many customers. And you can search for these kind of a case studies available on the internet. Now the worker environment executes the task given by the SQS with the HTTP response after the operation is completed. Now here what happens is a quick recap. The client requests for an access of an application to a web server using an HTTP request. The web server passes that request to the queue service. The queue service shares the message with the worker. Probably a worker might be the manual worker, and generally it's an automated worker. So it would be shared via the worker environment only. And the worker sends back the response with the HTTP response back to the queue. That response can be viewed directly from the queue service by the client using the web server. So this is one of the examples. Likewise, as I said, that there can be many other examples also where you can have the worker environments defined. Now, what are the companies that are using the Elastic Beanstalk? These are few of the companies that are primarily using. One is Zillow, Jelly Button Games, then you have League of Women Voters, eBury. These are some of the few listed companies, and obviously you search on the AWS site and you'll find many more organizations that are using the Elastic Beanstalk primarily for deploying their applications. Now the next thing is to go with the practicals, that how actually we use the Elastic Beanstalk. So let's look into the demo using the AWS Elastic Beanstalk. Now first you have to log in into the AWS console, and I'm sure that you might be having the accounts created, or you can use the IAM credentials as well. And then you have to select the region also. Now I am in the North Virginia region. Likewise, you can select any of the regions that are listed here. Now click on the services and you have to search for the Elastic Beanstalk. You can find the Elastic Beanstalk under the compute section. So here itself, you'll find the Elastic Beanstalk as a service. Now open this service, and there it will give you an option to create an environment. You have to specifically select an environment, probably a worker environment or a web service environment. So let's wait for the service to open. So we have the dashboard now available with us. This is how the Elastic Beanstalk looks, and this is the symbol representation of a beanstalk. Now what we have to do is we have to click on Get Started, and that will load, and you have to create a web app. So instead of creating a web app, what we'll do, we'll create a new application. So just click on Create a New Application. Put an application name. Let's say we put something like XYZ. You can put any description to your application. Let's say it's a demo app, and click on Create. Now it says you have to select an environment. Now the environment, the application name XYZ is created. You just have to select an environment. So click on Create One now, and it is going to ask you that what kind of an environment tier you wanted to select. So as we discussed that there are two types of environments. One is the web server and the other one is the worker environment. Let's look into it, what is defined by the AWS. AWS says that it has two types of environment tiers to support different types of web applications. Web servers are standard applications that listen for and then process HTTP requests, typically over port number 80. Workers are specialized applications that have a background processing task that listens for message on an Amazon SQS queue. Workers application posts those messages to your application by using the HTTP response. So that's what we saw in the case of the Beanstalk slides also. Now the usability of a worker environment can be anything. Now we'll do a demo for creating a web server environment. So just click on select and we have the environment name created. Now we can define our own domain. It ends with the region.elasticbeanstalk.com. Let's say I look for a domain which is XYZ only. That's the environment name. Now I'll check for the availability whether that domain name is available with us or not. And it says we don't have that domain name. So probably I'll try to make it with some other name, and let's look for the availability XYZ ABC, and it says yes, it is available. Now once I deploy my application, I would be able to access the application using this complete DNS. So you can put a description, it's a demo app that we are creating, and then you have to define a platform as well. Now these are the platforms that are supported by the AWS. Let's say I wanted to run a Node.js environment. So I'll just click on the Node.js platform. The application codes is something which is basically developed by the developers, and you can upload the application right now, or you can do that later as well once the environment is ready. Now either you can select to create an environment if you wanted to go with all the default settings. Otherwise, if you wanted to customize it more, you can click on configure more options. So let's click on configure more options. And here you would be able to define various different features like the type of an instance. For example, what kind of an EC2 instance or a server that should be running so that the Beanstalk can deploy your applications over it. If you wanted to modify, just click on a modify button, and here you can modify your instances with respect to the storage as well. Now apart from that, if you wanted to do some modification in the case of monitoring, in the case of databases, in the case of security, or in the case of a capacity, let's look into the capacity. So here you can actually do the modification. So in the capacity, you can select the instance type also. By default, it is t2.micro, but in case if your application requires a larger type of an instance, then you can actually go for the instance type as well. Similarly, you can define your AMI IDs also, because obviously for the application to run, you would require the operating system also. So you can select that particular AMI ID for your operating system as well. Let's cancel that. Likewise, you have many other features that you can actually define here from the dashboard, and you don't have to go to the EC2 dashboard to do the modifications. Now let's go and create an environment. Let's assume that we are going with the default configuration. So this is going to create our environment. The environment is being created, and you can get the environment and the logs defined in the dashboard itself. So you'll see that the Beanstalk environment is being initiated, the environment is being started, and in case if there would be any errors or if it is deployed correctly, you'll get all the logs here itself. Now the environments are basically color coded. So there are different color codings that are defined. If you get the environment in a green color, that means everything is good to go. So here you can see that it has created an Elastic IP. It has checked the health of the environment. Now it has created the security groups, and that would be an auto security groups created by the Beanstalk. And the environment creation has been started. You can see that Elastic Beanstalk as Amazon S3 storage bucket for your environment data as well. This is the URL through which you will be accessing the environment, but right now we cannot do that since the environment is being created. Let's click on the application name, and here you can see that it is in a gray color. That means right now the build is being done. It is being created. Once it will be successfully created, it should change to the green color, and then we will be able to access our environment using the URL. Now if I move to the EC2 instances and see in the EC2 dashboard, if I see whether the instance is being created by the Beanstalk or not. So let's see, and let's see what are the differences in terms of creating an instance manually and getting it created from the Beanstalk. So click on the EC2. Let's go to the old EC2 experience. That's what we are familiar with. And let's see what's there in the dashboard. So here you can see one running instance. Let's open that. And the XYZ environment, which was created from the Beanstalk, is being initiated. The instance is being initiated. And that is something which is being done by the Beanstalk itself. We have not gone to the dashboard and created it manually. Now, in the security groups, if you see that, here the AWS Beanstalk security groups are defined. It has the Elastic IPs also defined. So everything is being created by the Beanstalk itself. Right. Now let's go back to the Beanstalk and let's look into the status of our environment, whether the color coding has been changed from gray to green or not. And here you can see the environment is successfully created and we have that environment colored in green. We'll access the environment and it says it's a web server environment. Its platform is Node.js running on 64-bit Amazon Linux AMI and it's a sample application. Health status is okay. Now the other thing is that if you do not want to use the web console, the management console to access the Beanstalk, then the Beanstalk offers you the Elastic Beanstalk CLI as well. So you can install the command line interface and then you have the command references, CLI command references that you can actually play with and get your applications deployed using the Beanstalk itself. So this is one of the sample CLI commands that you can actually look into. Now let's look into the environment. Let's click on the environment and we'll be represented with the URL. It says health is okay. These are the logs that you have to follow in case if there are any issues. The platform is Node.js. That is what we selected. Now the next thing is you just have to upload and deploy your applications. So just click on upload and deploy. Select the version label or the name. Select file and wherever your application is hosted at, just select that, upload it and deploy your application. You'll see that like your environment is created, similarly your application will be deployed automatically on the instance and from this URL you will be able to view the output. It is as simple as just like you have to follow these 4 steps. Now let's see whether the Node.js environment is running on our instance before deploying an application. So we'll just click on this URL. Since the Beanstalk has already opened up the security groups or HTTP port 80 for all, we can actually view that output directly from the URL. So we have the Node.js running, that's visible here. And after that, you just have to upload and deploy your application. And then from that URL, you can get the output. Now this URL, you can map it with the Route 53 service. So using the Route 53 DNS services, the domain names can be pointed to the Elastic Beanstalk URL. And from there, it can be pointed to the applications that are running on the EC2 instance. Whether you wanted to point it to the URL directly using the Beanstalk, you can do that. Otherwise, as we saw in the slides, you can use the Route 53, point it to the load balancer, and then point it to the instances directly also, once it is created by the Beanstalk. So that was the demo, guys, with respect to the Beanstalk and how we can actually run the environments. Apart from that, the operational tasks like system operations, you can manage all these things from the environment dashboard itself. So you have the configurations, you have the logs, you can actually check the health status of your environment, you can do the monitoring, and you can actually get the alarms and the events here. So let's say if I wanted to see the logs, I can request for the logs here itself, and I'll be represented with the full log report, and I can now download that log file and I can view the logs. So it's so we have this bundle logs in the zip file. All right. So if you want to see some kind of logs with respect to Elastic Beanstalk activity, it's in the form of a notepad, and here you can see what all configurations the Beanstalk has done on your environment, on your instance. Similarly, you can go for the health, monitoring, alarms, events, and all those things.
If you are looking to become an AWS Cloud Architect to excel your career, then have a look at AWS Cloud Architect Masters program by Simplilearn. With this certification course, you will learn architectural principles, scalability, security, and key components like S3 and CloudFormation. Become expert in the tools like Amazon EC2, AWS Lambda, Amazon DynamoDB, Amazon CloudFormation, and much more. Our AWS Cloud Architect training is great for beginners. However, AWS recommends at least 1 year of relevant experience before pursuing this program. So hurry up and try your hands on this amazing course. Use discount coupon YTBE15 to get handsome discount. Find the course link in the description box. If you are looking to learn cloud computing Enroll into professional cloud computing program in Cloud Computing and DevOps by Simplilearn and gain hands-on experience with industry projects. 1 year experience is preferred to grab the course. Find the course link in the description box.
Here we're going to talk about Amazon ECS, a service that's used to manage Docker containers. So without any further ado, let's get started. In this session, we would like to talk about some basics about AWS, and then we're going to immediately dive into why Amazon ECS and what is Amazon ECS in general, and then it uses a service called Docker, so we're going to understand what Docker is. And there are competitive services available for ECS. ECS is not the own and only service to manage Docker containers. But why ECS? Advantage of ECS. We will talk about that. And the architecture of ECS. So how it functions, what are the components present in it, and what are the functions that it does. Each and every component, what are all the functions that it does. All those things will be discussed in the architecture of Amazon ECS. And how it works, how it all connects together. That's something we will discuss. And what are the companies that are using ECS? What were the challenge and how ECS helped to fix the challenge? That's something we will discuss. And finally, we have a wonderful lab that talks about how to deploy Docker containers on an Amazon ECS. So let's talk about what is AWS. Amazon Web Service, in short called as AWS, is an web service in the cloud that provides a variety of services such as compute power, database storage, content delivery, and a lot of other resources, so you can scale your business and grow, not focus more on your IT needs and the rest of the IT demands. Rather, you can focus on your business and let Amazon scale your IT, or let Amazon take care of your IT. So what is that you can do with AWS? With AWS, we can create, deploy any application in the cloud. So it's not just deploying, you can also create your application in the cloud. It has all the tools and services required, the tools and services that you would have installed in your laptop or you would have installed in your on-premises desktop machine for your development environment. The same thing can be installed and used from the cloud. So you can use cloud for creating, and not only that, you can use the same cloud for deploying and making your application available for your end user. The end user could be internal users, the end user could be in the internet, the end user could be kind of spread all around the world. It doesn't matter. So it can be used to create and deploy your applications in the cloud. And like you might have guessed, now it provides service over the internet. That's how your users worldwide would be able to use the service that you create and deploy, right? So it provides service over the internet. So that's for the end customer. And how will you access those services? That's again through the internet. It's like the extension of your data center in the internet. So it provides all the services in the internet. It provides compute service through the internet. So in other words, you access them through the internet. It provides database service through the internet, over the internet. In other words, you can securely access your database through the internet, and a lot more. And the best part is this is pay as you go, or pay only for what you use. There is no long-term or beforehand commitment. Here, most of the services does not have any commitment. So there is no long-term and beforehand commitment. You only pay exactly for what you use. There's no overage, there's no overpaying, right? There's no buying in advance, right? You only pay for what you use. Let's talk about what ECS is. So before ECS, before containers, right? ECS is a service that manages Docker containers, right? It's not a product or it's not a feature all by itself. It's a service that's dependent on Docker container. So before Docker containers, all the applications were running on VM or on a host or on a physical machine, right? And that's memory bound, that's latency bound. The server might have issues, on and on, right? So let's say this is Alice and she's trying to access her application which is running somewhere in her on-premises, and the application isn't working. What could be the reason? Some of the reasons could be memory full, the server is currently down at the moment, we don't have another physical server to launch the application, a lot of other reasons. So a lot of reasons why the application wouldn't be working in on-premises. Some of them are memory full issue and server down issue, very less high availability, or in fact single point of failure and no high availability, if I need to tell it correctly. With ECS, the services can kind of breathe free, right? The services can run seamlessly. Now how is that possible? Now, those things we will discuss in the upcoming sessions. So because of containers and ECS managing containers, the applications can run in a high available mode. They can run in a high available mode, meaning if something goes wrong, right, there's another container that gets spun up and your application runs in that particular container. Very less chances of your application going down. That's what I mean. This is not possible with a physical host. This is very less possible with a VM, or at least it's going to take some time for another VM to get spun up. So why ECS, or what is ECS? Amazon ECS maintains the availability of the application and allows every user to scale containers when necessary. So it not only meets the availability of the application, meaning one container running your application or one container hosting your application should be running all the time. So to meet that high availability, availability is making sure your service is running 24/7. So container makes sure that your services run 24/7. Not only that. Suddenly, if there is an increase in demand, how do you meet that demand? Right? Let's say you have like 1,000 users. Suddenly, the next week there are like 2,000 users. Right. So how do you meet that demand? Container makes it very easy for you to meet that demand. In case of VM or in case of physical host, you literally will have to go buy another physical host, or add more RAM, add more memory, add more CPU power to it, right? Or kind of club 2-3 hosts together, clustering. You would be doing a lot of other things to meet that high availability and also to meet that demand. But in case of ECS, it automatically scales the number of containers. It automatically scales the number of containers needed, and it meets your demand for that particular hour. So what is Amazon ECS? The full form of ECS is Elastic Container Service, right? So it's basically a container management service which can quickly launch and exit and manage Docker containers on a cluster. So what's the function of ECS? It helps us to quickly launch and quickly exit and manage Docker containers. So it's kind of a management service for the Docker containers you will be running in Amazon or running in the AWS environment. So in addition to that, it helps to schedule the placement of container across your cluster. So it's like this. You have two physical hosts, joined together as a cluster. And ECS helps us to place your containers. Now, where should your container be placed? Should it be placed in host 1? Should it be placed in host 2? So that logic is defined in ECS. We can define it. You can also let ECS take control and define that logic. Most cases you will be defining it. So schedule the placement of containers across your cluster. Let's say two containers want to interact heavily. You really don't want to place them in two different hosts, right? You would want to place them in one single host so they can interact with each other. So that logic is defined by us. And these container services, you can launch containers using AWS Management Console, and also you can launch containers using SDK kits available from Amazon. You can launch through a Java program. You can launch container using an .NET program. You can launch container using an Node.js program, as in when the situation demands. So there are multiple ways you can launch containers through Management Console and also programmatically. And ECS also helps to migrate application to the cloud without changing the code. So anytime you think of migration, the first thing that comes to your mind is that how will that environment be? Based on that, I'll have to alter my code. What's the IP? What is the storage that's being used? What are the different parameters I'll have to include? The environment parameters of the new environment. with containers, now that worry is already taken away, because we can create an pretty exact environment. The one that you had on premises, the same environment gets created in the cloud. So no worries about changing the application parameter, no worries about changing the code in the application. Right? You can be like, if it ran in my laptop, a container that was running in my laptop, it's definitely going to run in the cloud as well, because I'm going to use the same container in the laptop and also in the cloud. In fact, you're going to ship it. You're going to move the container from your laptop to Amazon ECS and make it run there. So it's like the very same image, the very same container that was running in your laptop will be running in the cloud or production environment. So what is Docker? We know that ECS helps to quickly launch, exit, and manage Docker containers. What is Docker? Let's answer that question. What is Docker? Now, Docker is a tool that helps to automate the development of an application as a lightweight container so that the application can work efficiently in different environments. This is pretty much what we discussed right before the slide. I can build an application in my laptop or in on-premises in a container environment, Docker container environment, and anytime I want to migrate, right, I don't have to kind of rewrite the code and then rerun the code in that new environment. I can simply create an image, a Docker image, and move that image to that production or the new cloud environment and simply launch it there. Right? So no compiling again, no relaunching the application. Simply pack all your code in a Docker container image and ship it to the new environment and launch the container there. That's all. So Docker container is a lightweight package of software that contains all the dependencies. So because, when packing, you'll be packing all the dependencies. You'll be packing the code. You'll be packing the framework. You'll be packing the libraries that are required to run the application. So in the new environment, you can be pretty sure, you can be guaranteed that it's going to run because it's the very same code, it's the very same framework, it's the very same libraries that you have shipped, right? There's nothing new in that new environment. It's the very same thing that's going to run in that container. So you can be rest assured that they are going to run in that new environment. And these Docker containers are highly scalable and they are very efficient. Suddenly you wanted like 20 more Docker containers to run the application. Think of adding 20 more hosts, 20 more VMs, right? How much time would it take? And compared to that time, the amount of time that Docker containers would require to kind of scale to that amount, like 20 more containers, it's very less, or it's minimal or negligible. So it's a highly scalable and it's a very efficient service. You can suddenly scale number of Docker containers to meet any additional demand. Very short boot up time because it takes it's not going to load the whole operating system. And these Docker containers, they use the Linux kernel and features of the kernel like C groups and namespaces to kind of segregate the processors so they can run independently any environment, and it takes very less time to boot up. And the data that are stored in the containers are kind of reusable. So you can have an external data volume and I can map it to the container, and whatever the space that's occupied by the container and the data that the container puts in that volume, they are kind of reusable. You can simply remap it to another application. You can kind of remap it to the next successive container. You can kind of remap it to the next version of the container, next version of the application you'll be launching, and you don't have to go through building the data again from the scratch. Whatever data the container was using previously or the previous container was using, that data is available for the next container as well. So the volumes that the containers uses are very reusable volumes. And like I said, it's isolated application, so it kind of isolates by its nature. It kind of, by the way it's designed, by the way it is created, it isolates one container from another container, meaning anytime you run applications on different containers, you can be rest assured that they are very much isolated. Though they are running on the same host, though they are running on the same laptop, let's say, though they are running on the same physical machine, let's say, running 10 containers, 10 different applications, you can be sure that they are well disconnected or well isolated applications. Now let's talk about the advantages of ECS. The advantage of ECS is improved security. Its security is inbuilt in ECS. With ECS, we have something called as a container registry. That's where all your images are stored, and those images are accessed only through HTTPS. Not only that, those images are actually encrypted, and access to those images are allowed and denied through identity and access management policies, IAM. And in other words, let's say two containers running on the same instance. Now, one container can have access to S3 and the others, or the rest of the others, are denied access to S3. So that kind of granular security can be achieved through containers when we mix and match the other security products available in Amazon, like IAM, encryption, accessing it using HTTPS. These containers are very cost efficient. Like I've already said, these are lightweight processes. Right? We can schedule multiple containers on the same node, and this actually allows us to achieve high density on an EC2 instance. Imagine an EC2 instance that's very less utilized. That's not possible with a container, because you can actually dense or crowd an EC2 instance with more container in it, so to best use those resources. In EC2, straightforward, you can just launch one application. But when we use containers, you can launch like 10 different applications on the same EC2 server. That means 10 different applications can actually feed on those resources available and can benefit the application. And ECS not only deploys the container, it also maintains the state of the containers, and it makes sure that the minimum set of containers are always running based on the requirement. That's another cost efficient way of using it, right? And anytime an application fails, and that has a direct impact on the revenue of the company, and ECS makes sure that you're not losing any revenue because your application has failed. And ECS is a pretty extensible services. It's like this: in many organizations, there are majority of unplanned work because of environment variation. A lot of firefighting happens when we kind of deploy the code from one, or kind of move the code or redeploy the code in a new environment. A lot of firefighting happens there. Right? This Docker containers are pretty extensible. Like we discussed already, environment is not a concern for containers, because it's going to kind of shut itself inside a Docker container, and anywhere the Docker container can run, the application will run exactly the way it performed in the past. So environment is not a concern for the Docker containers. In addition to that, ECS is easily scalable. We have discussed this already. And it has improved compatibility. We have discussed this already. Let's talk about the architecture of ECS. Like you know now, the architecture of ECS is the ECS cluster itself. That's group of servers running the ECS service, and it integrates with Docker, right? So we have a Docker registry. Docker registry is a repository where we store all the Docker images or the container images. So it's like three components. ECS is of three components. One is the ECS cluster itself. Right? When I say ECS itself, I'm referring to ECS cluster of servers that will run the containers. And then the repository where the images will be stored, right? The repository where the images will be stored, and the image itself. So container image is the template of instructions which is used to create a container, right? So it's like, what's the OS? What is the version of node that should be running? And any additional software do we need? So those questions gets answered here. So it's the template of instructions which is used to create the containers. And then the registry is the service where the Docker images are stored and shared. So many people can store there, and many people can access, or if there's another group that wants to access, they can access the image from there, or one person can store the image and rest of the team can access, and the rest of the team can store image, and this one person can pick the image from there and kind of ship it to the customer or ship it to the production environment. All that's possible in this container registry. And Amazon's version of the container registry is ECR. And there's a third party. Docker itself has a container registry, that's Docker Hub. ECS itself, which is
the group of servers that runs those containers. So these two, the container image and the container registry, they kind of handle Docker in an image format, just an image format. And in ECS is where the container gets live, and then it becomes an compute resource and starts to handle requests, starts to serve the page and starts to do the batch job, whatever your plan is with that container. So the cluster of servers, ECS, integrates well with the familiar services like VPC. VPC is known for securing. VPC is known for isolating the whole environment from rest of the customers, or isolating the whole environment or the whole infrastructure from the rest of the clients in your account, or from the rest of the applications in your account, on and on. So VPC is a service that provides or gives you the network isolation. ECS integrates well with VPC. And this VPC enables us to launch AWS resources such as Amazon EC2 instance in a virtual private network that we specify. This is basically what we just discussed. Now let's take a closer look at the ECS. How does ECS work? Let's find answer for this question. How does ECS work? ECS has got a couple of components within itself. So these ECS servers can run across availability zone. As you can see, there are two availability zones here. They can actually run across availability zones. And ECS has got two modes, Fargate mode and the EC2 mode. Right here we're seeing Fargate mode, and then here we're seeing nothing. That means it's an EC2 mode. And then it has got different network interfaces attached to it, because they need to be running in an isolated fashion, right? So anytime you want network isolation, you need separate IP, and if you want separate IP, you need separate network interface card, and that's what you have, Elastic Network Interface Card, separate Elastic Network Interface Card for all those tasks and services. And this runs within an VPC. Let's talk about the Fargate service. Tasks are launched using the Fargate service. So we will discuss about tasks. What is Fargate? Now, Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the cluster. ECS is a service that manages the containers for you, right? Otherwise, managing containers will be a full-time job. So ECS manages it for you, and you get to manage ECS. That's the basic service. But if you want Amazon to manage ECS and the containers for you, we can go for Fargate. So Fargate is a compute engine in ECS that allows users to launch containers without having to monitor the ECS cluster. And the tasks that we discussed, the tasks has two components. You see task right here. So they have two components. We have ECS container instance, and then the container agent. So like you might have guessed right now, ECS container instance is actually an EC2 instance, right, capable of running containers. Not all EC2 instances can run containers. So these are like specific EC2 instances that can run containers. They are ECS container instances. And then we have container agent, which is the agent that actually binds those clusters together, and it does a lot of other housekeeping work, right? Kind of connects clusters, makes sure that the version needed is present. So it's all part of that agent, or it's all job of that agent. Container instances is part of Amazon EC2 instance, which run Amazon ECS container agent. Pretty straightforward definition. And then a container agent is responsible for communication between ECS and the instance, and it also provides the status of the running containers. Kind of monitors the container, monitors the state of the container, make sure that the container is up and running, and if there's anything wrong, it kind of reports it to the appropriate service to fix the container, on and on. Right? So container agent, when we don't manage container agent, it runs by itself, and you really don't have to do anything to make the container agent better. It's already better. You really won't be configuring anything in the agent. And then Elastic Network Interface Card is a virtual interface network that can be connected to an instance in VPC. So in other words, Elastic Network Interface is how the container interacts with another container, and that's how the container interacts with the EC2 host, and that's how the container interacts with the internet, external world. And a cluster is a set of ECS container instances. It's not something that's very difficult to understand. It's simply a group of EC2 instances that runs that ECS agent. And this cluster handles the process of scheduling, monitoring, and scaling the request. We know that ECS can scale, the containers can scale. How does it scale? That's all monitored and managed by this ECS cluster. Let's talk about the companies that are using Amazon ECS. There are a variety of companies that use ECS clusters. To name a few, Okta uses ECS cluster, and Okta is a product that uses identity information to grant people access to applications on multiple devices at any given point of time. They make sure that they have a very strong security protection. So Okta uses Amazon ECS to run their Okta application and serve their customers. And Abima is a TV channel, and they chose to use microservices and Docker containers. They already had microservices and Docker containers, and when they thought about a service that they can use in AWS, ECS was the only service that they can immediately adapt to. And because in Abima TV the engineers have already been using Docker and Docker containers, it was kind of easy for them to adapt themselves to ECS and start using it along with the benefits that ECS provides. Previously they had to do a lot of work, but now ECS does it for them. Right. Similarly, Remain and Ubisoft, GoPro are some of the famous companies that use Amazon ECS and get benefited from its scalability, get benefited from its cost, gets benefited from its Amazon managed services, get benefited from the portability that ECS and the migration option that ECS provides. Let's talk about how to deploy a Docker container on Amazon ECS. The way to deploy a Docker container on ECS is, first we need to have an AWS account and then set up and run our first ECS cluster. So in our lab we're going to use the launch wizard to run an ECS cluster and run containers in them. And then task definition. Task definition tells the size of the container, the number of the container. And when we talk about size, it tells how much of CPU do you need, how much of memory do you need. And talking about numbers, it requires how many numbers of container you're going to launch. Is it 5, is it 10, or is it just 1 running all the time? Now those kind of information goes in the task definition file. And then we can do some advanced configuration on ECS, like load balancers and what port number you want to allow and you don't want to allow, who gets access, who shouldn't get access, and what's the IP that you want to allow and deny requests from, on and on. And this is where we would also mention the name of the container, so to differentiate one container from the other, and the name of the service. Is it an backup job? Is it a web application? Is it a data container? Is it going to take care of your data backend? And the desired number of tasks that you want to be running all the time. Those details go in when we try to configure the ECS service, right? And then you configure a cluster. You put in all the security in the configure your cluster step or configure cluster stage. And finally, we will have an instance and bunch of containers running in that instance. All right, let's do a demo. So here I have logged in to my Amazon portal, and let me switch to the appropriate region. I'm going to pick North Virginia. North Virginia, look for ECS. And it tells ECS is a service that helps to run and manage Docker containers. Well and good. Click on it. I'm in North Virginia. Just want to make sure that I'm in the right region. And go to clusters. And here we can create cluster. This is our Fargate, and this is our EC2 type launching for Linux and Windows environment. But I'm going to launch through this walkthrough portal. Right? This gives a lot of information here. So the different steps involved here is creating a container definition, which is what we're going to do right now, and then a task definition, and then service, and finally the cluster. It's a 4-step process. So in container definition, we define the
image, the base image we are going to use. Now here I'm going to launch an HTTPD or a simple HTTP web page, right? So a simple HTTPD 2.4 image is fair enough for me, and it's not a heavy application, so 0.5 gigabit of memory is enough, and again it's not a heavy application, so 0.25 virtual CPU is enough in our case, right? You can edit it based on the requirement. You can always edit it, and because I'm using HTTPD, the port mapping is already port 80. That's how the container is going to receive the request, and there's no health check as of now. When we want to design critical and complicated environments, we can include health check, right? And this is the CPU that we have chosen. We can edit it, and I'm going to use some bash commands to create an HTML page, right? This page says that, Amazon ECS sample app, right? And then it says Amazon ECS sample app. Your application is running on a container in Amazon ECS. So that's the page, the HTML page that I'm going to create, right? Index.html. So I'm going to create and put it in an appropriate location, so those pages can be served from the container, right? If you replace this with any of your own content, then it's going to be your own content. ECS comes with some basic logs, and these are the places where they get stored. That's not the focus as of now, right? So I was just saying that you can edit it and customize it to your needs. We're not going to do any customization now. We're just getting familiar with ECS now. And the task definition, name of the task definition is first run task definition, and then we are running it in a VPC. And then this is an Fargate mode, meaning the servers are completely handled by Amazon, and the task memory is 0.5 gigabit, and the task CPU is 0.25 virtual CPU. Name of the service: is it a batch job? Is it an a front end? Is it a back end? Or is it a simple copy job? What's the service? Name of the service goes here. Again, this you can edit it. And here's our security group. As of now, I'm allowing port 80 to the whole world. If I want to restrict to a certain IP, I can do that. The default option for load balancing is no load balancer, but I can also choose to have a load balancer and use port 80 to map that port 80 to the container port 80, right? I can do that. The default is no load balancer. All right, let's do one thing. Let's use load balancer. Let's use load balancer, and port 80 receives information on port 80 HTTP. What's going to be the cluster name? We're in the last step. What is the cluster name? Cluster name can be Simplilearn ECS demo. Next, we're done, and we can create. So it's launching a cluster, as you can see, and it's picking the task definition file that we've created, and it's using that to launch an service. And then these are the log groups that we discussed, and it's creating a VPC. Remember, ECS clubs well with the VPC. It's creating a VPC, and it's creating two subnets here for high availability. It's creating that security group, port 80, allowed to the whole world, and then it's putting it behind an load balancer. It generally would take like 5 to 10 minutes, so we just need to be patient and let it complete its creation. And once this is complete, we can simply access the service using the load balancer URL. And when this is running, let me actually take you to the other products or the other services that are integrated with ECS. It's getting created. Our service is getting created as of now. ECR repository. This is where all our images are stored. Now, as of now, I'm not pulling my image from ECR. I'm pulling it directly from the internet, Docker Hub. But all custom images, they are stored in this repository. So you can create a repository, call it app1, create a repository. So here's my repository. So any image that I create locally, or any Docker image that I create locally, I can actually push those images using these commands right here, and they get stored here. And I can make my ECS connect with ECR and pull images from here. So they would be my custom images. And as of now, because I'm using a default image, it's directly pulling it from the internet. Let's go to EC2 and look for a load balancer, because we wanted to access the application from behind a load balancer, right? So Here is a load balancer created for us, and anytime I put the URL, so a cluster is now created. You see there's one service running. All right, let's click on that cluster. Here is the name of our application, and here is the tasks, the different containers that we are running. And if you click on it, we have an IP, right? IP of that container, right? And it says it's running. It was created at such and such time and started at such and such time. And this is the task definition file that this container uses, meaning the template, the details, all the version details, they all come from here, and it belongs to the cluster called Simplilearn ECS demo, right? And you can also get some logs, container logs from here. So let's go back. And there are no ECS instances here because remember, this is Fargate. You're not managing any ECS instance, right? So that's why you're not seeing any ECS instance here. So let's go back to tasks and go back to the same page where we found the IP. Pick that IP, put it in the browser, and you have this sample HTML page running from an container. So let me go back to load balancer, EC2, and then under EC2 I'll be able to find a load balancer, find that load balancer, pick that DNS name, put it in the browser, and now it's accessible through the load balancer URL. Right now this URL can be mapped to other services like DNS. This URL can be embedded.
In this section, we're going to take a look at Amazon DynamoDB. Amazon DynamoDB is a fast, flexible NoSQL database service for all applications that need consistent single-digit millisecond latency at any scale. So basically, it's a fully managed NoSQL database that's suitable for document and key value store models. It's perfect for mobile, web, gaming, ad tech, etc. Let's take a look at some of the benefits of DynamoDB. Firstly, it's always stored on SSD storage, so you get great disk throughput. It's also spread across 3 geographically distinct data centers, so you get high availability built in. It's fast and flexible, and it's suited for read-heavy applications. And it's worth remembering that, because you might see questions saying, I have a read-intensive application with a database, what should I use? And DynamoDB would be the answer. DynamoDB offers 2 different read consistency types. The first is eventually consistent reads, which is the default, and then there's strongly consistent reads. So what does this mean? Well, when you write something to your DynamoDB, the changes have to be replicated to the 3 geographically distinct data centers on which DynamoDB is being stored. And obviously this isn't instant. I mean, it takes a couple of seconds or less, but it takes some time. So you can choose your read consistency depending on whether you want users to be guaranteed to have the correct data, or whether on occasions when they run a query they might not get the latest up-to-date version. Eventually consistent reads, which is the default, means that consistency is usually reached within 1 second, and repeating a read after a short time should return the correct data. And it gives the best read performance. But there is the danger of something called dirty reads, which is where you might request a read and you might not get the latest up-to-date data. If it's essential that your application gets the latest and correct data, then you can enable strongly consistent reads. And this guarantees that all writes have committed prior to the read taking place. So it could result in a delay to your results being returned. DynamoDB is charged using something called provisioned throughput capacity. When you create a DynamoDB table, you define the capacity that you want to reserve for reads and writes. For write throughput, there's a charge per hour for every 10 units of write capacity, and this equates to 36,000 writes per hour. For read throughput, there's a charge per hour for every 50 units of read capacity, and this equates to 180,000 strongly consistent reads or 360,000 eventually consistent reads. What this shows is that DynamoDB can be expensive for writes, but cheap for reads. So if your application has lots of reads, little writes, and wants to be scalable, then you should be looking at DynamoDB rather than RDS. There's also a storage cost per gigabyte for the amount of data you use with DynamoDB. And here's a very brief real-life case study. Duolingo, the online language learning site, uses DynamoDB to store 31 billion items for their online learning site, and they deliver lessons in 80 different languages. And their application hits 24,000 read units per second and 3,300 write units per second. So you can see this is a very read-heavy application and is perfect for DynamoDB. In this demonstration, we're going to take a very quick look at DynamoDB. So we go to the database section and we'll find DynamoDB, which is the managed NoSQL database provided by AWS. So we'll click on that. We're taken to the dashboard. I have no DynamoDB tables, so we need to create a new table. And we need to give it a name. So let's call this Simplilearn _ users. That's going to be the name of our table. And we have to give it a key. So a primary key. So I'm going to put in last name, as that's going to be the primary key for this particular table, and that's going to be a string. Now down here we have table settings, so we can use the default settings, and it says no secondary indexes. Its provision capacity is set to 5 reads and 5 writes, and has basic alarms with 80% upper thresholds. So if one of your read or write capacities is greater than 80% of what you've set, then you'll get an alert. So if we untick this, you can see we're not going to take a look at secondary indexes, but the thing that's important is here we can change the read and write capacity units. So if we set it both to 1, we'll get an estimated cost of just 59 cents a month there. Conversely, if we push this way up, let's push it up to 1,000, then you see it's $580 a month. So it's fully scalable and you just sort of pay for what you need. So let's just set this to 1 and 1 because this is just a demonstration. And we'll click on Create Table. Okay, so the table has been created. Okay, so our table has been created. So here we can see the details of it and its creation date. So what we now need to do is we can add items to our table. So we click on the Items tab. Okay, and we need to create an item. So you see, this should look familiar to you because we're basically doing JSON code, which is the same as for the policies in the IAM lesson. So we get to stick in a last name. So let's put me in. So we'll stick Weaver, and then we can add more values to append. Let's append a string, and we'll put a first name, and we'll put my name in there. And we could put more information if we wanted, but we're just going to leave it as that. So we click on Save. And there we are, so now I'm in there. So I'll click on Create Item, and let's add a new user in here. So we'll call the last name Smith. Let's add another string. So we'll have a new field called first name. And we'll call this person Wendy. And we'll add another row. Let's put a string in there, and we'll call this position. So this shows what you can do with NoSQL. You can basically just keep changing things, and each row can be different. So we've entered the position of manager, and we'll click Save. So now we can see that it's different. So you can do whatever you want, basically. You can add as much or as little information to each row as you wanted. Now you can also do a search. So if we wanted to add a filter, we could say search for last name with a string that equals, and there we are. So we have Weaver Mark, and just to clear that, we just remove that and click on Start Search again. So that gives you a very basic overview of what you can do with NoSQL. It's unstructured data, and you can add as much or as little as you want. Some other things to look at: the Metrics tab. Here you can see your read and write capacity, what's actually happening. So you can see whether you're paying too much or if you need to be paying too much more. There's the alarms that we talked about, so they were set up for us. Some basic alarms if the threshold goes over 0.08 reads or writes for a 12-minute period, we'll get notified. And here's the capacity. So this is the thing that you'll see in the exam, is that DynamoDB, you can just change your capacity and as and when you want on the fly. So our table's up and running, but we could just say we want 5 read capacity units and 5 write capacity units, click Save, and we're done. It's up and running straight away. And if you knew how much you wanted and you had a table that you were going to be using for a prolonged period, like a couple of years, you can click on Reserve Capacity on the left-hand side, and you can purchase reserve capacity. and you'll get some significant discounts by doing that. So if you know you have a table that's going to have some heavy reads and writes going forward, you would purchase reserve capacity. Okay, so that's a very basic overview of DynamoDB. You just need to remember that it's instantly scalable and it's a NoSQL database.
Hi guys, I'm Rahul from Simplilearn, and today I'd like to welcome you all to the greatest debate of the century. Today, I'm joined by two giants of the cloud computing industry. They'll be going head to head with each other to decide who amongst them is better. It's going to be one hell of a fight. Now, let's meet our candidates. On my left, we have AWS, who's voiced by Apeksha.
Hi guys.
And on my right, we have Microsoft Azure, who's voiced by Anjali.
Hey there.
So today, we'll be deciding who's better on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, free tier, and instance configuration. Now, let's listen to their opening statements. Let's start with AWS.
Launched in 2006, AWS is one of the most commonly used cloud computing platforms across the world. Companies like Adobe, Netflix, Airbnb, HTC, Pinterest, and Spotify have put their faith in AWS for their proper functioning. It also dominates the cloud computing domain with almost 40% of the entire market share. So far, nobody's even gotten close to beating that number. AWS also provides a wide range of services that covers a great number of domains. Domains like compute, networking, storage, migration, and so much more.
Now, let's see what Azure has to say about that.
Azure was launched in 2010 and is trusted by almost 80% of all Fortune 500 companies. The best of the best companies in the world choose to work only with Azure. Azure also provides its services to more regions than any other cloud service provider in the world. Azure covers 42 regions already, and 12 more are being planned to be made. Azure also provides more than 100 services spanning a variety of domains.
Now that the opening statements are done, let's have a look at the current market status of each of our competitors. This is the performance round. Here we have the stats for the market share of AWS, Azure, and other cloud service providers. This is for the early 2018 period. Amazon Web Services takes up a whopping 40% of the market share, closely followed by Azure at 30% and other cloud services adding 30%.
This 40% indicates most organizations' clear interest in using AWS. We are number one because of our years of experience and trust we've created among our users.
Sure, you're the market leader, but we are not very far behind. Let me remind you, more than 80% of the Fortune 500 companies trust Azure with their cloud computing needs. So it's only a matter of time before Azure takes the lead.
The rest of the 30% that is in AWS or Azure accounts to the other cloud service providers like Google Cloud Platform, Rackspace, IBM SoftLayer, and so on. Now for our next round, the comparison round. First, we'll be comparing pricing. We'll be looking at the cost of a very basic instance, which is a virtual machine of 2 virtual CPUs and 8 GBs of RAM. For AWS, this will cost you approximately $0.0928 per hour. And for the same instance in Azure, it'll cost you approximately $0.096 per hour. Next up, let's compare market share and options.
As I mentioned before, AWS is the undisputed market leader when it comes to the cloud computing domain, taking up 40% of the market share. By 2020, AWS is also expected to produce twice its current revenue, which comes close to $44 billion. Not to mention, AWS is constantly expanding its already strong roster of more than 100 services to fulfill the shifting business requirements of organizations.
All that is great, really, good for you. But the research company Gartner has released a magic quadrant that you have to see. You see, the competition is now neck to neck between Azure and AWS. It's only a matter of time before Azure can increase from its 30% market share and surpass AWS. This becomes more likely considering how all companies are migrating from AWS to Azure to help satisfy their business needs. Azure is not far behind AWS when this comes to services as well. Azure's service offerings are constantly updated and improved on to help users satisfy their cloud computing requirements.
Now, let's compare AWS and Azure's free offerings.
AWS provides a significant number of its services for free, helping users get hands-on experience with the platform, products, and services. The free tier services fall under two categories: services that will remain free forever and the others that are valid only for 1 year. The always free category offers more than 20 services, for example Amazon SNS, SQS, CloudWatch, etc. And the valid for a year category offers approximately 20 services, for example Amazon S3, EC2, Elastic Cache, etc. Both types of services have limits on their usage, for example storage, number of requests, compute time, etc. But users are only charged for using services that fall under the valid for a year category after a year of their usage.
Azure provides a free tier as well. It also provides services that belong to the categories of free for a year and always free. There are about 25 plus always free services provided by Azure. These include App Service, Functions, Container Service, Active Directory, and lots more. And as of the valid for a year, there are 8 services offered. There's Linux or Windows virtual machines, blob storage, SQL database, and few more. Azure also provides the users with credits of $200 to access all their services for 30 days. Now this is a unique feature that Azure provides, where its users can use their credits to utilize any service of a choice for the entire month.
Now let's compare instance configuration. The largest instance that AWS offers is that of a whopping 256 GBs of RAM and 16 virtual CPUs. The largest that Azure offers isn't very far behind either, 224 GBs of RAM and 16 virtual CPUs. And now for the final round. Now each of our contestants will be shown facts and they have to give explanations for these facts. We call it the rapid fire round. First, we have features in which AWS is good and Azure is better.
AWS does not cut down on the features it offers its users. However, it requires slightly more management on the user's part.
Azure goes slightly deeper with the services that fall under certain categories like Platform as a Service and Infrastructure as a Service.
Next, we have hybrid cloud, where AWS is good and Azure is better.
Okay, although AWS did not emphasize on hybrid cloud earlier, they are focusing more on technology now.
Azure has always emphasized on hybrid cloud and has features supporting it since the days of its inception.
For developers, AWS is better and Azure is good.
Of course it's better, because AWS supports integration with third-party applications.
Well, Azure provides access to data centers that provide a scalable architecture.
For pricing, both AWS and Azure are at the same level.
It's good for AWS because it provides a competitive and constantly decreasing pricing model.
And in the case of Azure, it provides offers that are constantly experimented upon to provide its users with the best experience.
And that's it. Our contestants have finished giving their statements. Now, let's see who won. Surprisingly, nobody. Each cloud computing platform has its own pros and cons. Choosing the right one is based entirely on your organization's requirements.
If you are looking to become an AWS Cloud Architect to excel your career, then have a look at AWS Cloud Architect Masters program by Simplilearn. With this certification course, you will learn architectural principles, scalability, security, and key components like S3 and CloudFormation. Become expert in the tools like Amazon EC2, AWS Lambda, Amazon DynamoDB, Amazon CloudFormation, and much more. Our AWS Cloud Architect training is great for beginners. However, AWS recommends at least 1 year of relevant experience before pursuing this program. So hurry up and try your hands on this amazing course. Use discount coupon YTBE15 to get handsome discount. Find the course link in the description box. If you are looking to learn cloud computing, enroll into professional cloud computing program in Cloud Computing and DevOps by Simplilearn and gain hands-on experience with industry projects. 1 year experience is preferred to grab the course. Find the course link in the description box.
Hi guys, today we've got something very special in store for you. We're going to talk about the best cloud computing platform available, Amazon Web Services.
Rahul, I think you said something wrong here. The best cloud computing platform is obviously Google Cloud Platform.
No, it isn't. AWS has more than 100 services that span a variety of domains.
Alright, but Google Cloud Platform has cheaper instances. What do you have to say about that?
Well, I guess there's only one place we can actually discuss this. A boxing ring.
So guys, I'm Apeksha and I will be Google Cloud Platform.
And I'm Rahul, I'll be AWS.
So welcome to Fight Night.
This is AWS versus GCP. The winner will be chosen on the basis of their origin and the features they provide, their performance in the present day, and comparing them on the basis of pricing, market share and options, the things they give you for free, and instance configuration. Now first let's talk about AWS. AWS was launched in 2004 and is a cloud service platform that helps businesses grow and scale by providing them services in a number of different domains. These domains include compute, database, storage, migration, networking, and so on. A very important aspect about AWS is its years of experience. Now AWS has been in the market a lot longer than any other cloud service platform, which means they know how businesses work and how they can contribute to the business growing. Also, AWS has over $5.1 billion of revenue in the last quarter. This is a clear indication of how much faith and trust people have in AWS. They occupy more than 40% of the market, which is a significant chunk of the cloud computing market. They have at least 100 services that are available at the moment, which means just about every issue that you have can be solved with an AWS service.
Now that was great, but now can we talk about GCP? I hope you know that GCP was launched very recently in 2011 and it is already helping businesses significantly with a suite of intelligent, secure and flexible cloud computing services. It lets you build, deploy and scale applications, websites, services on the same infrastructure as Google. The intuitive user experience that GCP provides with dashboards, wizards is way better in all the aspects. GCP has just stepped in the market and it is already offering a modest number of services. And the number is rapidly increasing. And the cost for a CPU instance or regional storage that GCP provides is a whole lot cheaper. And you also get a multi-regional cloud storage. Now what do you have to say on that?
I'm so glad you asked. Let's look at present day. In fact, let's look at the cloud market share of the fourth quarter of 2017. This will tell you once and for all that AWS is the leader when it comes to cloud computing. Amazon Web Services contributes 47% of the market share. Others like Rackspace or Verizon Cloud contribute 36%, Microsoft Azure contributes 10%, the Google Cloud Platform contributes 4%, and IBM Software contributes 3%. 47% of the market share is contributed by AWS. Do you need me to convince you any more?
Wait. All that is fine, but we only started a few years back and have already grown so much in such a less span of time. Haven't you heard the latest news? Our revenue is already $1 billion per quarter. Wait for a few more years and the world shall see.
And AWS makes $5.3 billion per quarter. It's going to take a good long time before you can even get close to us.
Yes, we'll see.
Now, let's compare a few things. For starters, let's compare pricing. For AWS, a compute instance of 2 CPUs and 8 GB RAM costs approximately $68 US. Now, a compute instance is a virtual machine in which you can specify what operating system, RAM, or storage you want to have. For cloud storage, it costs 2.3 cents per GB per month with AWS.
You really want to do that? Because GCP wins this hands down. Let's take the same compute instance of 2 CPUs with 8 GB RAM. It will cost approximately $50 per month with GCP. And as per my calculations, that's a 25% annual cost reduction when compared to AWS. Talking about cloud storage costs, it is only 2 cents per GB per month with GCP. What else do you want me to say?
Let's talk about market share and options. Now, AWS is the current market leader when it comes to cloud computing. Now, as you remember, we contribute at least 47% of the entire market share. AWS also has at least 100 services available at the moment, which is a clear indication of how well AWS understands businesses and helps them grow.
Yeah, that's true, but you should also know that GCP is steadily growing. We have over 60 services that are up and running, as you can see here, and a lot more to come. It's only a matter of time when we will have as many services as you do. Many companies have already started adopting GCP as their cloud service provider.
Now, let's talk about things you get for free. With AWS, you get access to almost all the services for an entire year with usage limits. Now, these limits include an hourly or by-the-minute basis. For example, with Amazon EC2, you get 750 hours per month. You also have limits on the number of requests to services. For example, with AWS Lambda, you have 1 million requests per month. Now, after these limits are crossed, you get charged standard rates.
With GCP, you get access to all cloud platform products like Firebase, the Google Maps API, and so on. You also get $300 in credit to spend over a 12-month period on all the cloud platform products. And interestingly, after the free trial ends, you won't be charged unless you manually upgrade to a paid account. Now, there is also the always free version for which you will need an upgraded billing account. Here, you get to use a small instance for free and 5 GB of cloud storage. Any usage above this always free usage limits will be automatically billed at standard rates.
Now let's talk about how you can configure instances. With AWS, the largest instance that's offered is of 128 CPUs and 4 TBs of RAM. Now, other than the on-demand method like I mentioned before, you can also use spot instances. Now, these are for situations where your application is more fault tolerant and can handle an interruption. Now, you pay for the spot price, which is effective at a particular hour. Now, these spot prices do fluctuate but are adjusted over a period of time.
The largest instance offered with Google Cloud is 160 CPUs and 3.75 TBs RAM. Like spot instances of AWS, Google Cloud offers short-lived compute instances suitable for batch jobs and fault-tolerant workloads. They are called as preemptible instances. So these instances are available at 80% off on-demand price. Hence, they reduce your compute engine costs significantly. And unlike AWS, these come at a fixed price. Google Cloud Platform is a lot more flexible when it comes to instance configuration. You simply choose your CPU and RAM combination. Of course, you can even create your own instance types this way. Before we wrap it up, let's compare on some other things as well. Telemetry. It's a process of automatically collecting periodic measurements from remote devices. For example, GPS. GCP is obviously better because they have superior telemetry tools which help in analyzing services and providing more opportunities for improvement.
When it comes to application support, AWS is obviously better since they have years of experience under their belt. AWS provides the best support that can be given to the customers.
Containers are better with GCP. A container is a virtual process running in user space. As Kubernetes was originally developed by Google, GCP has full native support for the tool. Other cloud services are just fine-tuning a way to provide Kubernetes as a service. Also, the containers help with abstracting applications from their environment they originally run in. The applications can be deployed easily regardless of their environment.
When it comes to geographies, AWS is better since they have a head start of a few years. AWS in this span of time has been able to cover a larger market share and geographical locations. Now, it's time for the big decision. So, who's it going to be?
Yeah, who is it going to be? GCP or AWS?
I think I'm going to go for choosing the right cloud computing platform is a decision that's made on the basis of the user or the organization's requirement. On that note, I believe it's time for us to wrap this video up.
We hope you guys enjoyed this video and learned something new.
That AWS is better, right?
No, that choosing a platform entirely depends on you and your organization's requirement. If you're interested, you could also go through the AWS versus Azure video.
AWS, Azure and GCP are three of the world's largest cloud service providers. But how are they different from each other? Let's find out. Hey guys, I'm Rahul and I'll be representing Amazon Web Services.
I'm Chinmayi and I'll be representing Microsoft Azure.
And I'm Shruti and I'll be representing Google Cloud Platform. So welcome to this video on AWS versus Azure versus GCP.
Talking about market share, Amazon Web Services leads with around 32% of the worldwide public cloud share.
Azure owns up to 16% of the worldwide market share.
And GCP owns around 9% of the world's market share.
Let's talk about each of these service providers in detail. AWS provides services that enable users to create and deploy applications over the cloud. These services are accessible via the internet. AWS, being the oldest of the lot, was launched in the year 2006.
Azure, launched in 2010, is a computing platform that offers a wide range of services to build, manage, and deploy applications on the network using tools and frameworks.
Launched in the year 2008, GCP offers application development and integration services for its end users. In addition to cloud management, it also offers services for big data, machine learning, and IoT.
Now let's talk about availability zones. These are isolated locations within data center regions from which public cloud services originate and operate. Talking about AWS, they have 69 availability zones within 22 geographical regions. This includes regions in the United States, South America, Europe, and Asia Pacific. They are also predicted to have 12 more additions in the future.
Azure, available in 140 countries, has over 54 regions worldwide grouped into 6 geographies. These geographical locations have more than 100 data centers.
GCP is available in 200 plus countries across the world. As of today, GCP is present in 61 zones and 20 regions, with Osaka and Zurich being the newly added regions.
Now let's talk about pricing. These services follow the pay-as-you-go approach. You pay only for the individual services you need for as long as you use them without requiring long-term contracts or complex licensing. Now on screen, you can see the pricing for each of these cloud service providers with respect to various instances like general purpose, compute optimized, memory optimized, and GPU. Now let's talk about the compute services offered. First off, we have virtual servers. For AWS, we have EC2. It is a web service which eliminates the need to invest in hardware so that you can develop and deploy applications in a faster manner. It provides virtual machines in which you can run your applications.
Azure's virtual machines is one of the several types of computing resources that Azure offers. Azure gives the user the flexibility to deploy and manage a virtual environment inside a virtual network.
GCP's VM service enables users to build, deploy, and manage virtual machines to run workloads on the cloud.
Now let's talk about the pricing of each of these services. AWS EC2 is free to try. It is packaged as part of AWS's free tier that lasts for 12 months and provides 750 hours per month of both Linux and Windows virtual machines.
Azure Virtual Machine Service is a part of the free tier that offers this service for about 750 hours per month for a year. The user gets access to Windows and Linux virtual machines.
GCP's VM service is a part of a free tier that includes micro-instance per month for up to 12 months.
Now let's talk about Platform as a Service or PaaS services. For AWS, Elastic Beanstalk is an easy-to-use service for deploying and scaling web applications and services developed with Java, .NET, Node.js, Python, and much more. It is used for maintaining capacity, provisioning, load balancing, auto-scaling, and application health monitoring.
The PaaS backbone utilizes virtualization techniques where the virtual machine is independent of the actual hardware that hosts it. Hence, the user can write application code without worrying about the underlying hardware.
Google App Engine is a cloud computing platform as a service which is used by developers for hosting and building apps in Google data centers. The App Engine requires the apps to be written in Java or Python and store data in Google Bigtable and use the Google query language for this.
Next, let's talk about virtual private server services. AWS provides Lightsail. It provides everything you need to build an application or a website along with the cost-effective monthly plan and minimum number of configurations.
In simple words, VM Image is a more comprehensive image for Microsoft Azure virtual machines. It helps the user create many identical virtual machines in a matter of minutes.
Unfortunately, GCP does not offer any similar service.
Next up, we have serverless computing services. AWS has Lambda. It is a serverless compute service that lets you run your code without facilitating and managing servers. You only pay for the compute time you use. It is used to execute backend code and scales automatically when required.
Azure Functions is a serverless compute service that lets you run event-triggered code without having to explicitly provision or manage infrastructure. This allows the users to build applications using serverless simple functions with the programming language of their choice.
GCP Cloud Functions make it easy for developers to run and scale code in the cloud and build event-driven serverless applications. It is highly available and fault-tolerant.
Now let's talk about storage services offered by each of these service providers. First off, we have object storage. AWS provides S3. It is an object storage that provides industry standard scalability, data availability, and performance. It is extremely durable and can be used for storing as well as recovering information or data from anywhere over the internet.
Blob storage is an Azure feature that lets developers store unstructured data in Microsoft's cloud platform. Along with storage, it also offers scalability. It stores the data in the form of tiers depending on how often data is being accessed.
Google Cloud Storage is an online storage web service for storing and accessing data on Google Cloud Platform infrastructure. Unlike the Google Drive, Google Cloud Storage is more suitable for enterprises. It also stores objects that are organized into buckets.
Amazon provides EBS or Elastic Block Store. It provides high-performance block storage and is used along with EC2 instances for workloads that are transaction or throughput intensive.
Azure Managed Disk is a virtual hard disk. You can think of it like a physical disk in an on-premises server but virtualized. These managed disks allow the users to create up to 10,000 VM disks in a single subscription.
Persistent storage is a data storage device that retains data after power to the device is shut off. Google Persistent Disk is durable and high-performance block storage for GCP. Persistent Disk provides storage which can be attached to instances running in either Google Compute Engine or Kubernetes Engine.
Next up, we have disaster recovery services. AWS provides a cloud-based recovery service that ensures that your IT infrastructure and data are recovered while minimizing the amount of downtime that could be experienced.
Site recovery helps ensure business continuity by keeping business apps and workloads running during outages. It allows recovery by orchestrating and automating the replication process of Azure virtual machines between regions.
Unfortunately, GCP has no disaster recovery service.
Next, let's talk about database services. First off, for AWS, we have RDS or Relational Database Service. It is a web service that's cost-effective and automates administration tasks. Basically, it simplifies the setup, operation, and scaling of a relational database.
Microsoft Azure SQL Database is a software as a service platform that includes built-in intelligence that learns app patterns and adapts to maximize performance, reliability, and data protection. It also eases the migration of SQL Server databases without changing the user's applications.
Cloud SQL is a fully managed database service which is easy to set up, maintain, and administer relational PostgreSQL, MySQL, and SQL Server databases in the cloud. Hosted on GCP, Cloud SQL provides a database infrastructure for applications running anywhere.
Next, we have NoSQL database services. AWS provides DynamoDB, which is a managed, durable database that provides security, backup and restore, and in-memory caching for applications. It is well known for its low latency and scalable performance.
Azure Cosmos DB is Microsoft's globally distributed multi-model database service. It natively supports NoSQL created for low latency and scalable applications.
GCP Cloud Data Store is a NoSQL database service offered by Google on the GCP. It handles replication and scales automatically to your application's load. With Cloud Data Store's interface, data can easily be accessed by any deployment target.
Now let's talk about the key cloud tools for each of these service providers. For AWS, in networking and content delivery, we have AWS Route 53 and AWS CloudFront. For management, we have AWS CloudWatch and AWS CloudFormation. For development, we have AWS CodeStart and AWS CodeBuild. For security, we have IAM and Key Management Service.
For Microsoft Azure, networking and content delivery, we have Content Delivery Network and ExpressRoute. For management tools, we have Azure Advisor and Network Watcher. For development tools, for management, we have Azure Advisor and Network Watcher. For development, we have Visual Studio IDE and Azure Blob Studio. For security, we have Azure Security Center and Azure Active Directory.
For GCP, we have the following tools. For networking and content delivery, we have Cloud CDN and Cloud DNS. For management, we have Stack Driver and GCP Monitoring. For development, we have Cloud Build and Cloud SDK. And finally, for security, we have Google Cloud IAM and Google and Cloud Security Scanner.
Now let's talk about the companies using these cloud providers. For AWS, we have Netflix, Unilever, Kellogg's, NASA, Nokia, and Adobe.
Pixar, Samsung, eBay, Fujitsu, EMC, and BMW, among others, use Microsoft Azure.
So as seen on your screens, the companies that use GCP are Spotify, HSBC, Snapchat, Twitter, PayPal, and 20th Century Fox.
Let's talk about the advantages of each of these services. Amazon provides enterprise-friendly services. You can leverage Amazon's 15 years of experience delivering large-scale global infrastructure, and it still continues to hone and innovate its infrastructure management skills and capabilities. Secondly, it provides instant access to resources. AWS is designed to allow application providers, ISVs, and vendors to quickly and securely host your applications, whether an existing application or a new SaaS-based application. Speed and agility. AWS provides you access to its services within minutes. All you need to select is what you require and you can proceed. You can access each of these applications anytime you need them. And finally, it's secure and reliable. Amazon enables you to innovate and scale your application in a secure environment. It secures and hardens your infrastructure. More importantly, it provides security at a cheaper cost than on-premise environments.
Now talking about some of the advantages of Azure. Microsoft Azure offers better development operations. It also provides strong security profile. Azure has a strong focus on security, following the standard security model of detect, assess, diagnose, stabilize, and close. Azure also provides a cost-effective solution. The cloud environment allows businesses to launch both customer applications and internal apps in the cloud, which saves on IT infrastructure costs. Hence, it's OpEx friendly.
Let's now look at the advantages of GCP. Google bills in minute-level increments, so you only pay for the compute time you use. They also provide discounted prices for long-running workloads. For example, you use the VM for a month and get a discount. GCP also provides live migration of virtual machines. Live migration is the process of moving a running VM from one physical server to another without disrupting its availability to the users. This is a very important differentiator for Google Cloud compared to other cloud providers. GCP provides automatic scalability. This allows a site's container scale to as many CPUs as needed. Google Cloud Storage is designed for 99.9% durability. It creates server backup and stores them in a user-configured location.
Let's talk about the disadvantages of each of these services. For AWS, there's a limitation of the EC2 service. AWS provides limitations on resources that vary from region to region. There may be a limit to the number of instances that can be created. However, you can request for these limits to be increased. Secondly, they have a technical support fee. AWS charges you for immediate support, and you can opt for any of these packages. Developer, which costs $29 per month, Business, which costs more than $100, and Enterprise, that costs more than $15,000. It has certain network connectivity issues. It also has general issues when you move to the cloud, like downtime, limited control, backup protection, and so on. However, most of these are temporary issues and can be handled over time.
Talking about some of the disadvantages of Microsoft Azure. Codebase is different when working offline, and it requires modification when working on the cloud. PaaS ecosystem is not as efficient as IaaS. Azure Management Console is frustrating to work with. It is slow to respond and update and requires far too many clicks to achieve simple tasks. Azure Backup is intended for backing up and restoring data located on your on-premises servers to the cloud. That's a great feature, but it's not really useful for doing bare metal restores of servers in a remote data center.
Let's now look into the disadvantages of GCP. So when it comes to cloud providers, the support fee is very minimal, but in the case of GCP, it is quite costly. It is around $150 per month for the most basic service. Similar to AWS S3, GCP has a complex pricing schema. Also, it is not very budget friendly when it comes to downloading data from Google Cloud Storage.
And today we're going to talk about AWS certifications. So what exactly is an AWS certification? It represents a degree of expertise in AWS. It is obtained after passing one or more exams provided by Amazon, and each different role, like the SysOps administrator, developer, or solutions architect, has a different exam associated with it. This in turn helps employees demonstrate and validate technical cloud knowledge, which means that the people who are certified actually know what they're talking about. I have seen a common misconception among people where they believe that just because they're certified, they're entitled to a job. That's not true. Now, without proper practice or hands-on experience, the certification is wasted on you. So remember, just because you're certified does not mean you'll get a job. It only makes the job application process slightly easier relative to someone who's not been certified. Now, why is AWS given so much importance? Some of the important reasons are: an AWS certified individual gains credibility for their skills in AWS. They also gain access to free practice exams which help them prepare for their next AWS certification. There's an increase in monetary compensations, which only means that they get paid more, and you gain recognition for your knowledge and skills in AWS. Right now we're in the AWS certification website, whose link will be in the description, and now we're going to talk about the types of AWS certification. As you can see here, there are 3 levels of AWS certification. There's the foundational level, associate level, and professional level certification. Now, the foundational level certification only requires you to have a basic understanding of how the AWS cloud works. The AWS Certified Cloud Practitioner is optional for the architect path, developer path, and operations path. It is mandatory for the specialty certifications like the advanced networking, big data, and security certifications. Now, the associate level certifications are mid-level certifications for a technical role. Now, a professional certification is the highest level of certification that you can have for a technical role. Now, you have the solutions architect for the architect path and the DevOps engineer certification for both the developer and operations path. So how do you decide which of these certifications is suitable for you? So you've seen here that AWS provides various certifications for a number of job roles like SysOps administrator, solution architect, developer. So you need to make the right choice, taking into consideration the areas of your interest and the experience level that you have. Now we're going to talk about each of these certifications in detail. So first, let's talk about the AWS Certified Cloud Practitioner. Now we all understand that AWS is a widely recognized product in the market. So this certification helps you validate how well you know the AWS cloud. So this is just the basic understanding. Now, it is optional for the developer path and the operations path. I would suggest it's a good idea to start here because it forms a solid bedrock on all the other things that you're going to learn soon. Now, more importantly, it does not require any technical knowledge of other roles such as development, architecture, administration, and so on. So it's a great place to start for newcomers. Now you have the architect role certifications. Now, this is for you if you're interested in becoming a solutions architect or a solution design engineer or someone who just works with designing applications or systems on the AWS platform. Now, first we have the AWS Certified Solutions Architect Associate Level Certification. Now, this certification is for you if you want to show off how well you can architect and deploy applications on the AWS platform. Now, it is recommended that you have at least a year of experience working with distributed systems on the AWS platform. At the same time, it's also required that you understand the AWS services and be able to recommend a service based on requirements. You need to be able to use architectural best practices, and you need to estimate the AWS cost and how you can reduce them. Next up, you have the AWS Certified Solutions Architect Professional Level Certification. Now, you will not get this certification unless you're done with the AWS Certified Solutions Architect Associate Level Certification. This is to show off your technical skills and experience in designing distributed applications on the AWS platform. Now, this does require you to have 2 years of experience working with cloud architecture on AWS. At the same time, it also requires you to be able to evaluate requirements and then make architectural recommendations. You also need to provide guidance on the best practices on architectural design across a number of different platforms. The developer level certifications are for you if you're interested in becoming a software developer. Now, the AWS Certified Developer Associate Certification is to test how well you know how to develop and maintain applications on the AWS platform. It does require you to have a year or more of hands-on experience to design and maintain AWS-based applications. Like any software developer role, it is necessary that you know in depth at least one high-level programming language. It's also necessary that you understand the core of AWS services, uses, and basic architectural best practices. You need to be able to design, develop, and deploy cloud-based solutions on AWS platform, and you need to understand how applications can be created. You need to have experience in developing and maintaining applications for a number of AWS services like Amazon SNS, DynamoDB, SQS, and so on. Now for the AWS Certified DevOps Engineer Professional Level Certification. Note here that this certification is exactly the same as the one you have under the operations role. So both of them are the same thing. So here it tests your ability to create, operate, and manage distributed applications on the AWS platform. Now it is necessary or it is mandatory to have the AWS Certified Developer Associate Certification or the AWS Certified SysOps Administrator Certification with 2 or more years of hands-on experience in doing the same in AWS environment. It requires you to be able to develop code in at least one high-level language. You need to be able to automate and test applications via scripting and programming, and to understand agile or other development processes. The operation certifications are for you if you want to become a SysOps administrator, systems administrator, or someone in a DevOps role who wants to deploy applications, networks, and systems in an automatable and repeatable way. The AWS Certified SysOps Administrator Associate Certification tests your knowledge in deployment, management, and operations on the AWS platform. Now, you need to have 1 or more years of hands-on experience in AWS-based applications. You need to be able to identify and gather requirements, then define a solution to be operated on AWS. You need to be able to provide guidance for the best practices through the life cycle of a project as well. Now, the specialty certifications are for you if you're well versed in AWS and want to showcase your expertise in other technical areas. The AWS Certified Big Data Certification showcases your ability to design and implement AWS services which can help derive value from a large amount of complex data. You are, however, required to have completed the foundational or associate level certification before you can attempt this. You need a minimum of 5 years of hands-on experience in the data analytics field as well. Next, we have the AWS Certified Advanced Networking Certification. This validates your ability to design and implement AWS solutions as well as other hybrid IT network architectures at scale. This also requires you to have completed the foundational or associate level certification. You need to have a minimum of 5 years of hands-on experience architecting and implementing network solutions. And lastly, we have the AWS Certified Security Certification. It helps showcase your ability to secure the AWS platform. You're required to have an associate or cloud practitioner level of certification, a minimum of 5 years of IT security experience, and 2 years of hands-on experience securing AWS workloads. Now, say I wanted to schedule an examination. So, for example, I want to do the Solutions Architect certification. So first I would go there. Now, here I can click on Register Now and the process continues, or I can click on Learn More. By doing this, again, I can schedule the examination here. I can also get access to other data like the number of questions available, the cost of an examination, the portions I need to study, and so on. Now let's talk about the Solutions Architect certification with a little more detail. Now this certification exam costs $150 and the practice exam costs $20. Now here I can schedule the examination or download the exam guide. I've already downloaded the exam guide and here it is. Now this exam guide tells you about what you need to learn and what is expected from you. Here they want you to define a solution based on requirements and provide guidance in its implementation. It is also recommended that you know about how the AWS services work, 1 year of hands-on experience with distributed systems on AWS to identify and define technical requirements and so on. The rest is available in the exam guide. And most importantly, they tell you the main content domains and their weightages. Now we have 5 domains. First domain is to design resilient architectures, which holds 34% of weightage. Domain 2, you have to define performant architectures. 3 is to specify secure applications and architectures, cost optimized architectures, and 5 to define operationally excellent architectures. Now, like you've seen here, you've selected one certification and learned it in detail. You can do the same for any of these other certifications. You can press learn more and download their exam guide and learn everything that you need to know. And welcome to the session on AWS certification. In this session, I'll be telling you about several things like why AWS is so important. Next, we'll talk about the job roles in AWS, the career path to become an AWS solutions architect, the certifications that are available in AWS, and companies that are hiring in 2020. Also guys, if you have any questions regarding the topic or AWS, let us know in the comment section below. Our team of experts will help you as soon as possible. Now, before we get on to this, let's talk about why or what exactly is AWS. AWS, or Amazon Web Services, is a cloud computing platform that offers more than 175 different services across several domains. Now, among these several cloud service providers in the market right now, like Microsoft Azure, VMware, Rackspace, and so on, AWS is more commonly used than any of its competitors. But what makes AWS so special? Why must you get certified by them? So to answer our earlier question, let's have a look at 2019's third quarter's cloud market share, which is provided by Canalys. Now, AWS dominated the cloud service market share with 32% of the entire share, and it had a growth of over $2.3 billion year over year. Now, you can see in the graph here that Azure and GCP only account for 17% and 7% respectively. The others, like Rackspace and IBM Cloud, are contributing 44%. Now, if you do need more convincing as to choosing AWS, let me give you more reasons why. Firstly, it provides pay-as-you-go pricing, which means you only pay for how much you use. Now, you use what you need, and then the costs are scaled automatically and accordingly. Now, for example, say you use EC2, which provides virtual machines. You only use for how much virtual machines you've created and how long you use them. AWS is also very secure. Now, this provides end-to-end privacy and security and storage. AWS also has experience. Now, AWS has over 4 years of leg up over other cloud service providers like Microsoft Azure. This means over the years, they have skills and infrastructure management that can give you more. Next, AWS is also very flexible. This allows users to select their operating system, language, database, and other services with great ease. AWS is also very easy to use. You can host your applications very quickly and securely, whether it's existing or a completely new application. AWS is also extremely scalable. Now, if you're a small scale company, you don't need a lot of resources. AWS understands that and scales down. If you're a larger organization, obviously you're going to need a lot more resources. AWS can help with that as well. Now, let's talk about the job roles within AWS. Now, here are some of them. These aren't all of them, but we have AWS Cloud Architect, SysOps Administrator, Cloud Developer, System Integrator, Cloud DevOps Engineer, Solutions Architect, Network Specialist, and Big Data Specialist. Now, getting each of these roles becomes much easier when you're certified by AWS. Now, let's talk about the steps you need to take so that you can become an AWS Solutions Architect. Now, we're selecting this one because this is one of the most common and talked about job roles in AWS. Now, most of the job roles I mentioned earlier have similar steps, but with a few steps added or removed somewhere else. Now, first off, you need an understanding of operating systems. You'll need to have a basic understanding of operating systems like Windows or Linux. Now, although this isn't exactly mandatory, this will help you understand cloud services better since most of them are based on Linux. Next up, you need to have experience with programming languages. Languages like SQL, Go, Python, C#, .NET, and so on will help you develop cloud-based applications based on requirements from your organization. Now, although this isn't mandatory either, some services do require coding so that you can use them properly. In the next step, we have networking. You need to understand networking fundamentals like virtual networks, local area networks, wide area networks, networking models, and so on. Now, this is really important because this will help you understand how the back-end infrastructure of the cloud works. After that, the most self-explanatory step, learn AWS. Now, you need to focus on learning the different services that are offered by AWS. Now, AWS provides a year-long free tier where you get access to several important services like EC2 and S3. So you can use it to get practical experience with these services. Now you can decide among several different career paths that are offered by AWS. Paths like Cloud Practitioner, Cloud Architect, Cloud Developer, Operations, DevOps Engineer, and some others. And finally, you need to be certified by AWS. You need to choose from different levels of certification that are provided by AWS. These can help you showcase your proficiency in working with different AWS solutions. Now let's talk about certifications available in AWS. Now, as you can see on screen, there are 3 levels. 4 actually. Firstly, you have foundational level certification that includes the Cloud Practitioner certification. Now for this, you need to have 6 months of basic cloud knowledge and industry knowledge as well. So basically, the Cloud Practitioner certification acts as the starting point for just about every other job role you want to take, be it architect, operational, or developer. Then in associate, you need to have a year of experience working with AWS Cloud, solving solutions and implementing solutions. You have options for solutions architect, SysOps administrator, developer, and so on. And finally, you have professional level certification. Now, after 2 years of experience with the AWS Cloud, you can take up this certification. You have options of Solutions Architect Professional and DevOps Engineer Professional. Now, there are certain specialty certifications that are provided by AWS. These are based on advanced networking, big data, security, machine learning, and Alexa Skill Builder. Now, let's have a look at AWS's website. Let's go to Google, search AWS certification. And here you can see that, like I told you, here are the certifications. Let's go to the bottom here. And you can see that here all the certifications that I mentioned are divided into different levels. Like I told you, Cloud Practitioner, Architect, Developer, Operations, and DevOps Engineer. Let's have a look at Cloud Practitioner. So here you can see the steps you need to take to become a Cloud Practitioner. Now, AWS suggests that you take up their course and then follow it up by taking their certification test. Now, similarly, let's have a look at how to become an AWS Cloud Architect. You can select the link here. So like we saw with Cloud Practitioner, they give you a set of courses you need to take, followed up by a certification test. Basically, you need to first get the associate level certification and then move on to the professional level certification after you've gotten some experience and knowledge. Similarly, you can look at other job roles like developer, very similar, and operations. Likewise, everything else you can see here. Now let's go back and talk about the companies that are hiring in 2020. So this is basically every company that's hiring in 2020. So you have examples like IMDb, Lamborghini, Adobe, Bitdefender, HTC, and so much more. This is just the tip of the iceberg. Hi guys, this is Rahul from Simplilearn, and today I'm going to tell you how you can become an AWS Solutions Architect. So who is an AWS Solutions Architect? Now, the main role of an AWS Solutions Architect is to help you deploy your applications on the AWS platform. Now, this is nothing but a cloud computing platform. So it's not to say that you can't deploy your applications on the cloud computing platform yourself. It's just that when it comes to organizations, the applications that you need to deploy become a whole lot more complex. That's where an AWS Solutions Architect can help. Ever since cloud computing became a thing, companies around the world have started migrating their physical infrastructure onto the cloud. That's what an AWS Solutions Architect does. They help you migrate your physical infrastructure onto the AWS cloud. Companies around the world work on a budget, and an AWS Solutions Architect will help design a cloud infrastructure based on the organization's budget. Before that can be done, however, an AWS Solutions Architect has to create a design with an intricate and detailed blueprint of the cloud infrastructure that they plan to set up. Now, AWS Solutions Architects also have to focus mainly on non-functional requirements like usability, reliability, scalability, and performance of the cloud infrastructure. They're also responsible when it comes to minimizing risks that an organization can face when it comes to cloud computing platforms. Now, they could face risks like security leaks, calculation mistakes, and application downtimes. An AWS Solutions Architect has to ensure that these don't happen. Before we can talk about how you can become an AWS Solutions Architect, I have some exciting news for you guys. We've launched our own YouTube community. You'll get to see a lot of quizzes, polls, offers, and much more to make your learning experience a whole lot more fun. You can find all of this on your subscription feed, or you can also click on the top right corner right now to get started. And let's get back to how can you become an AWS Solutions Architect. Now, to become an AWS Certified Solutions Architect, you need to clear the AWS Certified Solutions Architect Associate Level Examination. Now, here's some details about it. The exam score ranges from 100 to 1000 marks, and the minimum passing score is 720. However, there's a catch. The passing marks are actually set using statistical analysis, so they can be changed based on how difficult the examination actually is. The exam fee is $150, and you can also take a practice examination which costs $20. Now, regardless of the examination you take, be it Solutions Architect, SysOps Administrator, or Developer, any associate level examination costs $150. For the professional level examination, it's $300. Now, if you want to learn more about the AWS certifications, I suggest you click on the top right corner and watch our video AWS Certifications in 10 minutes to learn more. Now, the exam duration is of 130 minutes, and you have two types of questions: multiple choice and multiple answer. Now, the multiple choice questions have 4 options, out of which one of them is right, and you have multiple answer where you have 5 options, out of which 2 of them are correct. You can take the examination in English, Japanese, Korean, and simplified Chinese. Now, let's talk about how you can schedule an examination. First, let's go to Google and search for AWS Certifications. Click on the first link. So on this page, we can go to the bottom and find the different certifications AWS provides. Click on Architect and select the AWS Certified Solutions Architect Associate Certification. Click on Register Now. And here you need to click on the AWS Certification account. You can sign in with your Amazon account or create a new one. I already have an Amazon account that I'll be using for signing in here. In case you don't, you can click on the Create Your Amazon Account button here and create an account for yourself. Now, after that is done, you can schedule a new examination. And you can scroll down to the bottom here, AWS Certified Solutions Architect Associate Level Certification. Click on Schedule Exam, press Continue, and here you need to select your language, which I'm assuming is English. I'm from India, so I don't need to change anything here, but you can change your country or time zone and other details based on your requirement. And select your preferred month. I want to do it in October. Now select Search for Exam Center. Select the one that's closest to you. I'm going to select this one. And here you can select the day that you want to take your test and the time available. I want to do it on the 15th. I select the time that I want and press Continue. Now you can go through all the details here, change them if you want to, otherwise you can press Continue. After this is done, close. And here we have the final step, which is the fees. You can enter your details here and pay now to finish the process. Now let's look at an outline of the exam content. Now what you're going to see in the exam are 5 major domains, and here you have each of the domains with their respective weightages. First, you have at 34% designing resilient architectures. At 24%, you have both defining performant architectures and specifying secure applications and architectures. At 10%, you have designing cost-optimized architectures, and at 6%, you have defining operationally excellent architectures. Now let's look at each of these domains in detail. Now, the first domain, or design resilient architectures, can be divided into 4 parts. Firstly, you need to know how you can choose reliable or resilient storage using services like AWS S3, AWS Glacier, and AWS EBS. Then you have how you can design decoupling mechanisms using AWS services. Now this is possible with the help of AWS SNS. Now these aren't the only services that enable this, these are just some of the services. Then how you can design a multi-tier architecture solution. Now this is important because you need to know how you can create a solution that involves several other services. Then you need to know how you can design highly available and fault-tolerant architectures. Now for the second domain, defining performant architectures. First, you have how to choose performance storages and databases. Services that are used are AWS RDS, AWS Redshift, and AWS DynamoDB. The second step is how you can apply caching to improve performance. A service that can be used for this is AWS Elastic Cache. Third, how you can design solutions with elasticity and scalability. You have AWS Lambda, AWS CloudWatch, and AWS Data Pipeline. Now, for the third domain, which is specifying secure applications and architectures, you need to know how you can secure applications using services like AWS Inspector, AWS CloudTrail, and AWS IAM. You need to know how to secure data using Cloud HSM and AWS Macie, and how you can define the networking infrastructure using CloudFront, VPC, and Elastic Load Balancer. For the fourth domain, you have designing cost-optimized architectures. Firstly, you need to know how you can design cost-optimized compute solutions. You can use AWS EC2, Elastic Beanstalk, Lambda, and AWS Lightsail. Then you need to know how you can design cost-optimized storage solutions using AWS S3, Glacier, EBS, and Elastic File System. And the final domain, to define operationally excellent architectures. You need to set up design features and solutions that enable operational excellence. Now, some of the features are that you perform operations as code, you annotate documentation, you make frequent and small reversible changes, and anticipate and tackle failures. Now, let's have a look at the job opportunities when it comes to AWS Solutions Architects. Now, if you have a look at this graph, you can see that AWS has always provided a lot more job postings as compared to the other two giants in the cloud computing domain, which are Microsoft Azure and Google Cloud Platform. Now, if you do a little bit of research, you'll find out that there's a significant lacking of experienced personnel when it comes to AWS. So I would suggest this is the best time for you to get certified in AWS. So how can Simplilearn help you with your AWS certifications? Now we're on the Simplilearn homepage. And here we have the AWS Solutions Architect course. On this course, which is the AWS Solutions Architect Certification Training course, we have 36 hours of instructor-led training, 20 hours of self-paced learning, 16 live demos, 3 simulation exams, 3 hands-on practice projects, and so much more. Here, our main emphasis is on making sure that you have enough hands-on experience with the services that you crack the examination at your first attempt. So here we also go through some of the more important services that you need to learn, like IAM, VPC, EC2, S3, and so much more. We'll also talk about databases, application services, security practices, disaster recovery, and so on. We even have practice examinations to help you prepare for the real one.
If you are looking to become an AWS Cloud Architect to excel your career, then have a look at AWS Cloud Architect Masters program by Simplilearn. With this certification course, you will learn architectural principles, scalability, security, and key components like S3 and CloudFormation. Become expert in the tools like Amazon EC2, AWS Lambda, Amazon DynamoDB, Amazon CloudFormation, and much more. Our AWS Cloud Architect training is great for beginners. However, AWS recommends at least 1 year of relevant experience before pursuing this program. So hurry up and try your hands on this amazing course. Use discount coupon YTBE15 to get handsome discount. Find the course link in the description box. If you are looking to learn cloud computing Enroll into Professional Cloud Computing program in Cloud Computing and DevOps by Simplilearn and gain hands-on experience with industry projects. 1 year experience is preferred to grab the course. Find the course link in the description box.
Welcome to another video by Simplilearn. Today, I am going to help you understand how to pass the AWS Cloud Practitioner exam. So, let's get started. Before we get started, let us look at today's agenda. First, we will go through what is AWS Cloud Practitioner and its eligibility criteria. Then we will go through the exam objectives and its exam content. Further, we will learn how to prepare for the exam and look at a few sample questions. And finally, we will learn a few tricks related to the exam. Now, what is AWS Cloud Practitioner? AWS has a variety of certifications. Under foundational level comes AWS Cloud Practitioner. Going up, we can achieve professional and advanced level certificates. AWS gives a variety of specialty certificates, which is something very unique. It is a foundational level certificate provided by AWS. It requires 6 months of AWS cloud and industry knowledge. Becoming an AWS certified cloud practitioner is recommended. It is an optional step towards achieving an associate level or specialty certification. With the cloud practitioner certificate, you can get a job as a cloud engineer or AWS practitioner in many companies. Now, let us talk about the eligibility criteria. Every exam has its own eligibility. In order to take this certification, the candidate must follow 2 important criteria. First, he should have at least 6 months of experience working with AWS cloud concepts in various roles like technical, sales, and finance. Next, it is mandatory for him to have knowledge of the AWS cloud platform and its working. Also, he should know about the various IT services. Now, let's talk about the exam overview. The exam duration is 90 minutes. The candidate should get 65% of the answers right in order to pass the exam. The question types are multiple choice and multiple response questions. The cost of this exam is $100. Every certificate is valid for a few months or years. AWS Cloud Practitioner is valid for 2 years. After 2 years, this certificate needs to be renewed, as in, the exam needs to be taken again. Let's get into the exam objectives now. The AWS Cloud Practitioner validates the candidate's strength in various domains. First, he should be able to explain the cloud knowledge and its platform. He should know how to manage the account. He should know about the billing and pricing details. The candidate should have knowledge of key services available on the AWS Cloud Platform. The candidate should be able to explain the various cloud values. The candidate should be able to explain security concepts, security model, and compliance concepts. The candidate should recognize the main sources of technical assistance or documentation. The candidate must be able to explain the key features of operating and deploying in AWS Cloud. And finally, he should be able to explain the cloud architecture and its basic principles. In order to excel in this exam, we should know the topics that occur in the exam. So, let's take a look at the exam content. The exam has 4 major domains, namely cloud concepts, security and compliance, technology, and billing and pricing. The pie chart indicates the weightage of each domain in the exam. The cloud concepts contain 28% of the total exam content, security and compliance contains 24% of the exam content, technology has the maximum weightage of 36% of the total exam content, and billing and pricing has the lowest weightage of 12% of the entire exam content. Now, let's dive deep into each of these technologies. First comes cloud concepts. In this, you need to have some basic knowledge of cloud computing concepts. Questions asked from this field are broad enough. So to perform well, you must have high-level cloud concepts which include elasticity, scalability, high availability, and fault tolerance. Next, we have security and compliance. Security is marked as an important topic of whether you are working with infrastructure or not. This certification exam includes a variety of questions related to security and culpable management. You may find some important topics regarding this domain in your exam as follows: shared security model, cloud logs, DDoS protection, and IAM, that is, managing users, password policies, and MFA. The next domain is technology. Technology is the most important domain of the AWS Cloud Practitioner exam. If you want to adapt in this section, then you should have the knowledge of core AWS services. Some of the AWS services that you must know are EC2, ELB, RDS, S3, SNS, and AWS Lambda. And finally, we have billing and pricing. The AWS Certified Cloud Practitioner exam concentrates on the business applications of AWS. Billing and pricing becomes important topics that we should know. You must have knowledge of general account information, AWS support, how certain services are built, how to calculate the cost of services and using what tools, etc. There may be some questions which overlap with other exam domains. Example, AWS cost calculator service may fall into billing and pricing domain as well as technology domain. Now that we know the domains, let's go ahead and see how to prepare for the exam. The first thing is we have to start off with the AWS training classes. The following 3 AWS training courses will help you pass the exam. That is AWS Cloud Practitioner Essential, AWS Technical Essentials, and AWS Business Essentials. Moving forward, the next step is to read the AWS Certified Cloud Practitioner Certification Exam Guide. This guide would give an idea about the essential areas that needs to be concentrated on. It provides an overview of all the exam objectives with preparation instructions. The next step is to get familiar with the subject areas. Before taking any exam, knowing the subject areas is very important. The exam content has been explained before, so review the subject areas carefully, plan and prepare how to attempt the test accordingly. Moving forward, we have to go through the AWS white papers. These white papers contain useful information and cover many important topics. Some of the popular AWS white papers are Overview of AWS, how AWS pricing works, maximizing value with AWS, and many more. Self-study is enough to pass the certification exam. The online training will help you understand the subject areas. A lot of material can be found on the AWS website. Also, read the facts related to the AWS cloud services, applications, and moreover architecture. The next important step is to examine sample questions and take free tests. To ace the exam, a practice test is always necessary to see where you stand and what subjects you need to concentrate on. AWS has many practice tests and you can take them before the exam. The final step is to schedule the exam and get certified. So once you're prepared well enough, then enroll for the exam, choose any testing center near you at AWS Training website and register yourself. Going forward, let's look at few of the sample questions that AWS website has. So all these questions are present under the AWS website, so you can go through them. Now, the first question is, why is AWS more economical than traditional data centers for applications with varying computing workloads? So you can see the answer choices on the screen. The correct answer is Amazon EC2 instances can be launched on demand when needed. The next question is, which AWS service would simplify migration of a database to AWS? The choices are AWS Storage Gateway, AWS Database Migration Service, Amazon Elastic Compute Cloud, Amazon AppStream 2.0. So the correct answer is AWS Database Migration Service. The next question is, which AWS offering enables customers to find, buy, and immediately start using software solutions in the AWS environment? So you can see the answer choices on the screen. The correct answer is AWS Marketplace. Which AWS networking service enables a company to create a virtual network within AWS? The choices are AWS Config, AWS Route 53, AWS Direct Connect, Amazon Virtual Private Cloud. The correct answer is Amazon Virtual Private Cloud. Which of the following is AWS's responsibility under the AWS Shared Responsibility model? So the options are configuring third-party applications, maintaining physical hardware, securing application access and data, managing custom Amazon machine images. So the correct answer is maintaining physical hardware. The sixth question is, which component of AWS global infrastructure does Amazon CloudFront use to ensure low latency delivery? The choices are AWS Regions, AWS Edge Locations, AWS Availability Zone, Amazon Virtual Private Cloud. The correct answer is AWS Edge Locations. So the seventh question is, how would a system administrator add an additional layer of login security to a user's AWS Management Console? The answer choices are use AWS Cloud Directory, audit AWS Identity and Access Management roles, enable multi-factor authentication, enable AWS CloudTrail. So the correct answer is to enable multi-factor authentication. The next question is, which service can identify the user that made the API call when an Amazon Elastic Compute Cloud instance is terminated? So the options are Amazon CloudWatch, AWS CloudTrail, AWS X-Ray, AWS Identity and Access Management. The correct answer is AWS CloudTrail. The next question is, which service would you use to send alerts based on Amazon CloudWatch alarms? The options are Amazon Simple Notification Service, AWS CloudTrail, AWS Trusted Advisor, Amazon Route 53. The correct answer is Amazon Simple Notification Service. And finally, the last question is, where can a customer find information about prohibited actions on AWS infrastructure? So the correct answer for this is AWS Acceptable Use Policy. So you can see we get sample questions like these. You can go through the website and see all the other preparation and exam guides you need. Finally, the last topic in this video is the tips while taking the exam. Since the time is limited, wasting time on difficult questions is unavoidable. The next tip is to keep a track of time and learn how to manage time to answer all the questions. Third one is analyze the questions first and then answer, because sometimes they may be traps. And finally, as per the guidelines, some questions may have multiple answers, so read the questions properly and choose the answers carefully.
Hello everyone. In today's session, we are going to talk about AWS best practices. So this is the agenda for today. We will talk about billing best practices. We will have a look at best practices for EC2, which is the Amazon Elastic Computer Cloud. We will walk through best practices for IAM, which is Identity and Access Management. Then we will walk through the best practices for S3, which is Simple Storage Service. And then we will have a general look at the security best practices from the Amazon account perspective, as well as from the general Amazon Web Services perspective. Now let's start with billing best practices. So billing essentially is the core of every company. Every company wants to keep billing to the minimum and cost to the lower side. So one of the best things about Amazon is that it gives you a good way of controlling your costs. So from the billing specific side, from the billing console side, there are a lot of things you can do as a best practice and also reduce cost. So Amazon gives you something called billing budgets. Now this is interesting. So they give you an option to actually create a budget kind of thing wherein you specify you want X amount of dollars for the next budget. Now, whenever you hit that budget, let's say it's $200, you get an email notification. Now, these budgets can be service specific. They can be specific to some service like EC2. So if you want to have a billing alert when the EC2 instances of the account hit almost $200, you can create that. One of the other best practices from Amazon billing side is to give limited access to IAM account users to billing. So, by default, Amazon does not allow billing access to IAM users. But you can specifically allow them if you have got some users who look at the billing perspective of your account. Now, if you have a bill which crosses $10 to $15 and it's not possible to pay using a single credit card or debit card, Amazon gives you an option to pay using multiple credit cards. So as a best practice, if your bill has crossed a big amount and you are not able to pay using a single credit card, if you are a good enterprise, it's always good to have 2 or 3 credit cards added to your account, so that even in the case when your one card can't fulfill the bill, you can have another account which automatically lets you pay the bill. So that way you don't risk your infrastructure. Your infrastructure is always safe. Now, one of the other best practices is to have regional taxation enabled in your account. For every country, there's a different taxation regime, and the tax methodology and tax rates are different. So instead of getting a notice from your income tax department, or to avoid being non-compliant to taxes, it's the best practice to have the billing number. So every country has the specific unique billing number, which you can put into the Amazon account, and then it automatically charges that or files taxes from Amazon's behalf on that number. So at the end of the year, when you are doing tax filing, you can easily show that you have paid X amount of money from Amazon. So you don't have to repay that, or if in your country the tax is collected at the end of the year in a consolidated way, you are more compliant. Now let's say that an enterprise which has got multiple accounts in Amazon Web Services. So let's say for Project A, you have a different account. For Project B, you have a different account. So you can consolidate the billing of those if you don't want to have a headache of having multiple account billing. You don't want to have to separate credit cards for every account. So what you can do is you can consolidate the billing of each and every account into a single account. That would essentially give you a single consolidated bill. So you can also consolidate your taxes there. In that case, you can have a single cooperate credit card, which can have a lot of limit. There are credit cards which give you no limit virtually, so you can use those kind of credit cards. Now, coming to EC2 best practices. One of the best practices from EC2 side is AMI hardening. So Amazon gives you Amazon machine images, which are exact snapshots of servers. Now, these machine images are used to spin up new machines. So these are like seat files for new servers. Now, you just can't have a stock OS image and use that as a base for your entire infrastructure. You need to have a hardened AMI. Now, when I say a hardened AMI, what I exactly mean is to have an AMI which has got all the security practices implemented into it. Now, as far as the Linux OS is concerned, An AMI which is hardened would have the SSH port changed, SSH password-based logins disabled, security enhanced Linux set to enabled if it's CentOS. If it's Ubuntu, maybe you can enable the firewall and only allow port 22. The next thing is VPC port lockdown. So apart from the instant level firewall port lockdown, you should also lock down ports specifically to IP addresses. If not possible to IP addresses, then at least you should make sure that in your VPC, all the security groups have got only the specific ports which are required by that server or application open to specific IP addresses. If you have to open something up to the entire world, make sure that you have got adequate checks PPP inside your application, so you don't have a malware user trying to do DDoS service attack. Although Amazon has got a required hardware in place to check the DDoS attack. But yes, there can be still valid amounts of attacks that go into your application if you don't plan the application correctly. One of the other things you should take care when you are running instances on EC2 is that you have private subnets for everything other than the load balancer or the web application tier. Now, this is important because you don't want anyone to be directly able to access your rediff, CCC, your database, or your internal backend systems. Because most of these systems, for example, let's say rediff, don't have authentication built into them. So if you have the port exposed, anyone can go in and pull all the keys. Now, from an application division perspective, you should make sure that the application is divided into small microservices. So it used to be known as Service-Oriented Architecture, SOA. Now the term has changed and people call it microservice architecture. So the basic idea behind microservice architecture is that big monolithic applications are divided into small chunks of application, which are exposed over as a service to the internet to the end users. Now this helps you to scale them individually, and one of the best advantages you get out of such a microservice architecture is that even if one of the applications is down, the others can actually still function without affecting this one. Now, this is very important because in today's e-commerce world, a single minute of downtime can cost millions of dollars of loss. So when you have microservice architecture, you can scale vertically or horizontally each microservice without worrying about downtime. You should take care while designing microservice architecture so that the microservice architecture is independent at every level. One of the mistakes which happens is that you have a microservice architecture at the web server or the application server layer, but then you have a common database. So how is it going to affect the microservice architecture in any way? I understand that it's very difficult to have independent database microservice architecture. But yes, there are companies who do sync ups of databases just to make sure they have totally independent microservices. Now, in such a scenario, even if the backend database of a particular microservice is down, the other functionality can work. Take an example. Let's say there is login functionality which talks to the backend database and gets to data from there. Let's say there is another functionality which lets you buy stuff. Both of them should have independent databases, and there should be a sync up every minute. Or there should be push-based mechanism where there is sync up only when they're in one of the DBs. Now, if you have both these microservices having independent databases, your logins will still work even if your payments are down, or your payments will still work if your login functionality is experiencing some degraded performance. You have stock images on Amazon, that Amazon provides you environment-based key or keys which are there for every instance. So every machine you launch on Amazon has got a key. You can't just use the username and password to log in. Now the advantage of key is that you don't have to provide clear text passwords, but you have to make sure that for every environment, so let's say you got a production environment QA test environment, make sure every environment has got a different key. The reason is if you have a single key across all the environments, and let's say you give a developer access to one of the environments, he can automatically gain access to each and every environment. So that's not a good thing, right? You don't want developers to access production environments. Now, if you have 100 EC2 instances and you have users to manage, let's say you should make 10 users are there on every machine, which are 10 members of your dev team. So it's very difficult to create manually. Let's say you also want to do password expiry and a lot of intelligent stuff on these users. You can actually use something called LDAP. This LDAP is basically centralized authentication system, which lets you authenticate users across machines. So you can change the password for a user on one LDAP server, and it's reflected across all the machines. So let's have a look at IAM best practices. So IAM is Identity and Access Management Service of Amazon, and it allows you to have fine-grained controls over the access. Now, as a best practice for your teams, you should have various roles defined. Each of those roles should be specific to what each member is doing. Let's say you have a read-only dev role assigned to your developers. You can also have DevOps Engineer role, which you assign to your DevOps engineering team members. You can assign roles to the finance team, which has billing access. Now, this gives you the flexibility to easily assign policies or attach policies to various users without having to manually do them. This is useful in a scenario wherein you have a custom role, wherein you have a reporting engineer which needs access to billing to create reports of CPU utilization. Now, you can give them a specific access by assigning specific policies. You can have new joinees or freshers who have joined your team have a read-only access, so that way they don't mess up the account, and they also have got full access to the account. So they can go and they can see what the environment's like. They can read, but they can't change anything. So that way, you safeguard your account by any accidental mistakes by those freshers or new joinees. You can have service-specific access. So let's say you have an EC2 instance, which requires access to S3 buckets, so you actually create a role in IAM and assign that specific role to EC2 instances. You can also have special service-specific roles. Now, these service-specific roles have got access to specific service of Amazon. And you can use this, let's say, in case you want to give some developer access to some dev environment of Elastic Beanstalk. So you can create a role which has the access and the policies attached for Elastic Beanstalk read-only access to that specific region. So that way, you can control a specific service and specific action. Now, let's have a look at S3 best practices. S3 is Simple Storage Service, and it's one of Amazon's most important services. It's one of the most used services as well. Now, in case of S3, you should make sure that you have context-specific names. Now, these names can be the type of function that S3 bucket is performing. So let's say images, and then -dev, and then -region, and then -top-level domain. So you have a unique name. So Amazon has a policy wherein they have a single namespace for all the S3 buckets of the world, which in other words means that if you have a name which is already chosen by someone in the world of an S3 bucket, you will not get that name. So obviously you will have to have long names since all shorter names would have been taken. In order to make that long name meaningful, make sure you break that into a specific context so that when you look at that bucket, you already know this is what this bucket is doing. You should make sure you have bucket policies for buckets, which are accessible by other users. These policies can be generated in the policy generator, or you can create fine-grained self-made policies. For buckets which are very much live and large and have got tons of data, you should archive them to Glacier, because Glacier gives you very cheap storage, although there is a retrieval time associated with that. But yes, you should make sure to archive the buckets. So if you've got some critical objects in a bucket, you should make sure that you also save a version of your object, because you can go back to a previous version of that same object. Now in this case, you don't actually lose any version of that file. You always have the important version of that object. From security best practices, never share your root account details with anyone. Because if someone has got root account details of your account, he can actually do anything. Make sure people who leave your organization, you remove their access, and you don't keep them as stale accounts. You should also enable two-factor authentication, either with Google Authenticator or some hardware device access token, which flashes a 6 or 4-digit random number, so that it can be added as an added layer of security. You also should enable IAM login, don't give root access to even trusted users. So in IAM, you have a name and an ID, which shows you that this guy did this at this time.
So here we wrap up this full course. Feel free to ask questions in the comment section below, and our experts will be happy to help you. Stay tuned with Simplilearn for more such videos. Thanks for watching.
Hi there, if you like this video, subscribe to the Simplilearn YouTube channel and click here to watch similar videos. To nerd up and get certified, click here.